Hello. Hello. Yeah. So, all right. Welcome you all again to the second day of this ISCLS. Now, unfortunately, due to certain reasons, there is a change in the schedule. So, I will announce the changes in the schedule. You may not be able to remember it, but we are updating it in the website, and we'll see. So, essentially, the invited talk by Kutumba Shastri Mahoday, that has been shifted to the afternoon at 5 o'clock. Okay? And therefore, we are bringing in 2 talks from session 6 now and 1 demo from session 5 onwards. So we will start with this Sanskrit teaching annotation and research tool. There is a full paper there and then a demo of about the same topic. That we will start with these 2. Then we will have a demo by Ronit Kumar on this shiva.sh, a platform to study Sanskrit literature. And then we will continue with this. So the tea break will be half an hour later, but I hope that should not matter a lot. Okay, so thank you all. We are updating it on the website, so you can go to the website and check it, but please just note these changes. Okay, thank you.
Okay, Suprabhatam. Shri Ram, Jai Ram, Jai Jai Rama.
Not audible. Hello, hello.
Am I audible?
Yeah.
Hello. Yeah. The second day of this symposium. So now I invite Anil Kumar and Ambakulkani and Nakka Shailaja. Their paper is on Start Sanskrit Teaching Annotation and Research Tool, Bridging Tradition and Technology in Scholarly Exploration. So you have 20 plus 10 minutes.
Hello, can you hear me? Yeah. So, thank you for giving us an opportunity to present our work on the latest tool, START. It is the Sanskrit Teaching Annotation and Research Tool. It's an exploration to bring the tradition and technology together. We are all familiar, we have been talking about the wisdom that exists in Sanskrit texts. And despite being it centuries old, there is an overgrowing interest we see in understanding these profound texts. And in order to understand these texts, several computational tools were developed by various groups, research groups. And these tools are being used by students. But then we found that just these tools are not enough. People are interested in reading certain texts such as Bhagavad Gita or Upanishads or Mahabharata, etc. So they needed a kind of e-readers. And such one e-reader was one reader which was very in a friendly manner. It was published by Rashtriya Sanskrit Sansthan a few years ago by which was edited by Professor Kutumba Shastri ji. When I saw that book, in that book the shloka was given, Sankshepa Ramayanam shloka was given, then its Padacheda and then Anvaya, Samasa, Vicheda, Padaparichaya, and translation in other languages were given. And then when I saw that book, I immediately thought that this can be put in a better way in electronic form, and during that time, Anil helped me in bringing it in a e-reader format. So we had this first e-reader way back in 2007, which was a book converted into an electronic format so that we can access, hide and show the information, access the information at various levels. So that was a kind of interactive display. Then we thought we should have such e-readers for other texts as well. And we continued developing e-readers for texts such as Bhagavad Gita, etc. These e-readers, the information that was available was something which was very useful as a gold data for the researchers. And then, how to go back? Okay. And then we noticed that suppose now I need to develop a new e-reader, there are some limitations in the existing tools. In fact, we did some experiments. It was during the COVID time. We were teaching Sanskrit using the computational tools. And at that time, we had given some shlokas to students for analysis purpose. And okay. So we had given some shlokas to the students for analysis purpose, and then we noticed that the students were finding it difficult to use these tools to create a kind of annotated text for a given shloka. So by annotated text, I mean given a shloka, they were supposed to do the sandhi vichcheda, they were supposed to do the samasa analysis, and then also the karaka analysis, etc. And all this analysis is to be presented in a format which is similar to co-NLL format. So people were finding it difficult to place it in a proper format, etc., because the tools were not that user-friendly. Teachers were also trying to use these tools, but they were not happy because they wanted few extra features in these tools. The user interface. So I am talking about now only the user interface. The backend tools are working fine, but the user interfaces are not friendly enough for teachers, friendly enough for annotators. They were not friendly enough for the Indology researchers or even the computational linguists who would like to use such gold data for any further purpose. And this was the motivation behind building these tools. So we needed a new platform. We looked at various platforms that are available for other languages also. There are various platforms like Gate and many others are there. You can see the list in our paper. We looked at all those existing platforms which are there for developing the annotated data for any particular language, natural language. And we noticed that these are not good for Sanskrit. Because in Sanskrit, what we also want is not just one analysis, but multiple analysis in certain cases. If the shloka is, if there is a shlesha in the shloka, or it is also possible that at the back end, if we have a machine and machine makes some mistakes, then we need to have a kind of system where user can correct those, annotator can correct those by just bringing in looking at the other possible analysis that machine has produced. Typically, all the existing computational tools for other languages, they produce only one analysis. Whereas here we are producing all possible analysis, and we want users to select from those analysis instead of asking the user to give his own analysis. We prefer him to select from the existing analysis. So we wanted a platform which is good for annotation, which is, and once this is annotated, the data is annotated, we would like to build e-reader automatically out of it. And also we wanted it something good for teaching purpose also. So from all these points of view, we decided to go for a new architecture where we will have Samsadhani and Heritage Platform as the backend. The SCL tools is a misnomer, it is an API. The APIs will be here. So we have the Samsadhani and Heritage Platform, here are the APIs. They are at the backend, and we have the interface where there will be a dashboard for annotators, dashboard for teachers, there will be a content management system, and there is a user management, and dashboard for Indologists. At present, still this is not developed, so we will not talk anything about it, but about the user management, content management, and the dashboard for teachers, we will talk about these. I think instead of explaining the features like this, it's better if we give a demo. So Anil will give a demo for this.
Yeah, so for accessing Start, this is the home page, and if you want to access this, you need to use this URL. URL is scl.samsadhani.in/start. If you will type that much, it will open. And here you may need an email address and a password as a username. And at present, we have not opened it for publicly, but if you want to access it, you have to write us a mail. We will make it. We will give you credential, and then you will be able to use it. So here internet is little bit slow. Yeah. So after giving login and your credential, this page will be opened, and here on your left side, left panel, you will be able to see user management, encoding management, content management, SCL tool. SCL means Sunset Computational Linguistics Tools, my work, my group, and logout. So these options are available. And if you want to, why we have given the user management? Because we have tried to develop it such a way you can use it in your classrooms, in your school, colleges, wherever you want to use it. That's why we have given the user management system also. So using user management system, you can, if you click here, you will be able to see, you can create a user. Suppose if you are teaching, you are using as a teacher, then you can create logins for your students, for your teachers also. And we have given also encoding management. Using encoding management, you can select the encoding, input encoding and output encoding. Suppose your input is in Devanagari. If you want to use Devanagari, then just you select Devanagari. And if you want to see the output also in Devanagari, then you can select it. And using content management system, you can give the data. So suppose if you want to create an e-reader on Ramayana, then you need to come here into the content management system. And if your source is not available here, then using this option you can create a source. That, for example, Ramayana is not here in this my list. You just click, you come here and type Ramayanam and add source. So immediately this will be appear here. And using these options, you can add the data. So here, plus button you have to click for adding the content. If you will click here, immediately this window will appear. Here you may need to provide chapter number like 001 and the shloka number, like my shloka is 1 or 2, whatever number if you want to use, you can use. Now I need a content. For example, I have taken, I will take this example like this. I am copying it. And here you need to provide 2 lines if in case of shloka. Ma'am? Yeah. Yes. I hope you will be able to see now. So after adding the line 1, line 2, or if you want, you can add this second line in line 1 also. So both the ways are possible. Then click add shloka. So now your content is ready to use the SCL tool. After that, you need to go to the SCL tool option, and here you will be able to see these options. For creating e-reader, you need to click on e-reader dashboard, because dashboard will provide you editing, modifying, or the deletion options. When you will click on, let me show it. You need to click here. When you will click here, you will be able to see select server. So actually, our current server is deployed now to different machines. So these options will be okay. So default will be our UH server, and then input encoding and output encoding will be there. In input encoding, you again the same options you will be able to see here for output encoding also. Now you need to select the source. So here I have added Ramayanam. Select that. Yeah, because just a minute. Let me check whether I have added it. Yeah, I need to delete this. Yeah, so now when I clicked on Ramayanam, immediately chapter number will appeared, and then your shloka number. So this way I added this shloka there, and here 2 parameters are required, like segmenter and text type. If you don't want to use any segmenter, automatic segmenter, just keep it none, and you need to give the prose type, like whether your input is shloka or prose. So our input is shloka, then you need to select this shloka. And here you will be able to see the original shloka in this form. And now it will ask for sandhi splitting. So here you can provide the sandhi splitting manually, or you can use our tool also. So if you want to get the sandhi splitting automatically, you need to click get sandhi split. See, after clicking this, automatically it is splitting. And here we are using Professor Gerard Huet's system. Now you need to provide the sandhi splitting like this, Vakya Vidam Varam. You need to check it once. And we have given also the Anvaya option. At present, we are not doing it automatically, so you may need to provide it manually. But for the time being, I'm using the same text as it is. And after that, you need to click on the show analysis. Yeah. So here you will be able to see the output, the response like this. You can see here Tapa, Swadhyaya, for these words analysis are like this. And again, okay. Yeah. And these analyses are coming from the Samsadhani platform. As madam told that we are using API in the back end. So when we click on show analysis, it goes to the Samsadhani platform and heritage platform. And from it process there, and whatever response it gets, it brings here. And it shows like this. Now here, one more thing I would like to add, that these fields are editable. So suppose if you want to change these values, you can change. In case, because every time machine will not bring the correct output. There may be some mistakes also. So those can be rectified here itself. And here, in Karaka Sambandha, if you will click here, you will be able to see the possible relations also. So machine has decided one Karaka relation. If it is not correct, so you can use possible relations for correcting it. So in this case, I don't know whether it is correct or not. Let us see the graph, because after seeing the graph, you will be able to know whether the given output is correct or not. You just click here. It will bring this graph. Now, if your graph is looking correct, there is no mistake, you can just directly go to the save analysis. If it is your graph is not correct, you can come again to this feature and you can select the relations if the relations are not correct. So in here I'll change this. Suppose this is Tapasvi is not Visheshanam of 7.1, it is Karta of 6.1. It is not here, but in case suppose if it is there, then just you click here and click again show graph. Then this graph will change. So this way you can correct your graph also. So I'll put it again, Visheshana. Now you need to save it. Because if you will save it, then it will go to the database. Your database will be stored automatically. Why? Because as I showed you here, so for this, we are saving the data into database. So I will show you that also. Let me save it. So now my data is stored into database. Now if you want to see the Sanskrit e-reader, it will be available there. Just go to your source. It will look like this. Then click your shloka, because I have added only one shloka, so it is showing only one shloka. And now it is bringing all the analysis here. So there are two options. I'll show you. This is for the data entry. So you will give the data, you will provide the content, it will go to the Samsadhani heritage platform. It will bring all the response to you. You will correct it, you will save it into database. And here using this, you can use the ready-made database, ready-made e-reader. And this can be used for teaching in the classrooms, in your schools, classes, etc. So that way two options we have put. This is the dashboard, this is the e-reader. So now I'm showing you the ready-made e-reader. Using these features, you can show and hide, you can expand this window size also. And here, if you want to hide some features, you can hide like this. So you can minimize also the window size. Okay, now we need it because we need to generate the chart. And again, if you want to see the chart, you can see here. Now we have given two views, Anusaraka view and normal view. See, Anusaraka view you are already familiar with. Now this is something new one. If you will click here, automatically this interface will be changed. And here if you will click, the expansion windows they will be appeared. And this can be used as an annotation also. Okay. Now I'm coming back to this. And or we have given also encoding options. Suppose if you want to see the whole output into IAST, we just click here. Then go to the Ramayanam. Then click here. Now whole whatever things you have saved into database now will be appeared in IAST. If you click on show parser, it will also be available in IAST. So this way you can use encoding options also. Now I'll come back to the other resources, SCL tool. Now here, whatever tools you have seen in Samsadhani, so those tools are available here also, but we have developed little bit further, like we have just updated some versions like Sandhi. And for Sandhi, now you will be able to see like this. So my input is Lakshmiman Shubha Lakshmanaha. For this it is showing 4 output, Lakshmiman Shubha Lakshmana, Lakshmiman Shubha Lakshmana, like this. And here some show and hide features are given. Using this you can teach to your students. Suppose you are teaching in the class and you want to explain how this prakriya is working, you just click, open it one by one. Click, so this is the spelling of Lakshmiman, and this is the spelling of Shubha Lakshmanaha. Then the student will understand it clearly. Oh, this way Sandhi is being taught. And if you will click on Prathama Padasya Antima Varanaha, so automatically it will show the last word of this, last letter of this word. And if you will open it, then it will show the first word of this word. This way we can teach students how Sandhi, we do the Sandhi, etc. And finally you can show the Sandhi word here. So this way you can use Sandhi. And same, whatever API is being used in Samsadhani, same API is being used here. Now for Sandhi splitter, we have improved something more. So now Sandhi splitter, you can use 3 ways. You can give a word, you can give a sentence, complete sentence, and you can give a text in bulk also. So if I'll take the example from Samshek Rapayana like this. Tapasvadhyaya Nirata. So you will be see the output like this. Or if you want to use the text options, now go to the I'm copying this. So we need to remove the so this way it will provide you the Sandhi splitting on your right side. So this can be used for further processing. This data can be used. Or if the Sandhi splitting is not being done correctly, you can correct it here itself. And you can use for your research purpose. And also we have given, there are many options also which are similar to the Samsadhani. You can explore it. Now we have given also my work. So whatever work is being done by me, so you just click here, you will be able to see when I have done this work, what I have done this. And you can also create the groups. This group feature we have added for teaching purpose. Suppose you are a teacher and you want to take the class and you want to give some assignment to your students. So you just create a group, add your students, and give them work. They will work here. Whatever they will be doing. You can monitor them. For example, I have created a group, Samskritam, and in this group, I have added Shailaja, Sri Ram, and Vani Shri Madam is there. And what Shailaja has done, you just click on her email. So she has done this much, when she has done, and whatever she is doing, you will be able to track that also. But for that option, we need to work little more. I think in coming time, we will add that option also. So this way you can use group and then log out. So this is what I wanted to show. Yeah. So for developing this tool, we have used Angular 13 version, and for CSS framework, we have used Bootstrap. For backend purpose, we have used CGI and Flask. And whatever graph you are seeing, so for that we have used GraphFace. And for database purpose, we have used MongoDB.
Well, so so you have seen the demonstration. And we will also provide one guest login so that you can use what is there. You cannot you cannot give your text and do the annotation, etc. But whatever e-readers are available and whatever other tools are available, those you can have access to. But in case you want to develop some e-readers or use it for teaching purpose, then you need to write to us. We will provide you the email, the login credentials, and then you can use it. What we, why we have developed this is, there are, as I, in the beginning itself I told you, first of course the ease of management for creating the annotated data, etc. Second is, once it is available in a uniform format, for the computational linguists, for researchers, this will be a very good source, because now you will have all the analyzed data available in uniform format, which can be used for various purposes, for developing the neural network models, for various tools, etc. So we can use these for large language models once we have huge amount of data available. And if all the teachers in Sanskrit universities start using it, I'm sure we will have huge data available, and then it will be easy for us to build the, use the LLM for building good, better tools. So cooperation and collaborative platform. That's it. I will stop here. I would like to thank the generous financial support we got from the University of Hyderabad under the Institute of Eminence, which helped us in developing this platform. So, any questions? So,
Presented your paper and you have already shown the demonstration. Now the floor is open for discussion.
Thank you. Very, very good work. The Sandhi thing is actually very important. And, but I just wondering, see, where there is Prakriti Bhav Sandhi, where actually Sandhi is prevented, that I found to be the hardest to understand myself and to teach. So there, what will the interface show? The two things are coming, but there is no Sandhi happening.
Well, at the back end, we are using Gerard Hewitt's Sandhi splitter.
Okay, so he can answer.
Yeah. So, well, Prakriti Bhav will be kept as Prakriti Bhav. There won't be.
No,
If it is joiner, if it is splitter, yeah.
No, it's joiner. The joiner is,
See,
it
here-
prevents the Sandhi, right?
Oh, see, you
Where
are
you-
talking about the joiner or segmenter?
Joiner.
Joiner,
Huh.
okay. So, for joiner, you can give a demonstration for Sandhi. Give me one example of Prakriti Bhava.
Thank you.
Okay, thank you.
Yes, please.
Kavi Dirgha. Eto. Okay? This is Prakriti Bhava. There is no change.
Okay. All right. So, yeah, and just one more, two more things. First is, you are not showing what the Sandhi is actually.
Yes,
right?
it is there. Sandhi rule is there. Yeah.
No, in that interface you are not showing that.
No,
this
no,
is-
it is there.
Oh,
There
okay,
are
okay.
three options. Basic.
Okay.
You tell about these.
Yeah, okay, fine.
So Sandhi
Correct.
can be used in three options: basic, intermediate, and advanced.
Oh, advanced.
So if you go to the advanced option, you will be also see the sutra also.
Okay, all right. Thank you very much. Yeah.
So essentially, these are pedagogical tools. So basic is for school children, advanced is maybe for high school students and college students, and those who are doing BA, MA, maybe they can also have the precise rule and Again, these sutras are linked to ashtadhyayi.com. Here in this, we have not shown, but the Sausadhani website, it will take you to the ashtadhyayi.com so that you can see all the commentaries, Kashika, and whatever you want to see. Everything is available.
Great. So for the collaboration, you are using your own tool, and why not GitHub collaboration, all those things, where you want to check what others have done, what your collaborators
Right now only ours are plugged in, but we can provide, because this is just plug-in we have to provide.
Okay.
If any other API is available, we can provide that.
Okay.
So right now for Segmentor, only one API we have, Gerard Hewitt's, which we are using. Okay.
Okay. Thank you. Very, very, very interesting. Thank you.
Sanskrit corpus is not just isolated works. It's got the commentarial tradition, which is very important. And so if you want to have a lasting tool for investigating Sanskrit corpus, you have to accommodate commentarial data, and this means you would have some kind of reflexive capability of the system, be able to validate your own interpretation in light of the commentarial text, and conversely, you could think also of synthesizing commentary of a text that you have finally analyzed. So did you have some thought about the design of such a system?
No, not yet thought of, because we are busy in fixing some of the problems, and even for Indologies the things are not yet ready. We wanted to have a search engine first, and then we will go for the commentaries, because search engine is something which is very important, which can search on these data and provide you whatever information you need. That search can be on morphology or Karaka Vishleshana or on word forms, or I want to just know where this sloka is, in which text. I would like to get that information. So we are planning for that at the present. After that we will think of the commentaries.
Thank you, Ambaji. This is a very nice presentation. I have two questions. One from annotator's dashboard point of view. So when I am annotating, say a Karaka and all, and I understand this is not the correct one which has come from the system, but I want certain help to decide which one would be a better. So such kind of interactive, such kind of intelligence, like maybe I can see similar kind of thing which has been done. So maybe when you do the indexing of your database, and from there you get the similar kind of things that is there already in your data, I can check that and I can decide, and then...
Yeah, good. So that kind of search facility I was talking about for Indologists, even for annotators this will be useful. Right.
Yes.
Yeah. But what we are providing right now is what are from the grammatical point of view, what all possible relations are possible. Those relations we are displaying, and then you can select one among them. We are not displaying all the relations. There are some 40 relations, but in that given context, grammatically what are feasible things? Only those relations we are displaying, and then user can choose among them. So we ensure that the grammaticality is maintained. Of course, there are few bugs, like when you make the changes, after that again we need to do some vanity checking. That vanity checking is not done at present. So
it goes to the database right now?
Yeah, right now it goes directly to the database, which is wrong. It should do some vanity checking. For example, when Anil gave the demonstration and he changed Visheshana to Karta, there were two Kartas. Two Kartas are not possible. So such vanity checking we need to add, because here it's not now again going back to the APIs. It's doing at the database level, and therefore we need to add that layer of vanity checking there, which we will add.
point of view, so like this reader is for the readers who already know Sanskrit. But if a reader like me still wants to read, so are you planning to add some other language facility also, kind of accessor through another language?
Yeah. So, so we are working on English to Hindi and English to Tamil, Sanskrit to Hindi, Sanskrit to Tamil and Sanskrit to English machine translation systems. Not English, Telugu is there. Telugu, Marathi, Hindi are there. So, and Tamil is also in plan. So, we will provide the meanings at word level, and in the graph we can show that meaning along with the Sanskrit word. So from the dependency graph with the translation, you can then understand the whole
Translation?
Yeah. Of course, translation we are working on, but our aim is not the translation. Our aim is understanding. So we are just providing hint, and I do not know how, when the word is ambiguous, how to provide the meaning and all that. So we may have to provide the complete dictionary link, and there Dr. Dhaval Patel's work, where he is disambiguating the senses or aligning the senses, that will be useful. Once we disambiguate, then we can align all these senses from various dictionaries. So, but the disambiguation work has not yet done, so we will be displaying all the meanings as of now.
Thank you, ma'am. My question is that in our schools, Sanskrit books are there. So if we want to enter any new shlok to your software, so we have to enter directly a shlok, or we have to give the same grammar also regarding that, what your software shows?
No, you will be giving just shloka. Okay. Machine will produce the analysis. But somebody has to make sure that the analysis is correct before showing it to the students.
We from in our there we are giving plenty of small books, and they have very much new shloks. So my question is that directly we put the shlok and we get.
He showed how he added the Ramayanam. Similarly, okay. You can add, suppose it is lower KG, you prepare something lower KG X, school X, and then under that you can have the shlokas entered, and machine will produce the analysis, but before showing it to the students, okay. The teacher has to ensure that the analysis is correct. See, 80 to 85% okay. It will be correct. There will be some errors which we need to fix before showing it to the students.
Okay, thank you.
Any other questions? No?
Yeah. So before leaving the platform, I would like to announce that all our SCL tools are now available as mobile apps also. So you can just search for Samsadhani. They are available under Android as well as iOS platform. Search for Samsadhani and you can download it and install. We have Sandhi Joiner, Sandhi Splitter. For Sandhi Splitter, again we are using Professor Hewitt's engine, and then morphological analyzer, morphological generator, and the Dhatu Patha. These are available as of now. The Karaka Vishleshana is not there. For Dhatu Patha, Prasanna has helped us in a very interactive, reactive interface. So thank you all who have helped us in porting this to Android and iOS and yes. You just search on the Google Play Samsadhani. You type Samsadhani, you will get that one. Okay, either on Google Play or on iOS.
Okay.
Thank you.
Yeah, thank you, Professor Amma Madam and Dr. Anil for their nice presentation. And there is a general announcement. You know, those who are presenting their papers, I request them to switch off their mobiles so that there won't be any disturbance on acoustics actually. Yeah. Now we have a demo by Ronit Kumar. He'll be demonstrating his tool on a platform to study Sanskrit literature. You have 10 minutes for demonstration and 5 for Q&A.
So Hari Om everyone, and it is my pleasure to introduce Siva.sh to you. Siva.sh is a brand new platform that has been built for the scratch for consumption of Sanskrit literature and Sanskrit texts. And what you are seeing right now is available in production. So you can right now go to Siva.sh and access the website for yourself too. So I'll go through the front page and I will demonstrate the features as I go through them. So as you can see from the design itself, we have tried to incorporate the most recent features. And in our library, we already have books like Srimad Bhagavad Gita, Patanjali Yoga Sutra, Granth Samhita. We also have Ramayana, and we are now working on Mahabharata. So we have 1,500 readers already on the platform, and actually we now have more than 2,000 readers on the platform. During the past 3 days, the website has been really popular. We support many languages, and as I will show you through the demonstration, that we provide native features that I think are not available anywhere else as of now. One of our most popular features is Siva GPT. Siva GPT is an RAG, so basically we provide the resources we have to the GPT client, and it tries to formulate the answers from those. I will demonstrate Siva GPT now. So I have this simple question of who killed Jatayu. So it will take like a few seconds to come up with the answer. So meanwhile, we can continue with the demonstration. So we want to provide a platform where reading scriptures is fun. It's easy, and it makes you want to learn scriptures much more. So I'm going to show you a sample from Arjun Vishad Yoga. So as you can see, I have enabled multiple languages here. We already have a translation, user-generated translation in Hindi. We also provide machine translations in Russian, in Tamil, in Bengali, and I can also change language from here. So maybe let's say Kannada. And as you will see, it will fetch the Google translation in place for the Kannada language too. You can also customize the interface per your requirements. So maybe if you don't want the chapter list, you can remove it. If you want to increase the text, you can also do that. You can also switch the context. If maybe you are unable to read Sanskrit, you can directly read the transliteration. And this reader is built in a way that you can continuously read the scripture. So if I want to go to the next page, I can just click here, and it will show me the next page, and I can continue reading. Let's say I'm seeing too many languages right now. I can just remove the languages. And let's just keep Hindi there too. So the reader is really customizable as per your needs. We also have the ability to add favorites. So I have this interesting shlok that was quoted by Oppenheimer. Let's say I want to have this shlok in my repository. So I can just heart it, and it will automatically add that shlok to my profile. So whenever I want to research over it, I can simply go to my profile. And you can see the shlok is already there. So I have kind of bookmarked it, so I can keep coming back to it later whenever I need it. So we have what we call state-of-the-art semantic search. I think it's best if I demonstrate it. Let's say I want to find the appearance of Rama. So as you can see, it is not looking for the keywords. It is actually searching the shlok where the appearance of Rama has been described. It is doing that through vector search. We use TextAda 002 for embedding models, and as you can see, we have all the places where the appearance of Prabhu Ram has been described. I can also facet the search, so basically like if I want just the answers from Balkand, I can do that too. So it will now only focus the answers from the Balkand part of Ramayana. We also provide data visualizations and other powerful tools. So let's say if I wanted to know what is the chapter 2 versus distribution of Patanjali Yoga Sutra, I can see that too. I can also see the same for Ramayana. So I can see like Ayodhya Kand has more verses than most of them. Then I can go inside Balakand. Then I can also see like the verses distribution inside Balakand. And when I go in further, I can start reading the scriptures right away and then continue my research after that. So the purpose of making this platform is to make sure that the Sanskrit scriptures can be read from anywhere on the planet. It is all online. It has been designed with the latest technologies in mind. It is available instantly wherever you are accessing our website from. As you have seen throughout the demonstration, there are no loading pages. And one big reason for this is that we use one of the most advanced techniques for data fetching, which is used by Meta at scale, which is Relay. It is somewhat hard to get Relay in production, but on our platform, we only use Relay. So our backend is not REST, it's GraphQL. So we are already using a much more advanced backend and coupling it with the extremely performant library to get Siva.sh working. Oh, and we also have dark mode. So like many people are familiar, for most developers, dark mode is an absolute necessity. So I can simply turn on the dark mode. So now I can read the scriptures at night or whenever I want, and it wouldn't like bother me at all. So personally, I use dark mode everywhere. So I had to have it. Let me just switch it off. So we use Next.js for this website. To those who are aware of the React technologies, Next.js is as advanced as it gets. And we are using the Next.js 14, which is basically comes with App Router. So in short, we are using bleeding edge technologies to make this platform. It is used by the Washington Post and all sorts of websites. And it is, I think, by far one of the most performant web frameworks available right now. So our platform is multilingual. As I have just shown you, we provide transliterations and translations in multiple languages. For languages for which we do not have user-generated translations, we provide Google translations in place. We also have a very unique feature. I'm not sure if I can show that, but you can also hear the verse. So you can do this for all Sanskrit verses that we have on our platform. Someone like me who is trying to first understand the pronunciation, I find it really, really helpful when I'm trying to learn Sanskrit. We also have a very advanced, you could say, research platform. We use MarkDoc. MarkDoc was developed by Stripe. Stripe is one of the largest payment providers in the world. And MarkDoc authoring system is available in production in our platform. And I'll show you an example of what we are doing with it. So this is a research that was done by a person at Banaras Hindu University, and this is the Shiv Tandav Stotram. In it, he describes like who might have written the Shiv Tandav Stotram, or if we can attribute to Ravana. But as you can see, it is multilingual in the sense that there are parts of it that are in English, and then parts of it that are in Devanagari. So we have digitized it on our platform. Now when you see it, we have replaced those parts that were in Sanskrit before or in Devanagari into English. But what if you wanted to see them in Devanagari again? So it's pretty simple. You can choose Hindi. And it will change the proper nouns in place to Hindi. So this technology is also very unique to us. It is not available anywhere else. And once again, you can change the text. You also see a timeline. This is a pro feature. It is only available to editors. So we basically have a knowledge of what is happening to the system as it is happening to the system. Another thing that makes this platform really unique is in-context visual editor. I will show this editor in more details on the verses. It is a proprietary tech. I don't think it's used in many places, but it is one of the most advanced ways of editing scriptures and adding scriptures. So we call our design system Vishwakarma design system. Our intention is to be on every platform, whether be it AR, VR, or mobile platforms. Right now, we have a very performant website. You can access the website from almost anywhere, and we also have a pretty good mobile view. So if you are using it via mobile also, it should work flawlessly. So I've already demonstrated the search. Now let's see the answer SivaGPT has come up with for who killed Jatayu. So this answer was formulated by GPT-4 using the information it has in our system. And I generally find that the answers SivaGPT generates are way more accurate, and they have a lot of information that generally the ChatGPT client misses. So few of the things that I'd like to talk about the backend of the system. We are using for database Postgres, and Postgres is hosted via Supabase. We are using AWS technologies to host our database. It is edge friendly. We are also using a lot of serverless technologies to make sure that our APIs are really performant. As you can see, like even when I switch pages, there will be no lag. It's like as fast as it gets. And now I would like to briefly demonstrate the editor that we have. So this is what we call an in-context visual editor. Right now what we are seeing is a shadow copy of the website which we use for development. So as you can see, the in-context editor knows that if you are inside Bhagavad Gita, it is probably the book where you're trying to add the verses. So a lot of information is abstracted away from you. Now I have this verse here. Let me just remove some parts of it. So as you see, like whenever I remove something, it's instantly reflected on the editor. What we have seen with this editor is that even people who do not, say, have a lot of information on Sanskrit, they are easily able to add verses because the editor makes it really intuitive and kind of really user-friendly to do so. And if I save it, it will be immediately updated and put to live use all across the world. Now, when I say that it would be live is because we also use a lot of edge technologies to cache our web pages. It's one of the reasons the website is so fast. So we need to manually revalidate a page whenever, so it has successfully revalidated also, whenever a new update has been posted. And all of this is taken care for you. You don't have to manually revalidate anything. Our platform will do it for you, and as fast as it gets. So I think my time is up now, and if there are any questions, I'll be happy to take them.
Thank you, Ronit, for demonstrating the platform to read Sanskrit tests. Now the floor is open for questions.
So thank you, very good work. So the GPT, the Shiva GPT that you are using, so how have you built it? I mean, if it's not a trade secret or if it's not a this thing, I mean, just want to know.
So for the search technology, we are using a cloud provider called TypeSense. In TypeSense, you have the option to vectorize a particular field. In our case, when I was architecting the system, I knew like we had to have English translations because it has taken me 3 years to make this, and at that time, Google was not doing Sanskrit to English translations like that. So since you already have the English translation, we vectorize that data. And when you are searching it through our search, we have some trade secrets there, but it is able to find out like the kind of searches you want to do, the kind of verses you are looking for. And once our GPT client has the access to the verses where what you are looking for, it can formulate a much better answer. So it is called retrieval augmented generation. So basically we provided the verses where we think the answer lies. The GPT client looks at it. The GPT client also has a lot of worldly knowledge about what things are. And sometimes it will reject the references also. So if I put in a query that is not correct, and I'm not sure that, so it will reject the references and not answer from the references at all. So it is pretty advanced.
Right, right. So this is probably building to the next step of our own Sanskrit ChatGPT, right? So
it is coming.
Yeah.
Internally, this is version 3. And with version 4, I'm planning to add all the features that I'm seeing in the symposium today. And more advanced features will come soon.
Thank you very much. Great work, great work.
Thank you.
Yeah, thank you for the wonderful presentation, Donit. My questions are simple. One, you just removed some part of the text.
Yeah.
So if I do, as a user by mistake, how to back it up? Is there any undo
Yeah,
option
so
or
there's a
version?
Yeah, there's a strong auditing all over the system. Any change you make, we know which change you have made. So I'll go to my profile because I recently updated something. So as you can see on my timeline, I can see the changes I'm making to the system. So nothing escapes like the auditing trail. And if you have made a change that we do not like, we'll restore the change and probably inform you that don't do this.
Okay, great. And one more suggestion is, when you said for the who doesn't know how to pronounce the words properly, you have enabled that voice.
Google text to speech, yeah.
Google text to speech, but it is not as accurate as it should be.
Yeah, state of the art. Yeah.
So how? I mean.
So
do you have any other plans for that to upgrade?
I'm actively, I really love technology, so I'm actively seeking technologies that are better. So I'm well aware of the Whisper technology that OpenAI has, and they claim it's better than what we have at Google. And the entire interface is abstract, so we use all the programming principles per se to make sure that when we need to replace like a sub-module with another module, it's also really seamless. So if tomorrow it happens that the Whisper client is really good at pronouncing Sanskrit, you will see it in our platform on day one. Yeah.
Hello. If I input some Sanskrit text in your system, can I ask the question, show me all the places where Krishna is mentioned? But I don't want the Krishna black color, yes? I want Krishna.
So when you do a search, I think we can do the search right now also. So what it will try to do is try to find out where Krishna is mentioned exactly, which we call keyword search. After that, it will try to analyze whether you're looking for the god or whether you're looking for the color.
But the keyword, I mean, is it, are the two keywords different for
So if you mean to ask, are we also indexing the Sanskrit data? We are. So even if you put it in Sanskrit, give you the places where Krishna is mentioned, it will not disambiguate whether you mean to find a god or you mean to search for the color, but will try to provide you the best result it thinks you are looking for. So obviously in many advanced cases, and in this conference I'm coming to know of many edge cases also, it may not perform as well as for normal queries that I have. So I'm continuously working on that, and maybe in the future it will also recommend you whether you're looking for the god or the color. So this is also in the pipeline. Oh yeah, definitely.
Sahi Waze and Amba Kulkarni. I think Sahi Waze is going to present.
We're getting some interference from the mobile data. A cordless system. So if you're a speaker on stage, please turn off ideally switch your phone off because there's a lot of radio running to the streaming systems and all that. And in the audience, also keep your data off if you're not needing it urgently. Thank you.
Yeah, now I invite Sahi Waze to present her paper on intersentential discourse relations.
Hello. Yeah. Namaste everyone. My name is Sai Chandrasekhar Vaze and I'm from University of Hyderabad, and my topic of today is intersentential discourse relations. Next slide please. So this is a broad overview of my presentation. We will start with the introduction of discourse analysis. We will briefly see what all work has been done earlier. We will then move on to the elementary units, the units in between which we are marking the relation, and the essential factors which drive or has a clue of that particular relations. Then we will look at the comprehensive list of all the discourse relations and how to present them. The implementation and challenges. We will look at one case study for the case of disambiguation, and we'll end the presentation by conclusion and future directions. Next slide please. So we all know that discourse is a very broad term which can particularly used for a language phenomena that goes beyond a sentence. It may include intralinguistic factors such as context or genre, and also outer linguistic factors such as context or situationality, etc. For this study, we are focusing on intersentential relations. That is the relation that exhibit between two consecutive sentences, and we are trying to make a computer processable model to analyze and graphically show these relations. So theoretically speaking, there is a lot of work has been done on the discourse and Sanskrit, and a comprehensive list of that we would find in the Sanskrit syntax by Schaff and Hawk. The computational thinking was started by the work on cohesion by Halliday and Hassan. And we all know that RST and PDTB are very famous models for showing the discourse relations between various languages, and that RST and PDTB model is also, along with obviously English, it was demonstrated on various languages, not only foreign but Indian, such as Hindi, Tamil, Bangla, etc. In case of Sanskrit, there is not much work has been done on the same field. The earlier effort was started by Kulkarni and Das, along with few representational efforts on discourse relations. They tried to build an FST for Mahabhashya, where the text cohesion was handled, and then Tedalkar and Bhattacharya worked on a question-answer system. Next slide, please. So the first thought we had was to apply PDTB or RST to Sanskrit language, as were done for many other languages. But instead we choose to build an indigenous approach because of mainly three reasons. Because of our rich knowledge systems already available in the domain of Sanskrit. The first reason was because of the different theories on Shabdabodha. So Mimamsa, Nyaya and Vyakarana, all of them are they very well discuss the theories of Shabdabodha in their own perspective, and all of them deals with the coherence in their own style. Then there is a rich commentary traditions. The Bhashya or Tika already has some hints of coherence. From that we can guess the relation between two texts or two sentences. And there are three essential factors for verbal cognition: Akanksha, Yogyata and Sannidhi. These three factors were already in use to modify the to represent the dependency relation. We have extended that point we will be seeing in detail in next few slides. So the basis of this work was led by Ramakrishna Macharyulu in 2009 and Kulkarni Das in 2012. they listed out few intersentential relations with in using the indeclinables as connectives. So we can see these two figures in so sentence 1 and sentence 2 are our two entities, and connector 1 and 2 connect these two sentences. And the generic terms such as anuyogika means having a counter combining, and pratyogi means having a counterpart. So these generic terms were used for that, and the relation R shows a relation between connector 1 and 2. So there was a fluidity between so connector 1 and 2 are basically paired markers, but it was an option to omit one of them. In that case, the figure 2 would collapse to figure 1, which only has one connector. So the limitation of this stage of this work was there were only limited set of markers being discussed, and because of the generic terms, the semantic categorization was very vague, and it needed to be more specific. So next slide, please. So that's why we took up this work. So let us first discuss in which units, or what are our units in which we are marking the relation. So basically we are marking the relation between two sentences, and to decide what sentence is, we have used a Kartayana's definition, ekating vakyam, where ting refers to a finite verb form. A sentence is a unit where there is only one and one finite verb forms. So in the syntax, Sanskrit syntax by Spicer, he had listed few infinite forms who function as finite verb forms, such as tak, tavatu, pratyay, or kritya suffixes such as aniyar, etc. So that we have included in the our list of finite verb forms. That much only we have included. We can see one example. There are three sentences here which are marked by square brackets. First one is tvam ichhasi, where the finite verb form is ichhasi. Then aham tava gruhe agachami, where the finite form is agachami, and ramaha shamam vadati, where the finite form is vadati. So between first two sentences, yadi and tarhi are two paired markers which connect these two sentences, and iti is the karma dyotaka, sentential object representation. So these are three sentences between which we are focusing on first two sentences, as the yadi and tarhi being the discourse markers. Next slide, please. So let us now move on to the clues, or the three factors that essentially drive us, or that essentially decide the relation between two sentences. The primary factor being akanksha. Now akanksha means jnatum ichha, or the expectancy. We have already used this expectancy factor to decide the dependency relation within the sentence, but we found that this concept can be extended outside the boundary of a sentence. So we have used a few clues in which this akanksha can help us understand the relation between two sentences. The first one is obviously indeclinable, such as yadi tarhi yataha tataha. So Ramaha pathati tathapi parikshayam uttirnaha na bhavati. Now tathapi has a expectancy of another sentence, or the another indeclinable such as yadyapi. So the mutual expectancy establish the relationship between these two sentences. Second one is, I'm sorry, the numbers are slightly off. The second one is relative position. The positioning of the three sentences such as Ramaha pratakale uttishtati snanam karoti dugdham pitva shalam gachati, because they are placed one after the other, the consequence shows that there must be a temporal relation between them. Third one is pronoun, anaphora resolution, where saha refers to Rama, and thus the relationship between two sentences is established. And the fourth one is nature of verb. We have given an example, Naradam paripapracha Valmikihi narapungavam, and the second sentence is Shruyatam iti amantrya pradushtaha vakyam abravit. So here the verb pariprapracha or asks. So asking has an expectancy for answer. So that expectancy is being satisfied with the verb abravit in coming sentences. Next slide, please. So these factors from akanksha can be used to establish a relation. Similarly, yogyata means the compatibility of meaning. So it can refer to both linguistic and non-linguistic factors, and it plays a major role in disambiguation process. For example, let us take a example. The intersentential, that is a karak, intrasentential, that is a karaka relation, versus intersentential, that is a discourse relation. We will look at this point in further slides, so I will make a quick pass to it. Then sannidhi, because we are dealing with the consecutive sentences, that factor has been taken care of. Next slide, please. Next slide. Yes, so this is a comprehensive list of discourse relations and the corresponding markers. So, so far we have came across all these markers and we have segregated them into the relations. So succeeding or the anantara kalaha is the relation, and tataha, anantara and atha are the markers that can denote this relation. Similarly, simultaneity, collocation, similarity, cause and effect, possibility, hindrance in cause effect, antithesis, conjunction and disjunction. So these 10 relations we have identified so far. Next slide, please. So this is, for example, this is a representation which we are going with. So this is one example. Yada bharataha marge gacchati tada saha devalayam pashyati. So here are two sentences and we are marking the relation using the head word, which is a mukhya vishesha, which is a finite word, between gacchati and pashyati. So we are using a double arrow to distinguish intersentential relations from intrasentential relations, and the direction of the arrow does not show any dependency or subordination relation, but it in fact shows the arrow shows that the property which is described by the relation reside in that particular verb. So this is this way the relationship is marked, and the markers which mark the relations such as yada and tada, because they have constant expectancy for each other, they are joined with dotted line and named nitya sambandha. So this is one example for which how we are representing all the relations. For the all 10 relations and all the markers, the representation will be same. In case any of the marker is absent, then the nitya sambandha relation won't be there, but the discourse pattern of relation will be constant. Next slide, please. So we implemented 700 shlokas from Bhagavad Gita. All these relations were marked manually. The sentence boundary was also marked manually, and the shloka and sentence has many to many. So one shloka can have multiple sentences, or one sentence can be found across many shlokas. So we extracted all the discourse markers in the Bhagavad Gita, and then we unambiguous markers such as yadyapi and tathapi, which only have one meaning associated with it, they were automatically marked by machine. In case of ambiguous markers, we found there were two types of ambiguity. First is because of pronoun and the suffix. For example, yena tena or yasmat tasmat. So because of the trutiya or panchami, they can either mark a karaka relation such as apadana in case of yasmat tasmat and karana in case of yena tena, or they can mark like discourse marker or non-karaka relation such as hetuhu or karya karana in this case. So the second time is it due to the polysemy or the multiple dictionary meanings such as he and atha. We will be seeing the case of he in further slides, so I will make that a quick pass. Then this is a sample list for what we did is we extracted all the markers and relationship or the meaning associated with it, and how many occurrences are there in the Bhagavad Gita. So this is a sample list. We have the whole list in our paper. So for example, tataha is the marker, and it can mark 3 different relations such as karya, karana, apadana and anantara kalaha, and the frequency distribution is quite similar. And the markers tada and tatra only represent one relationship respectively, samana kalaha and samanadhikarana, and they have 12 and 13 occurrences of occurrences each. Next slide, please. So let us look at the case of he, where we worked on the disambiguation of the marker he. So there are 3 relations, 4 relations as per the Sanskrit Hindi Aptes dictionary, and 3 relations with Sanskrit English dictionary of Monier Williams. And Spicer lists out 2 relations where he say that he was an earlier, he was considered as emphatic marker, which is a weak, similar to weak indeed, but generally he is marked as a causal particle. And Nagesha categorically says that he is a Karana Dyotakaha. So from all the list, we for the process of disambiguation, for the process of processing, we extracted 2 primary senses. One is Karya Karanam and Sambandha. So all the other non-Karaka relation which is associated with single word, we have given them a single tag such as Sambandha. Next slide, please. So we build a heuristic algorithm based on 2 main things. First is the position of the marker he. So if it is found on the 2nd or 3rd position in a sentence, then it would be marked as Karya Karana. And if it is surrounded by pronouns and other markers such as eva, yadi, etc., then it would be marked as Sambandha, no matter at what place it occurs. So in Srimad Bhagavad Gita, we found 49 instances of Karya Karana. This is one example. Sankaraha narakayaiva kulagnanam kulasya cha patanti pitaraha yesham lupta pindo daka kriyaha. So patanti, and if we insert Sankaraha narakaya asti, then he would establish a Karya-Karan relationship between patanti and asti. And 17 instances were found of Sambandha. For example, aham hi sarva yajnanam bhukta cha prabhurevacha. So aham he emphasizes on the pronoun aham. So 2 annotators manually and independently marked these sentences. There were total 66 occurrences. We marked them manually along with the machine. And our gold standard was Shankara Bhashya on Bhagavad Gita, because in Bhashya, Shankaracharya categorically explains he as Yasmat. Yasmat is the another Karana marker. So he categorically says he Yasmat. So that we considered that Shankar Bhashya as a gold data. So we can see that machine really outperforms 2 annotators and shows very good agreement score. Next slide, please. So this is an initial effort by us to use 3 factors, Akanksha, Yogyata and Sannidhi, and make an indigenous effort towards establishing relationship between 2 sentences. Currently, we are using explicit markers as relations to establish between 2 consecutive sentences. The next step of ours would be for anaphora, and where we will be focusing on correlative pronouns such as yaha, saha, etc. And then we will look at the disambiguation by modeling yogyata, and we will also focus on verb-specific expectancies. Next slide. Thank you. Any questions and suggestions are welcome. Thank you.
Thank you, Sahi.
Yes.
Am I audible? That was a nice presentation. Now the floor is open for Q&A.
Thank you, Saeed,
Yes.
for the presentation. I have one query. In the case of yada tada, you showed this as a nitya sambandha.
Yes.
Yes, when there is explicitly mentioned, that is fine. But we have some instances where yada is only mentioned, tada is not mentioned at all. And where there is yada, tada, expectancy of tada is there. But
Yes.
where the tada is used in a completely different sense also.
Correct.
So both are being, I mean, all these cases have been considered while developing.
Not right now, as we are saying that right now we are only dealing, right, the work has been done on the cases where both the markers are present explicitly. Our next step is to find out, because there is no way to establish nitya sambandha with which we are proceeding to establish a relationship between two sentences. So that is our next step to identify that, because yada has an expectancy for tada but not in the similar case. So that is our next step.
And one more query I have. The he, which you are
Yes.
taken as an example, that he is used also as just Chando Purana. Chabai
Yes,
to he,
yes,
chabai to he.
yes.
Without any proper meaning also it is used.
Yes.
So will you add that particular aspect also?
Yes. See,
Because
he
yesterday I created a shloka. Because of the Chando thing, I
Correct.
had to include
Correct.
he there.
But in when you are describing or graphically represent, you cannot make any node be hanging. So it must be joined to. Yes, ma'am.
So right now we have considered only two meanings of he. The first one is karya karana, and there are many other meanings. One is the emphatic marker and pada purana, as you said. So to decide whether it is pada purana or not, whether it is emphatic or not, we still do not have any clues. So we just mark it as sambandha. We do not disambiguate it. And that is, once we find some clues, we can implement them. But as of now, we do not have any clues as such.
So we have used an umbrella term as sambandha for all the other relations except karya karana.
Right. So one important thing that I see is that because of this yada tada and you're using these double-edged arrows.
Yes.
Now therefore the whole parts no longer remains a tree. It is not a tree any farther,
It's
right?
a graph.
It is a graph. So basically dependency parts, trees are useful than graphs in some of the processing. So I was just wondering, maybe there is no solution, but is there a way to make it as a tree by probably using some other extra sentential information and connecting both yada and tada as to that, so that whole structure is more canonical, more tree-like?
Well, in the case of sentences, I understand there is a dependency tree. But in the case of discourse analysis, you cannot say this is mukhya visheshya. Okay? And therefore, we are not going for that. We are just showing how the various sentences are related. We do not claim that this is the mukhya visheshya. Of course, in the case of karya karana, which one is karya and which is karana, that is shown. But among them, which is a mukhya visheshya, that is not shown. That mukhya visheshya will be a kind of tatparya, and that tatparya nirnaya, today we are going to listen more about it from Professor Kutumba Shastriji.
Thank you, Sai.
Yes,
I have a very naive question. This relative correlative pronouns, these kind of constructions, are we taking them as part of discourse, or are we taking them as part of sentence? If we are taking them as part of discourse, then is there any reference from the Indian grammatical tradition literature? Which will
may I? Okay. So see, what we earlier said, that the unit of the relation is sentence. Okay. So yada and tada occurs in two different sentences because it corresponds to two different finite verbs. That's why we have named them under the term discourse, because it goes beyond the boundary of sentence. That was our idea.
So I have a further question on this. Like if I take example from Hindi because so Ram jo mera bhai hai kal aaya. Now if I break this into sentences, Ram kal aaya and jo, if it is a sentence then I cannot have jo there. I have to make it vah kal aaya. Now I feel like there is an information loss by changing jo with vah. Because jo being a relative pronoun is bringing certain more information than vaha. So,
Ma'am, these are two different factors. So, jo, vaha would come under the anaphora resolutions which we are yet to work
even
on.
jab tab, even
jab
jab
tab.
also you have to
Yes.
resolve what
Yes,
is jab.
correct. Yes. So,
See, in the case of jab, tab or yada, tada, actually there are two finite verbs. In the case of jo, kal, vah, aaya tha, there are also two finite verbs. Now, how to split them in two and what are the connectives? Let me first talk about the yada, tada part because that is comparatively easier. In the case of yada, tada, you have yada and tada as the discourse markers. And you have two sentences. So we analyze these two sentences separately, and yada and tada will join these two, showing the discourse relation.
So you are saying that they are discourse connective. I mean that is there in the literature. They have been treated as discourse markers.
See, in the Sanskrit literature, there is no term such as discourse marker. Okay. But what is there is how do we
Because
understand?
in one case it is a temporal co-reference and
Yes.
the other ways it is a personal co-reference. Like jo is a personal.
Right. So, yeah, so what you are saying is both of these are parallel
I'm just thinking.
parallel constructions. Now I need to see how the Sanskrit deals with the relative pronouns. We have not, we worked earlier, but now we still are rephrasing these from the point of view of Akanksha, Yogyata and Sannidhi. When we worked on it some 10 years ago, that time we didn't have this concept of Akanksha, Yogyata, Sannidhi, and we were looking at it purely from the computational point of view and what the contemporary computational linguists were doing. So we had implemented something, but since I'm not happy with that kind of implementation, we are again revisiting it. And for yada tada, we could find this answer, but not for the relative pronouns yet. In the case of yada tada, they are also relative pronouns. That da suffix is there, da pratyay is there, yat and tat, and to which these suffixes are added. But there we have clear-cut boundaries of the sentences. Whereas in the case of the example which you have given in Hindi, I don't know how to translate it into Sanskrit and see the corresponding things. So we may have to discuss these things later on. Right now we do not have the solution for this. Out of the four various akanshas, we have looked at only two of them. The remaining two we still have to work on.
So, yeah, I have a few observations. You have mentioned that akanksha is jnatum ichcha. The desiderative form of the jnatum ichcha is jignasa. So what is the rationale for you to say that jnatum ichcha is akanksha?
Okay, so when you, what I meant was when you say a particular word as yadyapi saha pathati, then immediately comes to mind then what. So you wish to know that what happens next. So that makes the expectancy that reader wants to know, or there is some kind of more knowledge is or more context is required in order to establish a relationship between two
So I understood the point, but the thing is, why don't you take the definitions mentioned by logicians? Padasya padantar vyatirekha anvaya anubhavagatma akanksha. That will serve the purpose separation, right? Yeah. And there are some things when it comes to the relations, you have enlisted some relations, right? Enumerated relations like samanadhikaranaha. It should be samanadhikaranam. Okay.
Okay, but the two verbs would be samanadhikaranaha, correct? The relation between them would be samanadhikarana, but the two verbs would be samanadhikaranaha because both of the actions lies on the same platform, correct?
It should be samanadhikaranam only. Samanadhikaranaha is no, not. Samanadhikarana kalaha is, it's unit, but yeah. So that you have to take care of those things. We will discuss it later. Okay. So, okay. So thank you, Sai and Professor Amma Madam for such a fantabulous presentation. Now we'll break for tea. We have half an hour, I think. 11:30. Okay. Thank you.
महागणपतिम्
Test, test. Mr. Arun, are you online? Can you hear us? Mr. Arun Prasad? No, no response. Huh? It's not online. He's not online. We can't hear you.
Oh dear.
Now, yes.
Okay, wonderful.
Okay, we can't see you.
Oh, sure. Let me turn my camera on.
Okay, okay.
Testing?
Oh, great, great. Give us 2 minutes to
Sure.
start the session. Okay. Yeah, you can, if you have a PPT, you can share your screen.
Okay, I'll share now.
Yeah. Perfect. Okay, good morning. Welcome back. We are about to begin the research session 4 with a paper presentation, virtual paper presentation by Mr. Arun K. Prasad on a fast Prakriya generator. Welcome, Mr. Arun, and you have 20 minutes to present, followed by 10 minutes for QA. Okay, thank you.
May I start now? May I start?
Please, please, yes.
Okay, thank you everyone. I wish I could be there in person, but unfortunately I can't because I'm getting married here in 3 days, so there's just a lot going on at home. As said, I'll be presenting my work on a fast Prakriya generator, and I'd like to first get on the same page on what is a Prakriya. And I'll be very brief here. It's a derivation, according to Paninian rules from Sanskrit grammar, of a specific word or expression form. So here you can have an abbreviated Prakriya of the word bhavati, meaning is or becomes. So what is a fast Prakriya generator? The easiest way for me to convey that is to show you a quick demo. So I'll just click this link here. This is my GitHub repo with different tools that I've built. I just called this repo Vidyut for short. Go to Vidyut Prakriya, and there's a link to the demo here, which I'll open up. Let me stop and just make sure that everything is presenting correctly. Can you see my screen?
Yes,
okay,
yes.
I'll continue. Okay, so everything you're about to see now is running locally in my browser. Now that the demo is loaded, there's no connection to a server or anything like that. So I can click over here and click some Tatu like Bhu, and I can
Arun?
see all of its forms.
Can you zoom in?
Yes. Is that better?
Yeah. Yep.
Great. Great. So all these forms are generated in the client side, and I can create different versions of this, like using a Sananta Prakriya like San, or Nich, or Young, or Youngluk as well. I can change this to Karmani Prayoga and add an Upasarga as well. And again, this is all happening in the browser. And if I click one of these words, I get a step-by-step computational derivation of this word form, showing the rules that apply with links to ashtadhyayi.com, showing how the word was created ultimately. And at the end, we have our final result, Parabo Bhuyate. So I'll return to this later in the presentation. So I wanted to briefly convey what the project is. So continuing from here, why care about this? Why is this an important problem? There are three angles that I think are interesting. The first are study tools like ashtadhyayi.com, sanskritabhyas.in, Sanskrit Heritage Site, Sanskrit Library, Samsadhani, and so on. Having an accurate list of Sanskrit words to consult is useful for students and anyone curious about Sanskrit grammar. Second example is dictionaries, using sanskritdictionary.com as an example here, or kosha.sanskrit.today. It's nice if a dictionary allows searching by a specific word form, like gachati, instead of just the base form gum. And then as a third example, alluding to a talk from a couple of days ago, or I guess just yesterday, spell checking. So if we have a rich list of Sanskrit words, potentially we can offer a better spell checking experience too, for anyone who needs to have high quality, well-formed Sanskrit text. So what have people tried in this direction so far? There are many different approaches to cover. In the interest of time, I'll just touch on two. The first is this XML formalization work from sanskritlibrary.org. I don't know about the details since can't speak to them intelligently, but from what I understand, it's a very deep and precise formulation of different Paninian rules and their semantics in an accurate Paninian way. And here you can see an example derivation of the word bhavati, I believe, is the page that I pulled this from. And then another example, which is more akin to the spirit of my project, is Sanskrit Verb, which is a successful project from Prakriya Pradarshini, published in 2015 by Drs. Dhaval Patel and Shivakumari Khatri. So here you see Prakriya displayed on ashtadhyayi.com, showing again the derivation of the word bhavati. And the technique of this approach is relatively simpler. It uses regular expressions and string matching. But the big advantage of it is that it's very simple to understand, and it's actually deployed in real sites that people are using. I think it's a tremendously exciting and inspiring project, and I took it as inspiration for the work that I'm presenting here. So why build something new, given that these systems exist already? There are really two reasons that come to mind for me. The first one is speed. As a simple question to frame this, how long does it take to test 180,000 words? This would be 2,000 dhatus and 90 different forms for the 10 lakaras, and then the 9 combinations of purusha and vachana. So if we could test 10 of these forms per second, it takes about 5 hours. So testing a single change would let could test about 2 in a single working day. But with each order of magnitude improvement that you get, it becomes easier and easier to test. And ideally, we're aiming to this threshold here of 100,000 words per second, which means that if you can do something like that, you can test a code change incredibly rapidly, which makes it easy to iterate and build out the program and make sure it's well formed. And the second is reuse. So if we're implementing a program like this in a language like PHP, it's limited generally to a PHP web server or something you can call through a REST API, let's say, for example. But the downside of that is that you can't easily reuse that system. So one advantage of what I presented here, and I'll explain how it works, is that it both works totally on client side in a browser, but can also work in a backend server and on an app as well, using the same code without having to rewrite anything. So that's a tremendous advantage for deploying something complex like this. So how did we build it? I'm going to touch on this from a couple different directions. There are details in my paper. I'm happy to dive in the Q&A. In the interest of time, I'll keep some details very brief. First is a very narrow scope. So there's no explicit model of anuvritti, or the context inheritance that the Ashtadhyayi uses to condense rules in a small format. There are specific rules of anuvritti. I haven't explicitly modeled those in any way. Likewise, there's no explicit model of conflict resolution, the method by which we choose which of two rules can apply if they have equal co-application. I'll talk about how I avoid this, and it's a pretty simple approach of just choosing a fixed order. But this is, I want to be very clear, an important theoretical issue that I have no perspective on in this paper. Likewise, I'm not taking any variant interpretations of a rule. So if the tradition disagrees on how a rule should be taken, I tend to go with what the Kashika Vritti says in general, or Siddhanta Kaumudi as well. And then there's minimal use of traditional grammatical theory. This is due to my own limitations mainly. For example, I was halfway through development of this before I had even heard about the Paribhasha and the Shekara. So there are just some limitations in my own background knowledge. But the reason that I can confess that so freely is the program seems to have worked out very well despite that, which is perhaps interesting on its own and a subject for future discussion. So another kind of a method of approach is the choice of programming language. And I, after exploring a few options, decided to go with Rust, which is a very fast and reusable language. And here you can see an example from our API and documentation in case someone wants to get started. So if you aren't familiar with Rust, you can think of it as a language that roughly has the speed of C or C++, with the tooling of something like, let's say, the Node ecosystem, and some properties of OCaml as well. It has a mix of kind of all these languages at once, and what it's trying to promise is the speed of a low-level language like C or C++, with safety on top, which means that it's easy to build a complex program and have speed without having segmentation faults. That's too much of a technical detour mainly, but I found it a tremendous joy to work with this program and build it with Rust, which is why I'm advocating for it here. Here's just a quick view of our data model as well. I model a prakriya as a list of terms, and a term is just a string with some metadata on top. Tag is an enum, so one of a list of values, and this is basically a sanya with other flags on top. And there's some basic logging as well. I can go into the details later, but I just want to convey there's a structured model, and this is what it looks like underneath. And likewise, there's a structured argument model, a way of passing parameters into the program to derive specific words. So here you can see I can request deriving a thing anta with a dhatu, prayoga, lakara, purusha, and all of that. The dhatu can be either a mula dhatu or a nama dhatu. And then the mula dhatu can have an upadeshika form, which I just called upadesha out of a little bit of laziness. One of the 10 ganas, an optional antargana, and other details there as well. And technically, the prefixes shouldn't be part of the mula dhatu. This was just easier during earlier development. I'll probably remove that somewhere else later on. I also adopted a simple control flow, again, taking inspiration from Sanskrit verbs. So I said earlier that I have no explicit model of conflict resolution in rules. What I do instead is just a very simple ordering. So here's an example of 3 rules on the on the left. Jhontaha, adabhyastat, atmanepadeshonataha. So here I order them explicitly with a simple if, else checks. And you can see the specific rule that's being run. I have a comment here with an example that is produced by the rule just to keep design straight while I'm iterating. And here's some basic examples of the API. So I'm looking at the last term in a list of the prakriya, looking at the base term, and if it's an abhyasta, applying these, and so on. I also have support for optional derivations. The mechanism here is quite complex in details, but easy to convey the gist of. During a derivation, I record whether a rule is optional, meaning if it's marked with va, vibhasha, or anyata rasyam. And then after the first derivation is complete, we try permutations of those rules that we saw and kind of draw out all possible paths for each word that we could generate. And again, I can go into that in more detail in the Q&A. Just in the interest of time, I'll keep that brief. So what can this system generate, given all this work so far? First, obviously, is a list of words, a list of well-formed words. So here is just a snippet of Katari Tingantas without any special upasarga or anything like that. These words are relatively straightforward, but I also have nijantas, sanantas, and other verb forms like this. This is quite straightforward, so I'll move on. And likewise, we have this prakriya as a structured data object that represents the grammatical rules that are applied for any given word. So here we have part of the derivation of bhut, which is the long lakara of bhu dhatu, bhu saptayam. And here we can see the exact rules that are being applied, along with links to ashtadhyayi.com in the UI. But in a program, we could see the specific rule code that was applied and maybe show some interesting data about that rule if we so choose. Going into details, we have strong support for optional forms as well. So here's an example of our test for rule 3136. And then going into the details, this program has very strong support for Tingantas. So you can here see the test for 3170. Subantas as well have reasonably strong support. So here are some examples from Siddhanta Comedy 291. Kridantas as well, with examples from 31126. Unadi pratyas as well are supported, supporting about 500 rules from the Unadi Pata right now, with more coming soon. And I'll pause here also very quickly to note that the dhatus are encoded in SLP1 transliteration. I have no strong opinion between SLP1 or WX. I just chose one that I was familiar with, and I wanted something very condensed where one byte represented one phoneme, which is just easier to work with. And then likewise, there's strong support for tatitantas as well. Here in this test function, you can see that I'm deriving these specific words on the right in the sense of tatra jata. And if this kain pratyaya is not available in this sense, the derivation won't work. So I'm testing both that the pratyaya can be added to create that form, and that also that it's available only in the specified sense. Likewise, there's basic support for samasas. This is still quite early, so you can see some tests from 211. And stri pratyas as well, and you can see some examples from Ajadetashta. So we have Aja, Devadatta, and so on. There's also limited support for nested expressions. I've tested this in some contexts, but not others. So here we have the result of putriyati. We start with the pratipadika putra, and we mark this as the namadhatu created with the kyach pratyaya. And this test is implemented and passes. Likewise, we can create a kridanta and add a supratyaya to the end. I've tested this with some basic expressions as well. So if we have two subantas in a single expression, that can be generated as well. But I haven't battle tested this thoroughly, so it's a little experimental. And likewise, support for swaras is also experimental. I have support for very limited things like chit, lit, dit, nit, and so on, mainly from this section of the text, Pada 6.1. And here we have some examples of Narayana, Charayana, and the Anudatas are hidden here, so I just don't have to type them out, but they are modeled explicitly by the program as well with the Udata at the end. So how do we know this program works, given what I've said earlier about my kind of background and focus on engineering and relative lack of familiarity with the tradition? Well, mainly I've leaned on the tradition. So if we take this rule from the Kashika Vritti, for example, these words in green are positive examples of the rule and how it applies, and these words in red are negative words or counterexamples to show where the rule doesn't apply. So to my mind as a programmer, these stand out as unit tests that are very convenient. So we can just turn them into a unit test like so. So here in this previous slide, we have a dukshat and a likshat and a paitsit and so on. And here these become examples that we explicitly generate and make sure we can produce. And notice also we have abadat and achidat because these are forms that are licensed as well. What this function assert is testing is that we can produce exactly the forms that are being specified given the input parameters. Likewise, we can test against the Siddhanta Kaumudi. So again, if we take the examples from Jyotaha, we can turn those into a test. And I'm happy to walk through this as well at the end if there's time that allows it. And there's also something I use called snapshot testing. This might be a little unfamiliar. Essentially, in this test that you see here, I'm generating about, I think, 1.5 million forms and making sure that if I make some change to the program, the forms underneath are not changing. So I'm not testing if the forms are correct. I'm just testing if they're consistent with what I've tested previously. And to briefly convey some sense of the speed of this, if I run it right here, time make test all, this is running live on my computer right now. First, there'll be a compile. That's actually taking a bit of time. I'm not sure why it's compiling right now. Anyway, I'll come back to this, I suppose. We can check back on that later and continue here. So how well does this actually work in practice, given these unit tests that we have in this testing regimen that we've tried? So I have a quality and a speed comparison to Sanskrit Verb, which again is an outstanding system I have really high regard for. I performed an exhaustive comparison that I mentioned in my paper, and there are a lot of very small wins that collectively add up to, I think, a higher quality implementation. Mainly it's due to the support of stronger optional forms in various cases, like Tanadi Lung forms or Karmani Lung forms as well. And in terms of speed, this is, again, kind of an inexact science, and it's an unfair comparison because I'm using a faster language and a second implementation that can go off the work of a predecessor. But in average usage, we see something like a 2 to 3 orders of magnitude improvement. And this is important for testing because it means we can run our massive test suite and ensure that things are well formed. Speaking of, I'm going to quickly check and see how this did. Okay, this ran in about 20 seconds with the compile, but if it's compiled already, you can see these running live. So each item going by, this is running about 200,000 different tests in the background, making sure we can generate certain word forms. And if I open up one of these, like the Young Karmani here, you can see the forms that are being tested underneath, and I'll try to zoom in so it's clear. So here it's testing the specific form, the dhatu, the gana, other metadata, the sanadi, the prayoga, and other information. So returning here, what next with this work? What can we do with it now that we have it? First are the applications that I talked about at the beginning of this talk in terms of having a higher quality list of Sanskrit words, showing derivations, maybe applications for dictionary tools. But more concretely, in the short term, I want to implement more rules. Current coverage is about 2,100 implemented rules. I can't get to full coverage because some of these rules can't be formally modeled, like tadashishyam samnya pramanatvat. I don't know how to put that into a formal structure, so I'll set that aside. But in terms of practical rules that generate words, I'd say we still have quite a ways to go. More tests as well. I focus mainly on the correctness of word forms and have not focused on the correctness of a prakriya. So I'm hoping to pull some examples from the book like this, the Paniniya Vyakarana Udaharana Kosha. And if I can pull those in, I think I can also justify the well-formedness of some of these derivations as well, because there are some artifacts that indicate that it is generated by a computer. And more sophistication as well. Let's see if I have time to pause here. Essentially, Rust has a feature called macros, which let you generate and rewrite code on the fly. And I'm hoping that we can apply this to maybe move away from if-else change and move to a meta language representation and experiment with things like applying algorithms to order rules explicitly, for example. I think there's a lot of power that can be applied here to have the same runtime performance that I have, while at the same time letting us model things like different approaches to ordering rules in the grammar, just for interest. And then there are new tools we can build as well. I was just reminiscing the other day about the work that the Cologne project has done on digitizing Sanskrit dictionaries, so much so that I don't need to use a paper dictionary anymore. In the same way, I think that tools like this can allow us to move into digital grammar resources that are much more sophisticated than what we have now, that remove the need for a paper grammar book. I hope that I can type in a Sanskrit word and get a breakdown of exactly how it's derived, explained at a level that's appropriate for the student to ask them. So why does any of this work matter, to kind of conclude? First, we're producing Sanskrit words with rich structured data. So for example, if we derive the word gatva, we already know that it's created with va pratyaya on the gam dhatu. But we can also see that it's produced by a specific rule here, and we can ask questions like what other words are produced by this rule? What other forms of gum might use this rule as well? And get more insight into the behavior of the class of words produced by this dhatu. Likewise, I think I validated that Rust is very useful for building fast and reusable Sanskrit tools. As a second experiment that I'm quickly showing here, this is a transliterator that I wrote in Rust recently that's running again in the client side that I'm hoping can become a standard transliterator backend that can be used everywhere as needed. And then likewise, I think this is an incremental step toward emulating the complete Ashtadhyayi. I want to be very clear, I've avoided certain key issues around rule ordering, anuvritti, and issues like that. But the advantage, I think, is we've made incremental progress toward a real system that is useful today for applications that I think are interesting. I want to just quickly mention some special thanks. These are in the paper, and in the interest of time, I won't call out specific names, but this is work that had a lot of small contributions from many people, and I'm very grateful for the people who've contributed here. And likewise, I work on this project as part of a larger group called Ambuda. What we're trying to do is create interesting Sanskrit digital libraries and artifacts online. And you can email me here or check out some of our work here. I'll pause there. I went through that quite quickly, but I'm happy to take questions.
Thank you, Mr. Arun. Wonderful presentation. Yeah, this floor is open for questions.
What I see is so mesmerizing that the only thing I can say, I bow to what you've done, and I hope you continue. It's a factory.
Thank you very
I'm
much.
looking like at a factory that is only starting to producing the verb forms. Let there be a lot of Sanskrit verb forms.
Okay. Any questions or observations, comments?
Thank you, Arun. It was a very nice presentation. And yes, this particular technology which you are using, Rust and other things, that is really very mesmerizing, I should say. The results are very mesmerizing. But at the same time, I was just thinking aloud, why do we need the derivation of all the verbs generated and stored? And why the need for that speed? And see, because as a Sanskrit student, what I feel is, yes, if I have a doubt, then at that point in time, I should get that information. So for that particular word, you can generate the derivation on the fly and show it. Why do we need to generate all these and store?
Very good question. So there's a soft rule of program design, which is first you implement a basic system, then you make it correct, and then you make it fast. So my goal is not necessarily to make a fast program, it's to make a correct program. And what I found in early attempts at building something like this in Python, for example, is it would be very easy to introduce a bug and only find out about it much later because it wasn't uncovered in my test suite. So the reason I care about speed is the speed lets us run a very large test suite to make sure that there's no accidental change somewhere in the program. And during development, I've seen it be the case where I made what I thought was a simple innocuous change and accidentally broke the derivation of several other words that I wasn't expecting to break. So that's the reason for the speed, number one. And then number two, for this web demo that I showed, for example, there is a slowdown that happens there when converting from Rust to WebAssembly. It's running what's called WebAssembly. And the slowdown is not great, but I wanted to hedge against that by making the core program as quick as I could. And what that means is something like, if we load a page showing all the verb forms of a dhatu, that can happen basically immediately. If this program were, let's say, a couple of orders of magnitude slower, there would be a noticeable lag. And I also just personally, this is maybe not a wide application, I just personally like building things that are fast, and it helps me continue the kind of development flow and keep adding new features. So those are the reasons that I think it's worthwhile.
Good. So it's essentially a very quick feedback cycle.
Yes, exactly.
Yeah, good. Thank you very much.
Okay, let's thank once again to Mr. Arun Kumar for his wonderful work. Thank you, Arun.
Thank you. It's very late here, so I'll go to bed. All the best to everyone for the conference.
Good night. Thank you. 1 minute, 1 minute.
Yes.
Arun, all the best for your marriage.
Thank you very much.
Okay, let's move on to the demonstration sessions. There will be 4 demonstrations, starting with discourse relation marking tool, which will be presented by Dr. Soma Paul. This work has been done along with Dr. Sukata, Kumari Riya, Adepu, Varshist Kumar, Sanyam Jha, and Isma Anwa. So, Dr. Soma Paul. So all the demonstrations will have 10 minutes time to present and 5 minutes for Q&A. Display.
Oh. Good afternoon. So I'm Shoma, and this is a work that I'm going to present on discourse marker tool. Now this is a tool which is in a very nascent stage. Mainly the tools that I saw in the morning, the glossy tools, it is not. This tool is mainly for understanding the purpose of making this tool is more understanding the phenomena and trying out different sentences and the discourse to understand where and how does a larger work where we are developing a semantic representation system for the whole text. So today I'll be talking about only discourse, and I will give you a very small glimpse of the overall picture at the end. So this is a tool where you see that there are 3 windows where you give a, say, input sentence, and then we simplify those sentences. And why we simplify those sentences, I will discuss that. And then once the simplified output comes, so maybe I select here, and I simplify. So it would be something like this. It is working behind. So while it is working, I quickly go to my presentation, and so the objective is to demonstrate a tool that specifies semantic relations for explicit discourse markers of Hindi. So the objective of this whole work is to apply knowledge from Indian grammatical tradition for interpreting and analyzing modern languages. So modern Indian languages and English. So how we take insight from our knowledge system and apply it to the languages that we speak today, we use today. So that is the goal of the team. That is the larger vision. So now when we were looking at discourse markers, we found that for Indian languages, mainly here I'll be giving data from Hindi, but from the translation you will see that similar thing can be also talked about for English data as well. So you see that in Hindi there are two kinds of discourse markers, indeclinables and nominal. So like if you look at the first three sentences, Ram bimar tha isliye nahi aaya. Ram did not come because he was sick. Ram bimar tha, is karan wo nahi aaya. Now when you are doing this, you are splitting. These are two different sentences. So Ram was sick, that is why he did not come. This is a closer translation. Ram bimar tha, is karan se wo nahi aaya. For this reason, he did not come. So the meaning of all these three sentences are same, but the way you express it are different. So you are using indeclinable in the first sentence, and in the second and third sentence, you are actually using a nominal phrase. The other one is another example of it. So we understand that these two are semantically same, and therefore we are taking the strategy of sentence simplification first. So even for the sentence where like the Ram bimar tha isliye nahi aaya, first what we are doing before we go for discourse analysis, we are simplifying the two sentences as and now once you do that, then the first sentence and second sentence are same, in the sense meaning wise, semantically they are same. So that is the reason for doing our sentence simplification. So once you see that here, yeah, so the sentence simplification has happened. So what we are doing, agar Ram aayega aur Sita bhi aayegi. So this is another reason why we are doing simplification. See, when we are doing simplification, basically when we give complex sentence for the annotators to annotate or to the parser to parse, if the sentence is very complex, we are seeing our current parsers are not doing well. Whereas if the sentences are simple, our parsers are doing well. I'm talking about Hindi parser. So keeping that in mind, and also when the sentence is very complex, for human annotator to process is also difficult. So that is why what we are doing is, agar Ram aayega aur Sita bhi aayegi, to Mohan usse milega aur main bhi mil lungi. So these have got four components. Agar Ram aayega or agar Sita bhi aayegi. So see, this agar has been now brought by the system, because in language you tend to drop words which you can otherwise infer. But for system, those dropped words, those ellipses become very troublesome. So what we are trying to do, before we go to discourse marking tool, we are trying to do using certain clue and trying to retrieve the inexplicit words. So making the system more explicit. So agar Ram aayega or agar Sita bhi aayegi, to Mohan usse milega और मैं भी मिल लूँगी. तो ये 4 सेंटेंस हो गया. राम नहीं आया क्योंकि बुखार से पीड़ित था, इसके साथ साथ उसको सरदर्द भी था. Now इसके साथ साथ means along with it or as well. We are considering even इसके साथ साथ as a connector, and this is a connector which you could have said and you could have said Ram nahi aaya, Ram did not come because he was sick and he had headache. But the speaker did not say and. The speaker said as well. He was sick and he had headache as well. Now what is it that speaker wants to say by saying as well and not just saying and? So we call it speaker's vivaksha, speaker's perspective of looking at the situation. So when the speaker choose a word or choose an expression, what is there in his mind? The thought he tries to express in the best possible way. Now can we capture that semantics through our tool? That is the target. So when we do discourse analysis, so you see that Mohan usse milega, unse milega, samuchay. So these relations we have seen in Sai's presentation. We have followed those tags along with some of our addition, tarka. मोहन उनसे मिलेगा और समुच्चय मैं भी मिल लूँगी आवश्यकता परिणाम अगर राम आएगा और सीता भी आएगी. Now if you see राम आएगा और सीता भी आएगी is making grade. That means it is the not the main information, it is the subordinate clause. So आवश्यकता परिणाम clause. So I am keeping it within a bracket, if you see, and I am also graying it just to say that the main discourse flow is मोहन उनसे मिलेगा और मैं भी मिल लूँगी. राम नहीं आया क्योंकि वह बुखार से पीड़ित था. And then last line you will see samuchay dot समावेशी. Samuchay means and समावेशी for inclusive. So I am trying, so this is a presentation for you to comment on, but I want to say it is not just and. It is and plus something. That plus something is the author trying to say there is an inclusive. So inclusive and exclusive are the two information that we are bringing in. And so we have given it here like samuchay dot समावेशी, that is and as well. उसको सरदर्द भी था. Now if we go to our presentation where we are making it, so this is our like if you look at what we are, I told you that there is a larger picture that is universal semantic representation of text. There if you see we have this concept, index, semantic category, morphos. I won't go through all these things, just you look at discourse and speaker's view. So in the discourse row, we are capturing the information of samuchay. So we are saying that Ram is a boy and he is wise. That much. And then we are saying there is a speaker's perspective, and that is inclusiveness. And that information we are bringing at a different level, which you might call a pragmatic level. It is going towards that direction. So when in our original database, it will be kept like this in a tabular format where samuchay dot समावेशी that you saw in my other in my other window is actually samuchay is the discourse information, समावेशी is the speaker's view information. So this is what newness or I am happy to get it. So this is what I am trying to build in to the system. We are trying to build it into the system when we talk about discourse relation. So discourse relation is not only by indeclinables. In Indian languages, also in English, nominal phrases do play a role of connective. How to capture, how to give us semantics, similar semantics for both of these kind of lexical items. And if we can do that, then we are going away from syntax to the level of semantics and pragmatics. Thank you.
Thank you so much, Dr. Soma. Now the floor is open for questions.
So I assume that this can also be extended to Sanskrit. So you are using one module of simplification. That I understand as basically you are taking ekating vakyam as the sentence split as a condition for splitting the sentences.
Along with something more, like right now we are not splitting Jova.
Okay, fine.
We are not splitting jab tab. Yeah.
Okay, so there are few. But then the same simplifier, can we extend it to Sanskrit or other languages?
Right now I think yes, because we are using some syntactic cues. We are using some cues from parser, and that's why right now our simplifier are a little slow because we are using some information from parser, at least the Mukhya Vishesha identification of Mukhya Vishesha.
So that means first you parse the complex and then you split it?
Yeah. Right now we are
then
doing that,
what,
but
what,
no, but
what
we
you
are.
s- what you said is you wanted to split it because complex sentences
Yeah,
cannot be
that's why I
handled.
told you in the beginning that this is right now an experimental stage.
Okay.
Slowly we will try to learn also. Like these splitting, we are now doing it with cues, and cues are working fine. Only for now, the discourse tool that I showed you, there we are not using parser. But
Okay.
for USR, but USR generation
fine.
anyway require dependency
Okay.
relation.
Another question is related to the scope. For avashyakata parinam, you had put that in scope, it is good. Agar you had repeated in the second sentence, can you also not treat the scope of agar is from this, the whole first part?
Yeah,
avashyakata?
I wanted to say that this in the simplified sentence, in the discourse tool, you will see that there is no repetition. It is only in the simplified sentence.
Yeah.
Since I have the information, I am using it for helping my discourse tool to correctly identify the relation. And there, once it is identified, I am not using that agar information again.
Okay.
So this simplification is an intermediary stage.
Thank you.
Sai and Patrick.
Hello. So I just wanted to ask you that how have you decided what words should be repeated in a split sentence? And because I think not all possible words are repeated, such as वो सीता उनसे मिलूंगी or मैं भी. So in that second sentence, unse was not repeated. So is it that the
So
only
for this one-
discourse relation is repeated, and
Right
how
now,
to decide?
yes. Right now, because we have a very clear discourse markers in the language, and we are repeating that. When there is or या लेकिन kind of conjunction available, there are certain constraints.
Okay, fine.
Yeah, better.
So see, the idea is to make your representation as explicit as possible. So how to do that is the challenge, and we are addressing it.
I would like to comment on that from a learner's perspective, because I think this could be a really great tool, because I've tried to learn Hindi, and these are exactly the things, this ellipsis, that I'm struggling with. So from a learner's perspective, this is really great, and I appreciate that when it's split down in all these simple constituents, when the connecting words are repeated. The only thing that I could use it for that. The only thing I'd find difficult is when you have the discourse markers then in the bottom, in the box at the bottom, that of course these are the Sanskrit grammatical terms, and I think perhaps I'm not popular with that request, but I would really like it to be like also with an English glossing or something, so that I actually understand when I don't know the Sanskrit grammatical tradition and I want to use this tool for learners' purposes, then to actually see what is meant there. But it's just a remark from my side.
Yeah. So since we are claiming that we are developing a universal semantic representation. When we say that, the representation should be language independent, and that is where we are trying to go. So for example, if you look at this, like in the USR, see these representations like concept. See, I have not given either Hindi concept, Hindi word, or English word. This underscore something says that these are concepts. And we maintain a conceptual dictionary where all languages that we are working with, the concepts are given. For example, Samajdar wise _4 is mapped to Hindi Samajdar _5. So that is a way we are disambiguating concepts. And right now, initially we did it manually. And right now we have a system which is learning from parallel corpora these disambiguation thing. So, yeah. Yeah. I always say that, but my Sanskrit friends say that samuchaya should be there. Right. So I am also learning. Yeah.
Thank you. And one last personal question I have. If these tags are there. It is applied for Hindi. Can we apply it for other Indian? Can we use the same parameters for other Indian languages as well?
Yes.
So, is there a list of all these parameters ready?
Yeah.
Oh, great.
See, when I say ready means it is research, you know? So it is, yeah. Our version is ready. Yes.
Okay, let's thank Dr. Soma once again for her wonderful tool. Yeah, moving on to the next presentation on machine translation and LLM-powered grammatical explanation for Sanskrit by Sebastian Nerik, David Alpoch, Jivnesh Sandhan, and Kurt Kuzer. Sorry for mispronouncing your names, but yeah, this is a virtual presentation, virtual demonstration, and I request the presenter to start his presentation.
Boarding in progress.
So, yeah, you can start.
Okay, I hope my slides are visible now.
Yes, yes. Not in a presentation mode, though.
Okay. Yeah, thank you a lot for giving me the opportunity to present here. I'm Sebastian Nerich, and I'm today going to present on the Mitra system that we are developing at the University of California, Berkeley, together with David Alport, Jivnesh Sandhan, Sujit Jaiswal, and Kurt Kreuzer. And our system is basically a machine translation and large language model powered grammatical explanation system for classical Sanskrit.
Dr. Sebastian, can you?
So I will first.
Can you keep your presentation on the presentation mode, or full screen?
Oh yeah, sure. You mean like this, yeah?
Yeah. Yes. Thank you.
Okay.
Please continue.
Okay, great. Yeah. So I will first give a brief introduction of the Mitra project and team. Then I will give an overview of the architecture, of the grammatical preprocessing step that we are proposing, the machine translation, and I will also give one example of the system in action, and I will give an outlook of further work that we are planning to do. So the team, basically, it's a bit too much detail to go into all the names now, but just as an overview, there's Kurt, executive director, then I am the technical director, David Alport is working on Sanskrit data collection, and then we have Jivnesh and Sujit, who work together with a number of graduate students to collect data, and we also have a number of students and interns at UC Berkeley who help us and who work together with us to create the necessary data set for this type of work. So the architecture of the machine translation explanation system that we propose is we take Sanskrit input sentences and we process them in multiple steps. So the first step is grammatical preprocessing, where we do segmentation, lemmatization, and morphosyntactic tagging. Then the next step is we use an encoder-decoder language model to generate a draft translation. Then we use k-nearest neighbor search, so that's basically a search system where we can query an index and get the 5 or 10 or 15 closest, most similar sentences to our input sentence. And in that way we can gather few short examples for the language model. So we can say here are 5 Sanskrit sentences translated into English from our reference database, you can use them as examples to learn from them, to get some clues on how to translate. So that is a technique that can improve the quality of the translation here. And then with all these different information that we have gathered, we can prompt a large language model such as ChatGPT, Claude, Gemini, and so on, in order to generate a precise translation together with a grammatical explanation if that is desired. So this is an overview diagram to show how the workflow of the system works. So here we have the Sanskrit input sentence, that's our starting point. And then we have the step of Sandhi split, lemmatization, morphosyntax tagging. We also have the step of machine translation, which can actually be done in parallel. And then we also query the KNN index in order to get the number of examples from the reference corpus that we want to include at that point. And once we have gathered all this data, we can combine it into one prompt that we feed into a large language model, and then we ask the large language model to produce us, based on all of this information, a translation or a grammatical explanation of our Sanskrit sentence. So what is the motivation behind creating this machine translation and explanation system? So first of all, translation models such as Google Translate or transformer models trained from scratch, they are limited in their capabilities. So they cannot explain how a translation was derived, and we as users of these systems are basically sitting in front of a black box. So we can paste the sentence into Google Translate and we get a translation, but we cannot tell, if it's right. We don't know how was this translation generated, how did the machine come to that conclusion. So large language models, on the other hand, they do have this ability, and they show powerful performance on general natural language understanding tasks, but they lack the domain-specific knowledge for Sanskrit, and they are prone to show hallucinations, imprecise renderings of grammar, and so on. And I think this is familiar to many people in the audience here who have tried to use ChatGPT to translate Sanskrit. It's not always on point, and if you ask ChatGPT to explain the translation, then it can get more fuzzy, and there are more mistakes, hallucinations, and sometimes it's just downright wrong. And that's why we want to build this tool chain, in order to avoid the model to get off the rails and produce wrong output. Then currently the grammatical preprocessing tools are efficient and sufficiently precise, but they do not output machine translations, and they also don't present the results in an easy to understand manner. Few short examples actually can further increase the quality of translation when high quality data is available. So this is a so-called nearest neighbor machine translation paradigm, where a machine translation model is combined with a reference database in order to generate higher quality machine translations. Now, when we combine all of these different aspects, grammatical processing, pre-generated machine translation, and few short examples, we can query a large language model with strong reasoning capabilities in order to generate high quality Sanskrit translations together with easy to understand explanation of the grammatical structure of the Sanskrit. And this flow can be described as a sort of linguistically informed chain of thought prompting for machine translation. So I just want to give an example of the grammatical information that is stored in the digital corpus of Sanskrit from Oliver Helwig, which we are using as the basis of the data for the generation of the grammatical explanation system. So this is how the data is stored in the database, and we can already see that this is, from a linguistic point of view, of course, very important, very valuable data of high quality, but at the same time it's not immediately user-friendly to use. So when a tool outputs data in this format, it needs some post-processing, either in the form of a web interface or some language model that actually digests this and gives it in a nice, presentable way. And in order to generate these grammatical explanations, we are proposing the training of an encoder-decoder model to perform Sandhi segmentation, lemmatization, and morphosyntactic tagging jointly. So this is all done in one model. We use the MT5 model of Google as a base model for this. The data we are actually taking from Oliver Helwig's digital corpus of Sanskrit, and then we also perform simple post-processing in order to make the output more prompt-friendly, because the prompt systems are tuned to digest natural language, so this conlu format needs to be converted into some kind of natural language so that the model can actually work with that. Coming to the draft machine translation steps, so we have an ongoing effort of data collection here at UC Berkeley since the summer of 2023, and currently we have more than 718,000 aligned B-text pairs of Sanskrit and English data. The publication of the data set and the machine translation model rates are planned for 2024, and we also plan to release the machine translation and grammatical explanation tool for a limited audience, targeted audience in the summer of 2024. There are, of course, some problems that we still need to sort out, like, for example, the running cost of GPT in the inference, and for that reason, we just cannot make this available to a large audience right now. We need to sort out these details first. Coming to the machine translation data collection, so currently, I guess I cannot go through all of these numbers now in detail, but just to give a large picture of how our data is constituted, which different elements we have. You can see coverage for epic and Purana text is pretty good. For scriptures, it's not as good. For treatises, we are doing not so bad, but it could be better. Poetry, I think it's still a lot of room of improvement. Vedic material, of course, as well. The coverage is not very far at the moment. So, but all in all, we have managed to gather about 22% of the available data, and our reference corpus here is the Gretel corpus of University of Göttingen. So of that corpus, we have been able to cover about 22%, and we hope to be able to improve this number in the coming months and years. Now, to give one example of how this system might look like in action. So this is, I just took this screenshot this morning in order to include it in this presentation. So this is really as fresh and live as possible. And I have taken the first Karika of the Nala and Damayanti story, which is used frequently in Sanskrit textbooks in order to teach Sanskrit. And I hope the English translation that we have here, there was a king named Nala, the valiant son of Vidasena, endowed with desirable virtues, handsome and skilled in horsemanship. I hope this is acceptable. Maybe some Sanskrit experts find some point of criticism, but let's hope it's good enough. And then we get the grammatical explanation. So asid is derived from the root as, it means to be, and here it is used in the indicative mood, singular number, past tense, translating to there was. Raja is the nominative singular form of Rajan, meaning king, indicating the subject of the sentence here, and so on and so on. I can't explain the whole example here, but as you can see, there's a lot more linguistic information and precision in this system than any generative AI system like GPT or Gemini or whatever would be able to provide at the moment. So,
Dr. Sebastian, can you zoom in?
That the prompt system is working. Yeah, sorry?
Can you zoom in? We can't see that translation clearly.
Yeah.
Oh, it's in the presentation. Oh, okay. Okay.
Yeah, I'm sorry, but I can, yeah.
Okay, it's okay. Continue, please.
Yeah. Okay, regarding further work, so the outlook is, of course, collecting more parallel sentence data is very, very important, because the better the reference data is, the better the training data for the draft translation system is, the more reliable this whole pipeline is going to work. So we are putting a lot of effort into getting more data, and we also want to reach out and, you know, if anybody in the audience feels this is an interesting project, I want to also be part of that, I want to contribute, I want to see how we can improve the quality, then feel free to contact us. We are certainly looking for partners for collaboration for institutions. This is something like we really want to develop in an open fashion together with other people. So if you're interested in this, we are more than welcome to collaborate. Now, the data cleaning and improvement of alignment quality is an ongoing issue, and we are currently scrutinizing and trying to improve as much as possible on that end. So that's also a challenge. Then what we also plan is the integration of a corpus-wide semantic search tool that can provide relevant passages with similar content. So we can, for example, in the Geräte corpus or in other collections, we can search, and if there's a similar Kardika, we can fetch that from the database and then also give the user some references. You know, this Kardika you want to translate is also quoted here and there, so that can give additional meaningful information to the users. And lastly, we also want to explore the fine-tuning of open source large language models to reduce the reliance on commercial providers. So right now we develop the system by using the API of OpenAI, but of course, sooner or later, having our own independent model is very desirable, and we really want to work towards that end as well. Yeah. I think that's all from our side, and thank you so much first.
Thank you so much, Dr. Sebastian. And questions, yes.
Thank you, Sebastian. It was a very wonderful presentation. And what I like the most is you are not just producing the translation, but you are also giving the morphological information and segmentation and other things which are very much relevant. But here I have a question. When I saw your workflow, I noticed that translations are coming from different sources and the morphological information is coming from a different source. So do you don't you think there will be cases where the translation is different and the morphological information that you are displaying is totally irrelevant?
I think you are, it's a very good point that you make, and it's one of the great challenges that we have here. So just to show the workflow, it's of course very much possible and maybe even desired to change the order and to, for example, do the Sandhi splitting, lemmatization, and morphosyntax tagging before we feed the data into the translation model. So that is one way to make sure that the translation model is based on the same grammatical annotation that we have provided at this point. So that's one thing. The problem is in practice, it sounds nicer on paper than it is in practice, because since Sanskrit is such a morphologically rich language and we can encode so much, it's actually possible that we run into the problem that you just described, that the grammatical annotation tool is producing something that conflicts with the recorded translation data of our data set. So we have the collected sentence pairs, and they might have a different decision than the parser, the grammatical annotator is doing in the step before. So our experiments to train a translation system on top of the grammatical annotation systems have not always yielded that great results. So this is an ongoing process. So we are trying to explore what is the best way here, and it's still not, I think we are not there yet that we can say we have solved this, and it's really challenging because those conflicts in grammatical annotation and translation from the data side of view are very difficult to solve, because that would require basically retranslating the Sanskrit based on our grammatical parsing, or it would require to re-annotate the Sanskrit based on our English translations. And both is probably something that is well beyond what we can do as a team. So yeah, this is a challenging situation, absolutely, and especially on more complex verses, this can really become a problem. So yeah, there are certainly shortcomings here that will undoubtedly emerge later on.
Yeah, so here one suggestion is to plug in the dictionaries. Since you have the root words and you have the dictionary, and then use these dictionaries to map or correlate them with the translations, and then you make sure that there is convergence kind of thing. Thank you.
Yes, we have also worked with, so just to quickly respond to the dictionary, so we have tried that, and the problem at the moment is that it's actually giving too much information to the prompt of the large language model, and it's actually getting confused because we have the dictionaries like Money-Williams have so much for certain words, they have such an overgeneration of possible meanings, which makes sense. Of course, we know Sanskrit is extremely productive and the meanings can be really deep, and and manifold. So actually limiting the dictionary to what is relevant to the actual sentence is another challenge. We have some ideas on how we can tackle that, and I fully agree that this information should be included. Yeah.
Yeah, that you can do by looking at the translation. From the translation, you know what sense is there, and then pick up the corresponding sense, and this will also give you another resource where you have sense tagged it. But
Yes.
you need to look
Yes,
at the
yes. I think,
translation
yeah.
as well as the dictionaries. Okay.
Yeah, I fully agree with that idea to use the machine translation, because then basically we can just embed the dictionary entries and the machine translation in vectors and then sort the dictionary entries according to their similarity to the translation and rank them in that way, and then limit to just the first 4 or 5 entries. So in that way this overgeneration problem is solved. Yeah, I think that makes a lot of sense. Yeah.
Okay, yeah. Let's thank Dr. Sebastian one more time for his presentation. Thank you, Dr. Sebastian.
Thank you for giving me the opportunity to speak here.
Thank you. Yeah, moving on to the next demonstration. It is by Dr. Rishikesh and Dr. Arnab on Veda Patha Paddhati, a tool to generate Prakriti Patha and Vikriti Patha forms of Sanskrit texts. Over to you, Rishikesh. You have 10 minutes for presentation. Rishikesh.
Thank you. I am Rishikesh, and I'll be presenting tool Veda Patha Paddhati, tool to generate Prakriti Patha and Vikriti Patha. So let us start with Gayatri Mantra. So I'm sorry, and most of you will spot the error in this, that Tasya Vitura Varenyam. So there are other errors as well. So Vitura Varenyam. So these errors can happen while speaking. So if someone is guru is reciting shloka and Shishya is then reciting after it, he may have misheard and then spoken in error. So that is one of the possible ways of transmitting error. And to avoid such things, so we know that we have retained Vedas in a correct form. And so how did we manage to do that? And that is through these specific method of chanting, and which contains Prakriti Patha and Vikriti Patha. And these involve Sandhi resolution and then repeating the words in a specific order, either in maintaining the same order as they appear in the text, or some going back and forth, etc. So Prakriti Patha is are where the order is maintained, and Vikruti Patha is where the word order changes. And there are 3 methods for Prakriti Patha and 8 for Vikruti Patha. So Samhita, Pada and Krama for Prakriti, and Jata, Mala, Shikha, Rekha, Dvajo, Dando, Ratho, Ghanaha. So there are of course some variations with the specific, etc. So that I would be happy to, if someone helps, we'll be happy to develop this. So this is still in the early stages. So based on what my understanding, we have developed this, and the contribution is web-based application, so that URL is live, and you can also try it out. There's a Python libraries, so you can generate it offline as well. And you can, of course, select which part. So you can give input text and select which part you want to generate. And currently we have plugged in some splitters and joiners for resoluting Sandhi and joining again. And these are, of course, pluggable modules, so you can, if a better module is developed, then we can plug that in. So the method for generating these is essentially input is a Sanskrit text. So a disclaimer here, we are currently not handling Swara markers in the Veda. So this is plain text that we would be providing, and choices of methods. When the method is which Patha basically. And the methodology is you first, of course, resolve Sandhi. So you get the words out. Then this group formation and group transformation I'll come at. So this is the approach that we take to generate this. And we'll look at what each of these mean now. So the example, we are again taking the example of Gayatri Mantra. And we want to generate, say, Ghana Patha of this. So the split Sandhi is first we get the padas out. So Tat, Savituhu, Varendyam, and so on. Now coming to group formation. For Ghana Patha, from a sequence of 1, 2, 3, ... n, we generate a sequence of groups. So the first group is 1, 2, 3. Second group is 2, 3, 4. So that is the group formation phase. And this is a definition of Ghana Patha that we would store somewhere. So we'll also see an example of code, how we achieve this group formation. It's a one-liner really. And then after we found these groups, so if we had say n words, then we'll have some function of n groups now, either the same n or that depends on the definition. And now once we have this group, we transform this group. So that now once we have 1, 2, 3, then for Ghana we do this 1, 2, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. This is the group transformation form. So you take a group of words, transform it into another group of words. The length can be variable. That again depends on the definition of the paddhati that you are generating. And then you combine them to form the final Ghana Patha that you would be deciding. So this is a very small peek at the code where you'll see group formation. So given a list, so X is the list of words here. And this is how you generate these groups. And group transformation, the T here is the list of words, represents a group. So it can be thought of as a tuple of the words or list of words. So group size for Ghana Patha is 3, because every unit for Ghana Patha is, we consider groups of 3 words, and for those 3 we apply a particular application. And this 0, 1, 1, 0, that is the 1, 2, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. So that is the group transformation. And once we have such definitions, then the generation is essentially apply group formation and then apply group transformation. That gives us the Ghana Patha. So in action, when we enter something like this and select the splitter, and here we are choosing to join with space, that we get the output as Ghana Patha. Now I would like to show you this in action. So this is available at sanskrit.iitk.ac.in/jnanasangraha/Vedapatha. So I'm not sure if the URL will be zoomed in, but I'll
I'll show the URL on this. So this is the URL that is available, and in this we can first see. This is we are just trying to generate Padapata. Now in the splitter we had selected to split on white space. So it thinks of Tatsavitura Varenyam as one word. We of course don't want that. So we then get Pada separated. And let us try to do something complex. So in Mala Patha we get Tatsavitura. And ideally we also want to form Sandhi. So you get Sandhi formation as well. Sorry about this, there is a bit of error in the formatting. And the definition of the Patha is also shown. This is just for the, I mean, just if you want to see for how it works for some, it's easier to understand at times. And I have some other examples as well if you want to try. And I can also take examples from audience if you want to try on something. Sorry? But, okay. So for this, you get Tadvratam, Vratan, Tadvratam. And so sometimes it may happen that a splitter, it does not split the entire thing. So you might not get the correct split. Now that is a limitation, and to tackle that the split on the white space is there. So instead, if such a case happens, then you can actually provide the Padapatha, and then you can get around that limitation. Again, the Avagraha is currently being shown incorrectly. Sorry about that. So that is all from, and we'll be happy to take feedback and improve the system. Yeah.
Thank you, Dr. Rishikesh. Questions, comments? No comment. Yeah, no, you can go ahead.
So, I have several questions. Not one. First thing is whether Samhita Patha is basic or Pada Patha is basic. Well, there are.
So actually, Samhita Patha we are not generating. It's Pada and Krama. That is.
Yeah, but you start with Samhita, right?
Yes, yes.
So you consider Samhita as the basic, and then you have the Padapatha.
Yes, yes.
But there is another school which says Padapatha is basic, and then so there are differences of opinion.
Okay.
First thing. Second, the Ghanapatha which you have generated for the Gayatri, there some Itikarana.
Yes, yes.
That you have not included here.
Yes, so yes, that I have not included, and I am not. I would like some guidance in.
There is lot of material on Itikarana, and these Itikaranas are different for different Vedas.
Right.
So you need to look at that also.
Right.
That is second thing. And regarding the Sandhi, when you are doing the Sandhi, when you are generating that Ghanapatha, are you using Panini's rules or Pratishakya rules?
I'm using I'm feeding the words to Samsadni joiner and generating. So
those are the Panini rules, but then whether Panini rules are to be used or Pratishakyas, there are, when you are going in the Vikruti, the changed word order, the reverse order, I think you need to go for the Pratishakya rules.
Okay.
Panini's rules are for forward direction, not for the reverse. But I am not sure, I still, this is my understanding, I might be wrong, but they use Pratishakya rules as well as Panini's rules. And we need to decide, we need to take a decision while doing you need to use the appropriate rules, then only you will get the correct output. So
Right.
these are some of the observations and comments.
yeah, thank you, and we'll talk to you more about improving this in several ways that it needs improvement.
Yes. No, I wanted to ask about the ET rules only. Where, anyway, that has to be incorporated, or else Ghana Patha would be difficult. And same thing with the reverse order, Vikriti Patha. For example, in Yajurveda, you would get those gum sounds.
Yes,
where
yes,
Anuswara comes and the sandhi would not happen in that manner.
Right,
mostly.
right.
So that sandhi we cannot use the samsadhini for that kind of for the Vedic
Correct,
sandhi.
correct.
So these are the 2 points which you have.
Yeah. So I am not aware of any existing tool that we can plug in to form these sandhis. So that a tool to form sandhis using Pratishakya rules or Vedic rules, that it itself is a separate work, and yeah.
Yeah, please.
Pretty much that summarizes the Veshni, that is the Itikarana what is there. So that happens at the word endings, that is one place, and also at wherever it is Sambodhana or also Atho or something, which are the Avyayas basically in some places. Those also get this Itikarana. And one more thing is the best way to probably use this is a combination of Pada and Krama to get the orders and these things whenever you're doing the Ghana. If you just consider Samhita, that will not be enough. And just a Pada also will not be enough, because in some places it will be just Iti. Iti, Iti. Iti only will be the form that you will get there. And then that again will not be able to directly use it. But if you use a combination of Pada and Krama, those two will give you a better result to come out with the Ghana Patha for that. Krama, that's what, yes, Pada is that's why the progression would be in that manner.
So you're saying the input should not be just Samhita. We take this Prakriti Pathas as input and
yes,
generate
a
Vikriti.
combination of the Prakriti Pathas to be taken as input, and then based on that some analysis has to be done, and then the Ghana can be come out.
Okay.
Or the inputs,
I see.
and that means.
I see. Okay. So we'll definitely work on those.
Thank you.
Yeah.
Thank you, Dr. Rishikesh. If there are any more questions, you can take it during the lunch session. Okay, now move on to the final demonstration session on Sanskrit segmenter by Sri Ram Krishnan. So you have 10 minutes.
Am I audible? Okay. So, namaste. I'm Sriram. I'm here to present a short demonstration on the Sanskrit heritage segmenter, focusing on its recent developments. So, we might have used, most of us might have used the Sanskrit heritage platform for various tools like grammar, Sandhi engine. This reader is a segmenter. I'll just zoom it. Yeah. So it is accessible from here, the reader. Oh, okay. Okay. So this is the input interface. So it's called Sanskrit Reader Companion. It's not just a segmenter. It produces morphological analysis, morphological tags for each of the segments in a neat graphical interface. So I'll just give I'll just dive directly into examples. So I'm giving a verse from Shishupal over there. So there are various parameters here. I'll just focus on a couple of these. The input convention I have used Devanagari. If I want to increase the size more, I'll choose Devanagari here. And the Sanskrit display font is the output convention. There are two options, IAST or Devanagari. I'll choose Devanagari here. And I'm not going in details regarding other parameters. This is where the recent developments have been done in the mode parameter. We'll play with these, the first, best, or the two new features that have been added. So I'll first produce all possible solutions to see how many solutions this segmenter produces. Through internet. I think internet access is full, but it's a bit slow. Local, my laptop was not connected. Okay, I'll just reload it. Yeah, now it's available. So it has 1,20,900 solutions in total, this single verse. So we have all these options. I'll increase a bit more. Yeah. So upon clicking on each of the segments, we'll be able to find the stem, the morphological analysis, Shreyaha, it is an accusative. It could be in feminine plural accusative or feminine plural nominative, and these are the options. It also marks, one major advantage is it marks the compound Purvapadas, compound components separately and Purvapadas. So all these colors yesterday we saw in Jiratsa's presentation, so I'm not going in detail regarding that. So our approach was to reduce the number of solutions. So the total number of solutions into a small set like 1 or 5 or 10. And if a user wants to look at the best possible solution, so he has to click on each of these. So Shreyaha, and it automatically updates, and it prunes out the solutions which are yeah, I'll do with this Shrimati. If I choose Shrimati, all these will be removed, and all other solutions which are combined with these segments will also be removed. So what happens is, to get a single solution, we need the total number of clicks a person has to do is equal to the number of words plus the total number of Purvapadas of each of the compounds. So in order to avoid that, we are trying to reduce the number of clicks and make this accessible at a glance. So there is one mode here. I'll just go again to the yeah. I'll give another example to So this is from Bhagavad Gita. Aparyaptam tadasmakam balam bhishmabhirakshitam paryaptam tvidam balam bhimabhirakshitam. I will first run through the all mode and see the number of solutions it produces, and then come back to the best possible solution. So it's around 52,920 solutions, and we see a lot of options here. So I will now run these with the best mode, first mode, where it narrows down to a single solution. Yeah. So all the other options have been removed, and if you see aparyaptam tat asmakam balam bhishma abhirakshitam, and here we have to choose, like paryaptam could be a verb, or from pari-apta, pari-ap, it could be a nominal also. So the number of clicks here in this situation is 1, like 2. In the case of idam also, there are 2 options. So from the total number of words, I think it's 5, 10, 12, like more than 12 to 14 clicks to 1 or 2 clicks. So this is what we are trying to achieve. I'll give another example. Sometimes what happens is this is based on probability completely. So we are trying to push the most probable solutions at the top. It is possible that the first solution does not produce the intended segment. So we can go for a few more solutions, like 10 or 20. We have kept the arbitrary number as 10. So this is another verse from Bhagavad Gita. Anyecha bhava shura madarthe tyakta jivitaha nana shastra praharanaha sarve yuddha visharadaha. Yeah. So if we see here, this nana shastra praharanaha, this nana is should have been a purvapada. Nana shastra, different shastra praharanaha. But the first solution produces the indeclinable. It produces indeclinable avyaya. So we can use the best mode here and running into the best mode and trying to get the. So it computes a few more solutions. It just not stops with the first one. It computes the top 10 solutions and there's an issue with the internet, I guess. I'll reload again. Okay, so here we have, earlier we had only nana, the indeclinable. Now we have the IIC. IIC is the purvapada. Is also available. Sometimes it is also possible that even the best solution, the top 10 solutions, the intended segmentation is not available. I'll just give a small example. This discussion happened yesterday. I'll give this verse from Raghuvamsha. वागर्थाविव संपृक्तौ वागर्थ प्रतिपत्तये जगतः पितरौ वंदे पार्वती परमेश्वरौ. Here the segmentation that we almost always see is with Parvati and Parameshwara as Parvati Parameshwara. This is in the first mode, and if we try it in the best mode also, we won't. I'll just show the best mode also. It is Parvati Parameshwaro, and there are cases with Parama Ishvaro also in the top 10 solutions. But if we go into the all solutions, we have this interesting case of Parvati Pa. So this is marked as an H. This is also a Purapada. So this Parvati Pa, when we choose, we'll get the alternate analysis, Parvati Pa Rameshwaru. Parvati Pa, and here in this case we have to choose Rama also, Rama Ishwaru. So when you choose Parvati Pa, it says Rama Ishwaru separately. So this is about the segmenter. There's one more small feature that I would like to add. We have established a pipeline between the Sanskrit Heritage Platform and the Samsadini platform. So when we are trying to generate the dependency analysis from the dependency parser of Samsadini platform, it requires segmented inputs. So we are trying to feed this the first solution to the Samsadini's platform and see so that it generates the best possible solution. So I am giving the verse from Bhagavad Gita, Drishtva tu Pandavanikam Vyudham Duryodhanastada. I am trying to get the first solution here. Yeah. So here there is an option to view. So this is in the summary view where we can see along with the tags and morph analysis and all the colors. There is also an option to view it in a string, in a string format. Yeah. So Drishtva tu Pandava Anikam Yodham Duryodhana Tada, etc. And there is an option here where this redirects to the UOH Samsadini's parser and generates the dependency analysis. So what it does is it gives the segmentation along with all the possible morphological analysis of each of the segments. So for all of this, we have the APIs ready, and also for the entire Sanskrit Heritage platform, we have developed a portable version of the segmenter in Python. It's like a wrapper that can be used to generate the analysis, these analysis, either the first solution or the top 10 solutions, etc. Yeah. So this is Samsadini's analysis here, and so this is the dependency analysis. So this redirection is also available from the Samsadini platform. So there is an option in Samsadini platform to choose whether we need the segmentation to be done automatically using the segmenters analysis, or it needs to be done manually. I'll just show the interface, not run it. So here, this is the input interface for the Samsadini's dependency parser generation, and it also has Sanskrit to Hindi Anuvadakam Anusarakancha. So here there is an option to choose. If you are providing none, we need to provide the segmented input separately. There is an option to redirect from here to the Samsadini Heritage platform to view all the analysis and then choose manually. And it also uses the best possible solutions automatically. And for generating as I said earlier, for generating the best analysis or the list of all analysis, we have provided the, just a second. So yeah, this is available in GitHub, and this is a wrapper that generates in the JSON format all the analysis and all the, so both morphological analysis and segmentation is also available here for developing different models. So we are also trying to generate the entire graphical structure that the Sanskrit Heritage platform produces in the same Python library. So that will probably in due course we'll also release that. So that's it from this presentation.
Thank you, Dr. Sriram. Now we have time to get questions. Yes.
What if we try some long samastapadas like Raghuvira Gadyam or Badabhatta, something that? Have we tried that? What happens?
Yes.
It's
So
huge
so even if there are long samastapadas, I tried a few from Bhagavad Gita itself, like Katvam, Lalavana, Tyushna, Tikshna, Ruksha, Vidahina. It has like around 6 or 7 Samastapadas. To some extent, the segmenter works, but if there are multiple sandhis in the entire compounds and there are many components in the Samastapadas, then even the segmenter takes a lot of time to generate the output. So if it is very long, like I'm talking about more than 500 characters or something, then it chokes the system. So it stops. Regarding compounds, what happens is the number of possibilities that can be generated is huge. It's so huge. It's a Catalan number. So with the number of components, it's exponential in nature. So it is a computational problem, and yeah.
It's scalar number if you are doing the syntactic analysis. Then many lexical units are there, what all lexical units are possible. So that number we have not calculated, I think.
Audible? Yeah. I just want to add one more point here. The number that was shown earlier was no. So this. One second. So this number is not actually the exact. This is based on the part of speech, the number of segments that is shown here. But if we choose, let's say some. Yeah. I'll give another example. So this is like 45,000 solutions here. But if you choose Vidahinaha, there are 6 possibilities. So 45 into 6. If you're looking at a fine-grained analysis, then the number of solutions is multifold. And also, Ishtaha, let's say Ishtaha. There are so homonymy and syncretism both play an important role here. And if you see, there are 3 forms of like 6 forms of Ishtaha, 3 from the Ish dhatu and 3 from the Yaj dhatu. So again, it's the number of possibilities if you use the morphological analysis is like multifold. It increases much. So if you are fine-graining things, then it will be even more complicated. And with compounds, and it's a complex task. And one more point to be added is the representation of compounds. So here we have, this is simple. It's not simple. We can easily identify Katu, Amla, Lavana, Atyushna, etc. For some compounds like Akirti, Karam. So where we have the privatives. So whether Akirti and then whether it is Akirti and then Karam or Akirti Karam. So the system is unable to decide at this moment. So with more analysis with compound, then possible.
Any more questions? Let's thank Mr. Sriram once again for his wonderful.
Thank you.
Just to sum up this particular session, Prakriyotpadini Shigram Arunena Vicharchitam Somaya Darshita Navya Samvada Vishayatmika Hyanuvade Mitra Karyam Darshitam Katkritam Mahat Veda Patasya Vishaye Rishikeshasya Sadhanam Sriramena Nava Suchi Heritage Sandhikarini Sarvam Samyak Shubham Bhuyat Gachamo Bhojanaya Vai.
देवादिवन्दित महागणपतिं मनसा स्मरामि Krishna 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 ni begare baro Krishna ni begare baro Krishna ni begare baro Krishna ni begare baro begane baro mukhavanne toro begane baro mukhavanne toro begane baro mukhavanne toro Krishna ni begane baro 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 ni begane baro. Krishna ತಾಯಿಗೆ ಬಾಯಲ್ಲಿ ಜಗವನ್ನು ತೋರಿದ ಜಗದೋದ್ಧಾರಕ ನಮ್ಮ ಜಗದೋದ್ಧಾರಕ ನಮ್ಮ ಉಡುಪಿ ಶ್ರೀ ಕೃಷ್ಣ ಜಗದೋದ್ಧಾರಕ ನಮ್ಮ ಉಡುಪಿ ಶ್ರೀ ಕೃಷ್ಣ ಕೃಷ್ಣನೇ ಬೇಗನೆ ಬಾರೋ. ಕೃಷ್ಣ ನೀ ಬೇಗನೆ ಕೃಷ್ಣ ನೀ ಬೇಗನೆ ಬಾರೋ.
राम राम राजेश्वरा रघुवंश सुधा बुद्धिचन्द्र श्री
No, we're happy not to have monitor.
Yeah, it's fine. We want to see if the projection will. Okay, we'll check that after.
Have you got your headphones, Heather? Yeah. We'll see that. Might help to bring them out. I've So we might only be getting a mono feed. Yeah, I might only be getting a mono feed. Just give me a... Yes, mine is working, but Heather's isn't. So we might just be getting one mono feed from the system at the moment. But also I'm not getting the keyboard yet either. Well, you're good. It might be that it's not seeing them. Give me a sec. Device.
Hello. हरि ओम् सर्वेषां नमस्कारः स्वागतं च हरि ओम् सर्वेषां नमस्कारः स्वागतं च तृतीयं सत्रमिदं so we are having one presentation and 4 demos. Keep your So the first presentation is on Anuprasa identifier and classifier, a computational tool to analyze Sanskrit figure of sound. Presentation by Amrita. Amrita is pursuing PhD on Alankara. It is under the guidance of Professor Amba Kulkarni Madam. So please. Namaste everybody. I am Amrita. I am presenting my paper on Anuprasa identifier and classifier, a computational tool to analyze Sanskrit figure of sound. I know this is a bit difficult to listen to the session after lunch, but okay. So in the scope of the research in Sanskrit computational linguistics, we see many tasks have been done and it has been doing, but many have focused on upon the linguistic and grammar oriented aspect of the language, like segmentation and other tasks. But very limited focus we see on, has been given upon the language rhetoric and its processing and evaluation. So matter identification is one of the tasks which has been exercised in ample, and one more Alankara identification and classification task on Yamaka is also done. Now we are doing it for Anuprasa Alankara, an identifier and classifier tool. Alankara is one of the 6 schools of Sanskrit poetics, that is Rasa Alankara, Riti, Dhvani, Vakrokti and Auchitya. There are 3 categories of Alankaras, namely Arthalankara, that is figure of speech, that is ornamentation of meaning, includes semantic complexities, and the examples are like Upama, Utpreksha, etc. Then Shabdalankaras, these are the figure of sound, which consist of the ornamentation of the words and sounds are derived from the words, pronunciation, and it also includes the word play. For example, Yamaka and Anuprasa. And Ubhaya Alankaras are the combination of above 2. Then what is Anuprasa? Anuprasa is the repetition of consonants akin to alliteration in English. It is the phenomenon of Anuprasa includes the repetition of consonants, that is the sound repetition in a shloka or even in the gadya, that is prose. It plays a significant role in enhancing rasa in the poetry, and it is different. Yamaka has the repetition of longer sequences, but not the syllables. It has it consists the longer sequences, and then because the longer sequences can be words sometimes, and and each repetition has different meaning in Yamaka. So it may hinder the understanding of the meaning. Yamaka is used in metrical verses, and Anuprasa can be used in Gadya and Padya both. Here is one example of Anuprasa, that is Asauhi Rama Rati Vigraha Priya Raha Pragalbha Ramanam Manogatam Ratena Ratrim Ramayet Parenava Nachedu Deshat Tarunah Paroripuhu. Here we can see the repetition of Rakara with different vowel endings, that is Ra, Ra, then Ri, again Re and Ru, also Ru. So these Rakara with different vowel endings has been repeated in this verse, and That's why it gives us a different kind of experience in the reading the shloka. So this is an important alankara. The conceptual development of the types of alankara. Firstly, it was introduced in Natya Shastra, which is considered as the first book on rhetorics in Sanskrit, written by Bharatacharya, who is the father of Sanskrit poetics. It was introduced as one of the subtypes of Yamaka Alankara, that is Mala Alankara, Mala Yamaka. Then Bhamaha established it as a separate Alankara than Yamaka, that is Anuprasa. This Anuprasa is also has different definitions and different classifications by each of the acharyas in the tradition. So it depends upon the variations in the repetitions and categories of the repeated consonants, then number of the repetitions and mood emergence due to the repeated use of the various consonants. So some of the notable classifications I am mentioning here. There are two-fold classification by Bhamaha in 6th century, that is Gramyanuprasa and Latanuprasa. Then six-fold classification by Bhojaraja, that is Shruti, Varna, Vritti, Lata, Pada and Namadvirukti. Then threefold classification by Udbhata and Mammata, that is Chekanuprasa, Vrittyanuprasa and Latanuprasa. Then twofold by Jayadeva, that is Phutanuprasa and Arthanuprasa. Then fivefold by Vishwanatha, which is we are taking for the implementation of the tool, that is from 14th century, and it includes Chekanuprasa, Vrittyanuprasa, then Shrutyanuprasa, Antyanuprasa and Latanuprasa. So Vishwanatha's classification, why we are taking this classification amongst which I mentioned before, that is because of it is a well-defined theory. It also provides a clarity for implementation. Then it includes other prominent schemes which are mentioned. Then it uses widely accepted nomenclature, and it also encompasses various dimensions such as number of repetitions, order of repeated letters and types of repeated letters. One point again I want to mention here, it comes in the later part of the tradition, that is 14th century. So it undergoes all the changes which happened in the tradition. So that's why we took Vishwanatha's classification amongst these two, these all. Vishwanatha's classification has 5 subclasses. So first is Chekanuprasa. It includes one repetition of consonants with same sequence. For example, in Kaveri, Vari, Pavanah, Pavanaha. Here, the bold, which are in bold letters that are repeated. So V and R are getting repeated in same sequence. Veri and Vari. The vowel endings are different, but the sequence is same. Again, Pavanaha, Pavanaha and Pavanaha. Here, Pa, Va, Na and Pa, Va, Na are getting repeated. Then Shrutyanuprasa, the repetitive consonants belonging to a specific set having same location of articulation. That is, various locations have been described in the tradition. Those are Kanthya, Talavya, Murdhanya, Dantya and Oshtya. So here is one example. Drisha Dagdham Manasijam Jivayanti Drishaivayaha. Here Ja and Ya are articulated from the Talavya. So due to their repetition in a proximity, it gives different kind of experience. So this is in Shrutyanuprasa. Then Vrittyanuprasa, more than one repetition of consonants to evoke a specific mood or emotion, that is Vritti. Here the sequence is not considered, only the repetition of some consonants is considered. That the repetition can be more than one type. Here Kridak Kokila Kakali Kalakalai Rudgirna Karanajvara. So Ka and L are getting repeated, and the repetition is more than one time, and the sequence is not followed. So sometimes there is a ka before la and la before ka. So this is in Vrityanuprasa. Then Antyanuprasa, the repetition is in the end of the pada or a pada. For example, mandam hasantam prabhaya lasantam janasya chittam satatam harantam. Here makara is at the end of each of the many words. Then it also can be padantyanuprasa is the repetition of same sequence at the end of each of the pada of a verse. So here the first pada ends at mandam hasantam prabhaya lasantam. The lasantam is the end of first pada and harantam is the end of second pada. So makara is at the end. So that's why this is also an example of padantyanuprasa. Then latanuprasa is the repetition of words with the same meaning and different implications. That is tatparya. This is the example. Smera rajiva nayane, nayane kim nemilite. Here the first nayane is in the samasa, and so that's why it refers to a person, not the eyes. The second nayane refers to eyes, but meaning is same, but tatparya is different. So this is an example of latanuprasa. The implementation of the tool, we are first identifying and also classifying these types at the same time. So the order which we have followed is like this. First we identify latanuprasa, then chekanuprasa and vrutyanuprasa. After that shrutyanuprasa and antyanuprasa. Why we follow this order? You can see in this table, latanuprasa has the count of n grams we are considering in latanuprasa, chekanuprasa and vrutyanuprasa. The frequencies of n grams considered in latanuprasa is more than or equals to 2. The order of the consonants is consonants or syllables is same. The unit is sequence of syllables including vowels. Then the position of the position in the input is next to each other or with a few interventions. Then chekanuprasa, the count of the repeated consonants should be 2, and the order should be same. The sequence of syllables without vowels is considered unit, and position of the input is in anywhere within a proximity. Then vrutyanuprasa, there are two conditions. That is, if the sequence of consonant, there is no sequence. So in vrutyanuprasa, the count should be if there are two conditions. If a sequence of vowels is considered, the count should be greater than 2. If the length of n, that is the sequence which we are considering, that should be greater than 2 or equals to 2, then the input position should be anywhere in the proximity. Srutyanuprasa, if the count of the n-gram, if the length of the n-gram is greater than or equals to 2, the repetition should be more than 2 times, and it should be in the proximity. And if only single consonant is getting repeated, the sequence should be greater than or equals to 2. So like that, Shrutyanuprasa is the repetition. The frequency should be greater than or equals to 2. The syllables from the same place of articulation are considered as a unit. And in Antyanuprasa, the count we are considering is greater than or equals to 2. The unit is syllables after the second last vowel. So and the position should be end of the feet or words. The implementation we are doing, I already mentioned some points from here. We first do the normalization. We ignore spaces between the words and normalize variations in nasalization, that is anunasikas. We convert all the anunasikas to anuswara and ignore special characters like avagraha and danda. Except for Padantyanuprasa, that is if it is a verse, we consider it we consider it for Padantyanuprasa identification, and first we divide the input into 4 equal parts and then match the endings of each of the part. Then for Padantyanuprasa, we consider word endings which are we are not using any segmenter for this. We are considering the space separated strings for this. Then for n-grams, if the length of n is greater than or equals to 2 with and without vowels, for we consider them for Latanuprasa, Vrutyanuprasa and Shrutyanuprasa. So if the frequency of n-gram including vowels is greater than or equals to 2, we consider it for Latanuprasa. Then if this condition is passed, we check for Chekanuprasa. The frequency of n-grams including vowels is greater than is 2, not greater than 2 but 2. So we have kept some filter in between these three. If Latanuprasa is already recognized, it will not go to Chekanuprasa. If Chekanuprasa is already recognized, it will not go to Vrutyanuprasa. So if Chekanuprasa is not analyzed, it will go to Vrutyanuprasa and look for the frequency of n-gram, which has n greater than or equals to 2, excluding vowels is greater than 2, or the frequency of single consonants is greater than or equal to 2. So we are also considering the distance in between the repetitions to ensure the proximity of repetitions to prevent reader distractions. The reader will not remember if the two repetitions are too far from each other. So to prevent that, we are applying this calculation. The maximum distance considered based on indices of repeated consonants, it is approximately 4 to 5 aksharas. The interface is available at sanskrit.uohyd.ac.in/scl. I have already kept some screenshots, but I will show a demo also. As Wi-Fi is not working here, so I am showing my local version. I am giving an input in Devanagari. So there are various encodings which are encoded. So it is visible now. So various encodings we have incorporated. So the user can give input in various encodings and output encodings. So I am giving this input. Tatoruna parispanda mandikruta vapushyashi dadhe kama parikshama kamini ganda pandutam. So we select the alankaras. The 2 alankaras are available. We are selecting Anuprasa and then we click on submit. So it has recognized Latanuprasa in Pari in this shloka. Then Chekanuprasa, as we see the repetition of the in a same sequence, and it is twice. So it is Chekanuprasa, then Re Kama and Re Kshama. So why Ma is not highlighted? Okay. Then Kamini Ganda Pandutam and Ndu. So this is also an example of Chekanuprasa. Then Nrutyanuprasa, the repetition of Takara is twice. But a single consonant is considered in Nrutyanuprasa, not a sequence. So Takara is considered in Nrutyanuprasa. Then Pari, Spanda, Mandikruta Vapushashi. So R and Pa, then Shashi, then Shakara. So these are the repetitions considered in Vrityanuprasa. Then there is no Antyanuprasa in this shloka. Then Shrutyanuprasa, there is a repetition of Ra, then Sha, then Ana and Da from Murdhanya Varga. Then Dantyanuprasa in Takara, Sakara, then Nakara and Vakara, also Dhakara. So this is considered in Dantyanuprasa. Then Oshtya, that is Pa, Ma, Va. Okay, so these are this is an example of Anuprasa. So more than one type of Anuprasa are in this shloka. So you can try various examples on the tool. Then we have evaluated this tool with 70 verses and 10 sample pros. Because this data set is very small, but it includes all the rules which we have provided to this implementation. So it was enough to test this tool. The correct analysis were in 62 verses and pros were correctly analyzed. And partially incorrect analysis were in 8 verses, because we have kept this filter of Latanuprasa, Chekanuprasa and Nrutyanuprasa. So if any example of Chekanuprasa is already analyzed in Latanuprasa, it will not be shown in Chekanuprasa. Similarly with Nrutyanuprasa and Chekanuprasa. Then Antyanuprasa, it relies on the spaces and dandas provided by the user. So if input has wrong spaces and it has not any danda, so it will not be considered under Antyanuprasa. So these were the reasons for incorrect analysis, and we are considering it as a foundation for figurative language processing in Sanskrit and other Indian languages. As well, this model can be adapted for identification and classification of Anuprasa in modern Indian languages like Hindi, Marathi, Telugu and Kannada. These languages also have this Anuprasa in their poetics. So this model can be adopted. Then it can be extended to for other classification schemes in the tradition. Also, Vrityanuprasa, a type of Anuprasa, offers avenues for extensive research on identifying rasa through repetition of consonant clusters. And it is also useful for teaching Anuprasa and demonstrating various examples. It provides a tool for testing upcoming masterpieces in Sanskrit poetry also. So thank you for listening to this presentation, and questions are answered.
Thank you, Amrita. Actually, processing of Alankara is very difficult. But once if we can do this, it's very much helpful for students and teachers like us. It's a very good effort. Now we have 10 minutes for discussion, but I just want to ask one thing. This Anuprasa, can we give non-Aniprasa verses also? So Amrita, can we give this non-Anuprasha verses also? Then what you will produce? Any example, any sloka if we give, any other alankara.
Okay. Any other alankara it will not analyze. Only two alankaras we have till now we have provided. Other alankaras we are about to for other alankaras we are going forward. So
okay, thank you.
I must be one of the first users of this tool. So I've already made a paper in Russia on Vishnu Sahasranama based on the work of this tool. So I must say I'm impressed. It helped us a lot. The only thing I missed and still miss is the possibility for batch analysis. Otherwise, I would say it's a gem. Thank you. It's of practical use, both for pedagogical purposes and for me, trying to find why is the Vishnu Sahasranama so beautiful. So your tool already helped me. So I say thanks to you.
Thank you so much. Thank you so much for your appreciation. We will definitely think for the batch input. So we will work on it.
Thanks.
So regarding Dantyanupras, Murdhanyanupras, etc., does the tool over-generate or how do you control? Because there would be बहुत सारी जगह पे same वर्ण के होंगे.
Yeah, in three types I already mentioned. It has filter. So in three there is no overlapping. Means one verse can have many types of anuprasa. So it shows.
No, I understand. So let's say there would be many cases in which there would not be any alankar or there would not be any visible pattern, but still the would be appearing at random places, not generating any sense of aesthetics. So how do we kind of see कि इसमें रस है इसमें नहीं है, ये बेकार सा th लगाया है इन्होंने.
This is a bit difficult, but in sthana shrutyanuprasa. So it will produce. If there are it is in proximity, it will produce. So it will definitely have some effect.
Hello. Yeah. So when you say proximity, is the verse a unit for the alankara? Like can a set of 3 verses? I mean, what is the unit that is considered for alankara? Because this will also relate to the batch processing. So if you want to run this on 10 verses, if something is repeated in first line of each verse, or every verse starts with the same word, is that considered the same thing, or
this is not considered? We are mentioning aksharas. So
no,
aksharas is
in literature, would you call it an anupras if same sound is repeated in the first pada of each verse? Is that considered as an anupras in that
that is
kavya?
not anuprasa. That will be different than anuprasa. It will be considered in shabda chitra or something.
Okay. So the verse is the unit. Right?
Yeah.
And one more question, not related to anuprasa, for yamaka. What is in I think as far as I understand in Marathi, yamaka is thing that matches at the end. So if the same sequence is mattered at the end, but I think in Hindi and probably in Sanskrit, if the same word needs to be used in different senses.
Yeah,
so is that
that is true.
Okay.
In Marathi, the Marathi yamaka will considered in anuprasa Sanskrit.
nice work. I just had a question, follow up on the previous point of batch processing. So when you are writing a poetry, what is considered better? I mean, is the context of the previous verse important for understanding what is the alankara for the next verse? Like when a poet is composing a series of verses, would you want to put variety in alankaras, or would you want to repeat alankaras that were in the previous verses? So can the context be helpful for the next verse? That's my question.
Yeah. As a poet, if you are forcefully adding some alankara that is not at all considered in the poetics, if you by flow you are adding alankaras, naturally you are adding alankaras, that is more appreciated. And if you are adding repeatedly that alankara, that is you want to show that you are using this alankara. So if you want to like some that is some of the kavyas are yamaka kavyas. So poet has used yamaka in each and every verse. So different kinds of yamakas are there. Yamaka Bharatam is also one of the yamaka poetry. So this is we considered Kalidasa and other prominent poets, they don't do like that. They will naturally in flow they will write the poetry, and after that when reader or any commentator will read that, he will mention this alankara is there. The poet will not forcefully add this alankara. So this is.
Any other question?
Two things, like the tool which you have developed and it gives all the list of the alankaras, right? If the identification of the alankara, and you say like in between when you said about Vrityanuprasa in the particular example, it had tato in the starting. So if it doesn't have a poetic sense, do you have to still call it as an alankara?
Yeah. Sometimes anuprasa is like if there is a very so much like where? This example is also there. So you will not recognize this is anuprasa, or it will not be like explicitly you will not feel like this is anuprasa, but it will have some effect that comes and it adds to the rasa. If in place of tato in place of ta, if ta was used, it should give some different kind of experience. This ta is soft and ta is very harsh, so it gives something to the reader.
But shouldn't it be that it has to be, the repetition has to be not just two, it should be more than that?
Yeah,
because
but,
for example, if you take Kridat Kokila Kakali Kalakala, for example, that makes a really good poetic effect. But with just two letters like Tato or Shashi, do you think it actually comes?
Yeah, if we if Sha is Sha and Ta have some similarity in the pronunciation. So both groupingly give that effect. So this also can be considered as anuprasa.
And other thing is that if we say that there is almost like in this particular example, almost all the alankaras are there.
Yeah.
Doesn't it become like a khichdi of alankaras? And
but
does it actually give a...
one will be more prominent, or two will be prominent. Like here, pari is not that much effective. It is quite in a distance, but it will not be that much effective. But other like the Dre Kama Parikshama Kamini Ganda Pandutam, it is there.
Okay, shall we wind up? Amrita, if you give this complete word, Vibhakti Sahitam, Latanuprasa, see, this is Hindi. If you give Sanskrit, that is better. And one more thing, when you consider other languages, you consider Malayalam first, because that is very similar to Sanskrit. All rules, name itself is same in Malayalam.
Definitely.
Thank you, Amrita.
Thank you.
It's
Thank you so
nice
much.
presentation. So, next we have demo on content management platform for Vedic Sanskrit scriptures by Ravi Panja and Ramana Arimilli. It's online, I think. Welcome, sir.
Sounds good. Okay, thank you. Yeah. Can you just put it in my pocket? Good afternoon. My name is Ramana. I'm part of this organization called Swarupa. It's a non-profit based in California, but we have a development team in Hyderabad. So what I'm presenting today is a content management platform for Vedic scriptures. And the inspiration or the vision for this is from Swami Sri Atmananda from Satchicetana Mission. And a lot of the, I want to acknowledge Dr. Amba Kulkarni, Professor Hewitt, and Oliver Helwig for their the phenomenal work they've already done and that we are taking advantage of to come up with some of the segmentation and the morphological analysis for Vedic padas. So there is some gap between Sanskrit and Vedic padas, and we've taken care of some of that with the help of Dr. Amba's team. In particular, Sriram was very helpful in doing that. So what we are offering is this, what the vision was is to enable the entire humanity to have access to the wisdom that's locked up in the Vedas. And the way that Swamiji has given guidance is to come up with, first of all, core data set or a foundational data set, which has the mantras, the padapata, and the grammatical analysis, and make that available on a platform on which various scholars can utilize that and come up with their own ways of analyzing the meanings and so on and so forth. And based on that, other people can write some higher abstracted articles, and so on and so forth. That's why we chose this idea of a content management platform. It's similar to something like a medium.com, if you're familiar with. So the unified data set that we've accumulated so far is the 5 samhitas. Rig Veda Samhita, single recension of these. Yajurveda Samhita, Shukla Yajurveda, Krishna Yajurveda, Samaveda, and Atharva Veda. And the commentaries associated with that, Sri Dayanand Saraswati ji and also Sayanacharya ji's. And from a processing perspective, the derived content, we utilized Sanskrit Heritage Engine, where we pass the padas from each Veda mantra and get the analysis. And SH is used first because it gives a comprehensive analysis, doesn't limit things. Some sadhini, which is the next level of analysis. And then finally, if we don't find the pada, we look up in DCS. But that's only for Rig Veda and Atharva Veda. And then we have some curated content that some Mahatmas or Sanskrit scholars are adding to this platform. And then we also integrated the Veda Samhita mantras, audios. For every mantra, we captured audios by processing from various Veda Pathashalas, we've collected audio. And we used speech-to-text and text-to-speech analysis to take like for example, a sukta level audio clip and break it up into chunks so that we can get mantra level audios. I'll show you some of that. And Swamiji also mentioned to us that this should be accessible to across all kinds of devices. So we have developed this web app and also iOS and Android apps. And I'll show you a demonstration of the iOS app. The next step is basically using this framework or repository of information. We will encourage many Sanskrit scholars to utilize this data and come up with their own interpretation of the mantras. And we're hoping that in particular, Swamiji has suggested that we capture something like an Adi Bhautik, Adi Daivik, and Adhyatmic meanings, and not limited to the way analysis was or meanings were derived in the past. And also support some AI and other new technologies. I think there were a couple of presentations that are taking advantage of this raw data set that can be fed into like an LLM or something else to develop like a conversational interface and other applications. So this is the text data processing that we do. We captured from various spreadsheets, manually entered data, and so on and so forth, the Samhita mantras. And we cleaned it up by looking at manually, we verified the data and then fed it to Sanskrit Heritage first. And then next step to Samsadhani, and then finally to DCS, extracted data from DCS. And padas that were not processed, we manually took care of them, and that is the manual processing step. And Dr. Pataskar and Dr. Sathe were very helpful in doing this. They're from Pune. And we also took care of, before the padas are sent to these engines, we processed the Itikarana, cleaned that up, upasargas and avagrahas, the compound terms, because these were not handled by the engines. So that's how we kind of loaded the data. This is the process for that. And then as far as the audio is concerned, so we took the sukta level audio clips, because when they chant in these Veda Pathshalas, typically they just it's a continuous chant. They don't stop, give a break after every mantra. And we use this silence to split initially, and then made it consistent so that the Whisper large language, large V2 model that we use that does the speech recognition, we found that if the spacing is somewhat consistent, it performed better. So we took the silence and extended it, like we created like 1 second silence in between wherever the silence was noticed. And then the transcript generated basically, it's not exact match to the original text, but it gave us, as it sounds, essentially, the mapping. And then we created for this whole Samhita this predicted text corpus, and then we compared it with the actual mantra text. And we were able to, by matching it, we were able to derive timestamps for not only every pada, but also for the entire mantra. And we were then able to split the audio into mantras, into mantra level clips. So that's the presentation, and let me go into the web app first. So as I mentioned, this is a content management platform, so you'll see a whole bunch of stuff, people writing articles on various topics, but I'll focus here on scriptures. And the 5 samhitas that I talked about, Rig Veda, and as an example, we show all the mandalas, and you click on mandala, takes you to the sukta list, and you can play the audio, you can upload new audio clips, You can edit these definitions and so on and so forth. At the sukta level, if you click, it goes into the mantras. And for each mantra, there's a whole bunch of information that we capture. The deity, the chanda, and the rishi involved, and then the padapata, individual terms. I'll come back to this a little later. Anvaya by different people. I think it's set to English. So, for example, Maharshi Dayanandji and Sainacharya and so on and so forth. Padarth, again, Maharshi Dayanandji. And attributes like that, bhavarth, commentary on it, the purpose for this mantra, how to use this mantra, seeker experiences. As people utilize this mantra in their sadhana, what do they experience if they can document some of that information? What's the uniqueness of this mantra? And Swamiji has always mentioned that the deity and the chanda have a very specific meaning, and that needs to be captured. And that's why we had these attributes where people can enter information. And connection with, of the mantra with the sukta, what is the relationship there, and connection with the Upanishad. These are his understanding, from his experiential understanding, he has come up with these attributes, and that's how we've listed them here. Going back to Padarth, this is where the Padapata. So you click on the Pada. This is where we do the segmentation and morphological analysis and fetch the dictionary meaning. And we use the ambuda.org. You heard Arun Kumar earlier today. We use an interface that he provided to get the dictionaries. So it provides the grammar here, the morphological analysis, and access to various dictionaries. From DCS, we get the meanings. Shabdasagara, for example, and so on and so forth. So that's, and you can play the audio for this particular mantra. And we've recorded different styles of chanting. Looks like I'm running out of time. I quickly do the mobile app demo. It's a little bit tricky. The AV Viz back there helped me figure this out. So I have to start QuickTime and all right. This is the iOS app. It's identical to the content, and the functionality is identical to the web app, except that there's no way to edit information. On the web app, I didn't show you some of the editing capabilities, like the grammar and so on and so forth you can edit. Same thing, you go down here, click on scriptures. Let me see, maybe I should do this. Normally it's pretty snappy, but I guess the internet connection. So click on the Rig Veda. So it's pretty much the same, the mantra, the padapata, anvaya, padartha, and so on and so forth. So you go into padapata, you can click on any term. Shows the grammar at the bottom, and then the dictionary meaning, you can click on that. I think I'm running out of time, so thank you so much. Any questions?
Any questions?
I'm extremely interested.
Thank you, thank you.
Development by competent pandits, but I'm kind of worried about the blog. How would you avoid pollution by ignorance? Crowdsourcing is dangerous.
So there's a team that we're building that would be actually the content as the people post it is not going to get published right away. It'll go through curation process of people verifying it either from both. We are recruiting people now from Sanskrit scholars, Vedic Sanskrit scholars who will be able to do that.
Okay. So you can weed out nonsense.
Yes.
Search for a particular mantra in more Ved than one?
Search for the mantra?
Yes.
Yes.
And will it go through all the Samhitas?
All the Samhitas.
Okay, great.
You can search for Rishi, Devata, Chanda, a particular term, Pada.
Thank you, sir. It's a great work on Vedas.
Thank you so much.
So we'll
Namaskar.
move for next presentation. So next presentation by Sri. Hari Om. So next presentation is on automatic detection and evaluation of Varna Chitra by Sri Dilip HR from Infosys, Mysore.
Hello, hello, hello. It's good. Hello, hello, check, check, hello, 1, 2, it's good.
Namaste, good afternoon. Today I'll be presenting my work on automatic detection and evaluation of Varna Chitra. So first let us look at what is Varna Chitra. Varna Chitra is a type of Chitra Kavya. So basically out of Arthalankara and Shabdalankara, this falls under Shabdalankara. And Varna Chitra is poetry that makes use of a limited set of letters of the alphabet. It basically displays the skill of the poet, and it is suitable for hymns, narratives, and descriptive poetry. This is in contrast with the typical Rasadhvani which we encounter, and it is considered inferior to Rasadhvani. And Varna Chitra has been described mainly by Dandi in his Kavya Darsha and also Bhoja in Saraswati Kanta Bharana. We also see that scholar poets like Bharavi, Magha, Ratnakara, Shivaswami and Vastupala have employed Varna Chitra in their poetry. Coming to the types of Varnachitra, we have 3 types of Varnachitra. The first one is Swarachitra, second one is Vyanjana Chitra, and the third one is Sthana Chitra. As the name suggests, Swarachitra is use of a limited set of vowels, and we consider both the independently occurring vowel and also that which occurs in conjunction with consonants. Coming to Vyanjana Chitra, it is the limited use of limited set of consonants. We usually consider the Sandhi form and also conjunction with vowels. We have a couple of exceptions here, like Varga Panchamakshara and Anuswara Visarga are not considered. And also the last letter of the Pada and Padya need not conform to this rule. And the third one is Sthana Chitra. Here it is use of a limited set of letters. It can be either vowel or consonant based on their place of articulation. So we'll be looking at each of them in detail in a while. Here again there are 8 places of articulation, and the 3 places, Jihva Muliya, Urasya and Nasikya, are not considered. So basically this can be attributed to the sound of the language and also the aesthetics of poetry. Again, here we have exceptions like Anunasika, Anuswara and Visarga are exempted from the rule. Let's get into the details of each of them. First is Swarachitra. The first is Hrisvaika Swara. So this is like in decreasing order of complexity. So the most difficult is Hrisvaika Swara, where only one short vowel is used in the Padya or Shloka. So all this applies at the Shloka level. It is not, suitable for batch processing. And the second one is Dirghaika Swara, where only one long vowel is used. So similarly, we have Hrisva Dviswara and Dirgha Dviswara, where 2 short vowels and 2 long vowels respectively are used. Hrisva Triswara uses only 3 short vowels, and but we don't have corresponding part of Dirgha Swara, but we have Chatuswara Dirgha Swara, which uses 4 long vowels. The next item is Prativyanjana Vinyasta Swara. So in this case, there is no use of an independent vowel. So all the vowels are used in conjunction with consonants. And the last one is Apasta Samasta Swara, where again there is no independent vowel, but the only vowel used is A. So it can be considered as a subtype of Prativyanjana Vinyasta Swara. So these are the types of Swarachitra. And in the tool which has been developed, we can give the input of a shloka, and it will detect the type of Varnachitra. It could be any of the 3 types. And when we give this particular shloka, it is detecting Hrisva Triswara. The tool also provides facility to do an evaluation. So it will evaluate the given input for all the possible Swarachitras. For example, in the first one, we have Hrisvaika Swara. The green color denotes where it is conforming to that requirement, and the red one shows where it is not. So basically, if we look at this tool as an aid in writing poetry, or in case of Avadhanam, we can clearly figure out where there is a deviation from the requirement. Similarly, the second one is Dirghaika Swara. It is again pointing all the conforming ones and non-conforming ones in the color green and red respectively. So similarly, Hrisva Dviswara and Dirgha Dviswara. And it is correctly showing Hrisva Triswara, all of them in green, because it is 100% conforming. Chatuswara Dirgha Swara, again, if we want to conform to that rule, certain changes have to be made so that it can be a Chatuswara Dirgha Swara. And Prativyanjana Vinyastaswara, you can observe that there is a U vowel used. So except for that, it is conforming. So if the poet wishes to change it, then it will conform to Prativyanjana Vinyastaswara. So this is about Swarachitra. Let us move on to Vyanjana Chitra. There are actually many types of Vyanjana Chitra. The first one is Chaturakshari, where 4 consonants are used. It can be any consonants, the choice of the poet. Triakshari, again, 3 consonants. Dvyakshari is 2 consonants. Ekakshari is 1 consonant. So again, this is an increasing order of complexity. So making use of 4 consonants is relatively easy when compared to using only 1 consonant, Ekakshari. And we have only a handful of examples of Ekakshari in entire Sanskrit literature. The next one is Kramastha Sarva Vyanjana, where in a shloka, all the consonants they occur, and in the natural order. Again, these are very difficult to find examples. Chandokshara Vyanjana is like only 10 types of consonants can be used. The first 8 set of Gana consonants and also the 2 Sanya consonants. Only these Vyanjanas can be used in composition of poetry. Then we have an interesting Shadjadi Swara Vyanjana, where the 7 musical notes, Sarigama Padhani, only are used in writing the poem. And similarly, we have Murajakshara Vyanjana, where the 16 consonants used while playing the drum. Muraja basically is the drum. So the 16 consonants used while playing the drum, which has been listed here, only these can be used. Then it becomes a Murajakshara Vyanjana. Asamyoga is, there is a restriction that should be no Samyuktakshara. Then it becomes Asamyoga. And similarly, based on the number of Vyanjanas used, we have Sapta Vyanjana Bandha, where 7 consonants can be used. Dasha Vyanjana Bandha, where 10 consonants can be used. Apancha Varga. So no Vargiya consonants can be used. The poetry has to be written only by using Avargiya Vyanjana. And Antasthakshara is where only the 4 consonants, Yara, La, Va, should be used in writing the poem. And Atri Varga is where no consonants from any 3 Vargas should be left out. So basically, out of the 5 consonants, from 2 Vargas can be used. Talavya Praya is only the palatal consonants can be used in composing poetry. Apunaraktakshara is that once a consonant is used, it should not be repeated again in the shloka. Then it becomes Apunaraktakshara. Here again, I have provided a screenshot of how the tool behaves when we input Vyanjana Chitra. So it is correctly detecting Asamyoga and Apunaraktakshara in the input shloka. So similar to Swarachitra, again, we have an evaluation possible where the given input is evaluated against the requirements of all possible Vyanjana Chitras. So the green ones are conformant and the red ones are non-conformant. So as we can see at the last Apunaruktakshara, so everything is green, so it is 100% conformant. Coming to the last type, which is the Sthana Chitra. Here again there are subcategories. The first subcategory is Chatusthana Chitra, where out of the 5 which I described a bit earlier, one of them should not be used. So Nishkanthya is that no gutturals can be used. So on the same lines we have Nistalavya, Nirdantya, Niroshtya, Nirmurdhanya. So these are the 5 types of Chatusthana Chitra. So making it more difficult, it is Tristhana Chitra. So Niroshtya Dantya, Oshtya and Dantya should not be used. And Oshtya Murdhanya, Niroshtya Murdhanya is Oshtya and Murdhanya should not be used. And so increasing the complexity, so Dvisthana Chitra, we should be using only Dantya and Kanthya. So other combinations are theoretically possible, but we don't find them mentioned in poetic works. And Ekasthana Chitra is, for example, Kantya. The only gutturals should be used. Again, this is based on the aesthetics and practical feasibility of writing poems. This is again a screenshot from the tool where it is detecting several types of sthana chitras. Nirdantya, Niroshtya, again it is obviously Niroshtya Dantya also. And it is also saying it is Prativyanjana Vinyasta Swara. There is no independent vowel. The evaluation part. So Nirdantya, Niroshtya, Dantya. So all the three are 100% green, saying it is conforming. And wherever it is not conforming, it is shown in red. So this helps the poet to figure out what can be done. Coming to the uses of this Varnachitra tool, it acts as an aid in composing poetry. It also helps in analysis of poetry. Evaluation of poetry in case of Avadhanam and also in cases of Yakshagana. Yeah, this is the main reference I have used, Professor T. V. Venkatachala Shastri. And I would like to acknowledge the guidance of Dr. Mohan Raghavan, Head Department of Heritage Science and Technology, IIT Hyderabad, Dr. Ramakrishna Upadrashta from the Department of Heritage Science and Technology, IIT Hyderabad, and Dr. Amba Kulkarni of University of Hyderabad. This is the presentation of the tool.
Any question? No.
Thank you.
Fostering learner engagement in Sanskrit e-learning by Shankara Rama Sharma. So you all know about Vyoma Labs. It's an e-platform for learning Sanskrit basics as well as Shastra learning.
Mine. Yeah. योऽन्तः प्रविश्य मम वाचमिमां प्रसुप्तां सञ्जीवयत्यखिलशक्तिधरस्वधाम्ना अन्यांश्च हस्तचरणश्रवणत्वगादीन् प्राणान्नमो भगवते पुरुषाय तुभ्यम् यो नरः संस्कृतव्यो निह्यालयन् रमते मुदा संस्कृतिं चैव संस्कारं विन्दते नात्र संशयः. नमः सर्वेभ्यः. नमो नमः. We are here I am here on the behalf of Vyoma Linguistic Labs Foundation. A lot of you already know about it. Some of you are probably introduced to it for the first time. Is this because of? No? Okay. Yeah. So we are here to see how learner engagement is always a problem in e-learning. Like you sign up for a course and then you halfway through it, or even after first two classes, you just give up on it. So we are trying to improve learner engagement through various approaches. That is what we want to see here, how we are trying to foster learner engagement in Sanskrit e-learning. The whole Vyoma team is involved in this. It's just that I'm here on behalf of them to present this for you. So an introduction to Vyoma, the company was founded in 2012 to mainly enhance Sanskrit learning through technology. We try to blend both the traditional and modern tools to give the best of what is for all our learners. Our mission revolves around Sanskritam, Samskriti, and Samskara. Sanskritam is not just a language, it's a whole big knowledge base. It's a knowledge platform, and that is how Sanskritam is. So using Sanskritam, we want to build on Samskriti and Samskara. It's a culture and tradition and the whole of Bharatiyata that we want. So that is what we want to spread and ignite the lamps within each one of us through Sanskritam. That is our mission on SSS. So our salient points are some things that we will come to see. We will come to the slide at the end. We will directly go to our demo where, so for those who are not familiar with our website, this is our website, sanskritfromhome.org. So all of us can learn Sanskritam from home, starting from kids to all those who are advanced Shastras, whether it be Vyakarana Shastra, Vedanta Shastra, Tarka, and so on. So all those who are interested can learn Shastras from the comfort of their homes, which is why our website is called sanskritfromhome.org. And this is where all our courses are. So you can see we have more than 380 courses which are available. And we have quite a few learners and a lot of teachers who are supporting us. So we can see a lot of courses are here with which you can use your filters and many other things to find out which courses you are interested in. Most of our courses are live webinars, which are then always available for our users as pre-recorded material. So any course which has happened in the past, it will always be available to you. And some courses are rerun again and again. For example, those which are exam-oriented courses, which exams happen every 6 months, like Samskrita Bharati, Sura Saraswati Sabha, and all these can be used. They're done again and again, so that all the courses are available for all the students. And courses are available here. Then we have some things called learning programs, where we have curated a set of courses. You want to learn only Sandhi from basics, what is Sandhi, to using the sutras and the Sandhi and interactively learning. We have the learning programs. So these are some features in this website. And coming to the multimedia offerings that we have a lot of multimedia offerings, especially for kids, where they can learn rhymes and bhajans and many other things, shlokas. As you go down, you see this is a separate product. So these kinds of multimedia offerings are available both online and offline. So you do not want to give kids online access and just allow them. You want them to be within a particular this thing. You don't want to give them access to all websites. So we have offline access given in a pen drive, and such things are available for kids. We will see some of these here. For example, this one, I do not know whether the audio will play. So for Sankhyaha, we have something like this, and for kids, this is very nice. They can go, it can be used on the mobile also, or on a tablet or a laptop, so it's cross-platform. So you have some things like this, and then you have rhymes for kids, which are, this is also there as an app, as an Android and iOS app, which can be downloaded. It's called Shishu Geetani. It's playing, yeah. So this way, we keep the learners engaged, so that they're kids who want to see some things that is happening. They want to see some things that is happening. So these are you learn from poems and you learn from audio. You don't just see something that learn. It's all Shruti. It comes by listening. And this is for the next level, where you want to learn Ashtadhyayi Sutras. The traditional way of learning Ashtadhyayi Sutras, as a guru says, and then you repeat it twice or thrice, and then you go home back, and then you listen to it again and again. This is how all memorization happens, whether it be Veda Patha, or Ashtadhyayi Patha, or Gita Patha, or whichever it is. So we have this tool now for Ashtadhyayi and Gita, developed with the help of Hrishikesh ji, Dr. Hrishikesh, who's here. He has created the audio alignment tool. So this has been integrated with our platform. For example, if you see so you have a loop. You can just choose, let us say, I want to loop only from Iko Gunavriddhi to Halonantara Samyogaha. Then you can select Iko, you go to loop on, and then select the first thing, or let us go to Adeng Gunaha, and just say loop on. So that second will change there. And then you go to Ardha Dhatuke, select it, and then repeat it, and then just press the play button. So it will loop within those same things, so that you can listen to the same thing again and again and then memorize that. So it's a very good tool for memorization. The same thing is available for Bhagavad Gita also, and going forward, this can be adapted to any grantha that is required. Any scripture, the audio has to be aligned, which is already automated. The audio is just aligned, and we have that looping through. So there's a very nice tool that aids memorization. Then when we come to some of the things that we saw, like Sandhi and Samasa, where you learn step by step, we have a lot of games that helps the learners understand the Samasa. Let us see, Visarga Sandhi is there. So you have the Patha. First, there is the Patha, the lesson which examples. There is the rule explained in both English and in Sanskritam. Not only in text, there is also an audio which explains the whole rule. You can play the audio and listen to the rules. Then the rules are explained with a lot of examples. First, Udaharanam. Then you have the Koshtakam, which clearly gives you what the rule is. Then more examples. Then Yogyata Vistara with all the sutras and exceptions and many other things that are available. So this is the first. For a teacher, this would be very useful. If a teacher is going to teach in a class, whether it's a school teacher or in a Patashala, you're going to teach this. So this tool is going to be very useful. So most of us here are teachers and preachers of Sanskritam. We want to take Sanskritam to the mass. So this would be very useful. And then there are a lot of exercises that are there, both joining and splitting Sandhi. And then you have these kind of abhyasas, which are again very interactive. You go there, you choose Sarva Bhutebhya Datva, what is the correct answer. If you choose the wrong answer, it's going to show red. If you choose the correct answer, it's going to be green. And that way you can complete the whole exercises. Similarly, for more interactiveness, you have games like this, Nalanda Pravesha. So in the olden days, when you go to the Nalanda University, apparently the watchman who's the guard, he used to ask you some very difficult questions. Only then you get admission into the university. So this game is based upon that, where you have the guard asking you questions. Are you basic, are you advanced, or are you medium? And then you are asked certain questions, and then you go into the game. Advanced or intermediate, something.
मध्यमद्वारेण प्रवेष्टुम् इच्छामि.
अस्तु. प्रश्नाः एवं सन्ति.
So like this, tat chamanam equal to tat plus what? If you give a wrong answer like this, it's not going to allow you.
असमीचीनम् उत्तरम्. सरलस्तरं प्रति प्रेषयामि.
I will send you to the easy level because you're not given the right answer. So there are games like this which allow us to keep our concentration, and then you have computer-based assessments. So these assessments, you start an assessment, it opens it full screen, and you are within that assessment, which is very similar to how we would take online exams on various platforms now. So you can self-assess. It's a computer-based assessment, and this can be used to assess our students. So this is there for both Samasa and Sandhi, the whole, for all four various Sandhi, Visarga, Vyanjana Sandhi, and all various Samasas. This kind of things are there. If you see, there's a hierarchy game on this. Which Samasa would you do in this? Paradhana Haranam, which is the first Samasa you would do. If you give some wrong answer, that's how it is going to give you. Then that is also a wrong answer, the right answer. And there are negative marking and so on. So the games are very useful to keep the concentration of people. So game-based learning is the way forward. We can, all this is available in an app, so you can do this on your phone while going and coming, and that's how you learn. And this, then our next offering is a framework, which is a cross-platform framework. This cross-platform framework can be, it's called cross-platform, it's available on the desktop, on the mobile, and offline and online. So that's most important. So if, let us say I am a school or I am a Vedic Patashala, I want some of the courses that are offered by Vyoma, I want to install it in my desktop system so that my students can learn from it. I can choose which are the courses I want. I can make a customizable set out of it, and you can request us. We can immediately put that in a framework and give it to you, and you can install it offline or you can access it online. Both options are available. So this is very useful for institutions who want to help their students learn Sanskritam in particular ways with our products, with all our offerings or our courses. So we would give a framework like this, and whatever courses are necessary, it would be put in a particular framework like this with a lot of filters and this thing. And those can be used. So for example, you go into one of those like Raghuvira Gadyam, and then you can listen to the audio. So each course has audio, video, it has some exercises, some of them might have exercises, all of them have text material that is available. So this can be used for learning, self-learning, or for teaching. Both these are available. Similarly, we come up with products based on occasions. Since the Rama Janmabhoomi was recently opened, we have 2 new products like the Rama Chanting Companion and the Discourse Companion, which we have all our products related to Ramayana, which have been put into 2 different frameworks. And this can be listened to, all the kandas of Ramayana and Champu Ramayana, and both in English, Samskrita, and various other things. Our other offerings are the flip books. We have various flip books that are available. Physical books are always available, but if you are on Kindle or if you are on mobile and you want to go through our books, we have the flip books that are available. For example, the Bhagavad Gita, which is one of our offerings. You can see it almost turns like a book with the page turning sound also that is there available for us. We'll just go to some page in between, like page number 120 or something. Then this book is especially for Parayanam. It is very nice for Parayanam. Book is openable like this, the physical book. Here also you can see it is used a lot for Parayanam. So this is our flip book offering. So this is our main, the official website, vyoma.org. And as I said, we have 355 plus free courses. And most of our courses are free of cost. Very few courses, less than 10% is paid. We have 14 books and 9 flip books that we have published. We have 380 plus courses and 48 plus multimedia products and 6 mobile apps which you can right away download from the Play Store or iOS App Store. And all our products, the books or some things are available on the digitalsanskritguru.com, digitalsanskritguru.com. You can, so these are 2 websites that are there. And yeah, so basically the most salient features are these customized learning packages can be created. You can create your own learning paths, and it is there. It is not just for young children. It is there for all ages and whatever level of Samskrita you are in, whichever Shastra you want to go to. We have courses in all various Shastras, and that is so. And I would suggest all of you to download our Android app. It is also there on iOS. iOS app has the latest courses. Few more courses have to be added. Android has all our courses that are available. It's a free app to download and free to access content that is there. So you can right away download this, and welcome for questions.
Any questions?
Shankararama, what are the topics you are planning to cover? I mean, some topics uncovered, maybe, I don't know, the chanting classes, what the plans are, I mean.
So our plan is to have a lot of, cover the whole of gamut of Sanskritam from the basics. And we already have covered a lot of things in various Shastras. If I go back to the website and show you.
Like I saw the total number, but what the Shastras actually are covered,
Yes,
I mean.
so I will show you that here. If we come to, let's say, the courses. So if you see on the right side, we have Ayurveda, the basic courses on Ayurveda. A lot of people are for chanting courses. Then Vyakarana is one of our strong suits. We have a lot of courses in Vyakarana. If I select the
So
grammar.
Vyakarana and chanting are the 2 most popular ones?
Those are popular, but now Tarka is also popular. We have a wonderful Tarka Vidwan who has started Tarka from the basics. So he is going to handhold people through Tarka Shastra. From Tarka Sangraha he has begun. He is now teaching the style of Navya Nyaya, and he is going to take you till the highest of. And we have such plans for Vedanta and all other Shastras also. Similarly, we have it in Kavya and other Alankara Shastra. So all those are available based on, and even for IKS, for example, like management sciences, and you have Yoga Shastra, all such courses, for example, leadership lessons from Bhagavad Gita or management principles from Indic texts.
So you want to say they are covered in, I mean, equally well?
Everything is not equally well.
So that's the question. So what's the plan? I mean, what
the plan is to cover everything equally well. Yes. And it is a very long-term plan. It is not immediate. It's not like next year. I'm not going to promise you that by next year I'm going to cover. It's like 10 years. And we always have at least 5 or 6 courses that are going online live. So that is this.
One another point to add here is we welcome the subject matter experts in any of these fields. So because Vyoma is a platform which is connecting every teacher to every student in each and every part of this world. So whoever is interested can definitely join this yajna of sharing Sanskritam to everyone. So.
Very useful presentation. Actually, Shankara Rama is a techno-linguist scholar in Vyoma, right? And he did his engineer in computer science and a master's in Vedanta. Thank you. So last presentation in this Satra is on Future of Cologne Digital Lexicons by Marcis Gasun. Marcis is working on Sanskrit digital lexicography, and he is leading a Russian group of Sanskrit scholars. Now he is presenting. He's presenting now.
The pointer to change the slides. Just by clicking. Okay. Okay. Is it better? More down? Is it good? This one? Yep. Not yet, I just want to test it. Okay, it's not working. Okay. Okay. Hari Om, so I first of all wanted to say thanks for having me here. I believe that the papers is not the most important part, the people are. So I believe that we are a community of people who love Sanskritam and who know how to use the computers. There was a day when I understood in 2004 in Moscow we had a World Oriental Conference, and I understood that time of printed books has passed. I myself am a printed book printer, but I understood that digital humanities is what I'm interested in. So from 2005, I lead a group of Sanskrit Zealot Society in Russia, which means everybody who learns Sanskrit in Russia is a student of mine. So there are around 350 students right now, and we do a lot of lexicographical research. And there is one place which is the leading source for every Sanskrit dictionary on the internet. It's the Cologne dictionary. So in 2007, I wrote my first submission of errors to this website, and I understood that the problem is that it's very closed. Nobody knows what's happening inside those dictionaries, what kind of work is being made. And it took 7 more years to make this project open enough so people can actually contribute to the correction of the dictionaries. And when I say correction, I mean not the original print errors, which are little of amount, but the errors we've added by digitizing them. So, so the story is like 30 years long, and the last 10 years we've been open on GitHub, which means people can contribute in batch mode or error one by one. So my main goal would be that like in 10 years from now, we would have at least a clean list of dictionaries as they were in the mid-19th century. So Sanskrit lexicography is still in mid-19th century, and I would want it to change one day. And there is one person who is behind everything that's happening with the Sanskrit dictionaries. His name is Jim van der Burg. He is a mathematician. He is not a linguist. He's not a Sanskrit scholar, but everything we see for the last 20 years is because of him. So he was there initially with Peter Scharf and Thomas Malton. As he is not as young as I am now, so the plan is that Dhaval Patel will replace him by the time when he says it's enough of Sanskrit digital lexicography. And there are contributors from India, and actually I'm here so that there are more of Indian contributors after I came here. So Dhaval you already know about, but there is one other contributor that is contributing more than 100 different other contributors. His name is Nagabhushana Kalepo. So there are 42 dictionaries at Köln, which means that we cannot concentrate equally on all of them. Because of that, we have chosen priority dictionaries, like Monnier-Williams has the best markup, but we would want the Bertling dictionaries to have as good markup as the Monnier-Williams ones has. Because, for example, we don't know how many sopasargadhatus are there in the Bertling dictionaries. Still, I mean, they had been digitized like 20 years ago. We don't know how many samasas they are. They are yet to be compiled, the list. So based on these 42 digital lexicons, the total amount of Sanskrit lexica known to us is 393,000 words. As of now, the digital scans are not identical to the books. So the first goal is to make them identical, and then we can move forward. This is a small sample of the interface. I actually would want you to show that lately we've added the simple search function. That means that even if I don't know how the word is spelled exactly, we still have a chance of finding something that looks similar. But in this case, I just wanted to show that that's not always easy for the computer to know how we should construct a samasa. So every author of a dictionary, compiler of a dictionary, has his own attitude, so we don't know if it should be ati vatsala tva or it should be ati tva. Okay, so that's a computational task, not as easy as it looks. So MacDonald's dictionary is like a 30,000 word dictionary. Still, it has like some 8,000 more subhead words to be added, and it requires a lot of human power, which we lack, actually. So this year, I hope we start adding Sanskrit-Russian dictionaries. 5 of them I have already prepared, but they had to be added to the main site. And what I really like is that in 2004, I wrote an email to Thomas Malton, and he sent me a CD of all those PDF scans of the dictionaries. In 2004, he had to send me the CD because the internet was really slow, and we could not send big files over. And these days, there were no digital dictionaries. Even the scans were not available openly. So in 20 years, it has changed. And now, for example, there are some dictionaries that still will not be open and never be added to the Köln website, but there is the Keva dictionary, which I use for the etymological purposes and recommend to you as well. So the Kupa Manduka Nyaya says that if you are a frog and sit in a well, then you propose that that's the whole world, which is not actually the case. And I really like that we've made it possible, like 10 years ago, to show everything that's happening at Köln, which is not the case, for example, in Leiden, where all the dictionaries are closed. I mean, they've had that Meyerhofer Skeva like 18 years ago, and it's only for subscription-based for the libraries, which is not so great. So they've added like Gilner's and Griffith's translation of the Rig Veda lately. We had it done like 10 years ago. So the final idea would be is to unite grammar, dictionaries, and corpora. Grammar, dictionaries, and corpora. So we are cleaning the dictionaries. We are making cross-references from the dictionaries to the corpora. So lately it's been Rigveda, Ramayana, Mahabharata, Atharva Veda being added. For example, if you click on any of the references from the Grassman's Rigveda Wörterbuch, you'll land like here. So that would be one of the major goals, to make more targets for the cross-reference. And what I really believe is that we should unite the possibilities of artificial intelligence and the volunteers. Volunteers alone or artificial intelligence alone doesn't make much. So there is a movie which actually shows the way I believe we should move forward, because only a madman can compile a dictionary. And we should be like a madman to try to replicate what they've done 150 years ago with the Oxford Dictionary. We've also developed a Sanskrit search engine, which is pretty simple, with a search string function, but based on our parallel corpora, which is rather big and contains the Sanskrit texts and the Russian translations. It can show, like, it already has like almost 100 sources. So you can see that we have like 3,000 results for Jala, and we don't have to translate using Monia Williams dictionary, which itself is a translation from Bertling's Sanskrit German dictionary. We can directly take the Russian sources, the academical translations, so we don't have to reinvent the wheel. So our main concern actually is data correction. We don't care much about the code or the user interface, because we are a recycling plant, and that's what we are best at. One of the sad points is that when a website takes the data from Cologne and like 10 years pass, the errors remain the same on those websites, and that I believe is an issue, and I don't have a clue on how to fix it. So there are different ways of correction of errors, but I would want to show the websites that do use the Cologne data. So we see that although Cologne has a lot of corrections on an every week basis, the websites based on it, like 10 years ago, we had like hundreds of thousands of different mistakes, and they will always remain on those websites that have taken at that time the source files. So I hope we do find a way of updating the other websites at some point as well. So as you saw today, for example, the Ambuda project uses the source files as well, and they are included in this list. So not only the dictionary files are used, but you can see that, for example, Oliver's website, as you all know, it is like perfect in every possible way. But if you look at the meaning section, you'll find it kind of funny that it arranges the meanings alphabetically, which not might be the best case, because, for example, Jala, you have a cow's embryo instead of water as the first meaning. That might be not as great for a student who sees it for the first time. So in this regards, it's not a very, I believe, a good solution. Otherwise, of course, if you want to work with corpora, you have to have a list of words. So the list of words is based on Monet-Williams. So it's like out of the 200,000 words, the corpora needs like 90,000 words to cover all the corpora actually needs. There is the Rigveda data, and here is the Ambuda one. So we are working on the Russian translation of the Ramayana, and this is already of utmost interest for us, even at this stage. And there is this Nakstragas Wörterbuch des Sanskrit. So this is one of my I would say sad stories. So they take the data, and they never show where they take it from, and there is no way to fixing these errors. So it's an addition to the Petersburg Bertlin's dictionaries. Yeah, so a lot of projects come out of Köln but never come back. And what we really would need is the coding part. So it took just 10 years to clean out the headwords, which means that there are a lot of thousands and tens of thousands of mistakes inside the articles. And I believe that you've seen plenty of them yourself. And right now we are concentrating on the markup. Means if there is a quotation from the Rig Veda, you have to find it and write a regular expression so we can actually link the dictionary to the corpora, and that's not always easy. We don't have a list of abbreviations. Most dictionaries have only a partly list of abbreviations. We don't even know how many there actually are. That's as regards of the coding, the major features we are lacking now. That's what we could base our attention on. And here you can see actually what simple search means. I entered Guru, and you see all the possible ways of what I could meant. I have meant the Guru one actually. So and you see you can even enter it in Cyrillic. So if your mother tongue is Russian, which most of you, of course, is, then you can use the Cyrillic script. And there are some things you don't actually see a lot. For example, the indische Sprüche have been linked last year, but I believe only Dhaval knows that it's been done. So, I mean, the Subhashita collection, 7,500 Subhashitas, it's already linked from inside the dictionaries, and still not many people know it's there. So the Keva I spoke about, so this is like a partly digitized dictionary, which means like we have the headword list and the scans of the images. So, yep, that's the last one. So abbreviations, we don't have a list of abbreviations for each dictionary. We don't know what literary sources they use. We can spend the next 40 years adding cross-references. Yeah, we'll add a few Sanskrit-Russian dictionaries. And I believe that that's it. I want to say that however smart we are, each of us alone, we cannot change the world one by one. So I hope we unite. Thanks.
Thank you.
Shankar Rama has a question.
I actually do not have any questions because it was wonderful work. As you said, Samana Hridayani Vaha, we all have to work towards that. And the way you began, Sanskrit zealots, that's really, it touches our heart. We all have to work towards Sanskritam, and there's some great work that is being done. And we would like to help in whatever way we can and collaborate. Thank you.
Thank you.
Thank you very much. Idam satram atra sampurnam. Shubham bhuyat. धन्यवादः. So now tea time. We will come back by 4:35.
Raghuvanshasudambudichandrashri Rama Rama Rajeshwara Raghuvanshasudambudichandrashri.
அலைப்பாயுதே கண்ணா என் மனம் அலைப்பாயுதே அலைப்பாயுதே கண்ணா என் மனம் அலைப்பாயுதே ஆனந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா என் மனம் அலைப்பாயுதே ஆனந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா என் மனம் அலைப்பாயுதே உன்னானந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா என் மனமிக அலைப்பாயுதே உன்னானந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா என் மனமிக அலைப்பாயுதே உன்னானந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா நிலை பெயராது நிலை பெயராது சிலை போலவே நின்ற 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 நேரமாவதறியாமலே மிக வினோதமான முரளிதரா நேரமாவதறியாமலே மிக வினோதமான முரளிதரா நேரமாவதறியாமலே மிக வினோதமான முரளிதரா என் மனம் அலைப்பாயுதே கண்ணா என் மனமிக அலைப்பாயுதே உன்னானந்த மோகன வேணுகானமதில் அலைப்பாயுதே கண்ணா கண்ணா தெளிந்த நிலவு பட்ட பகல் போல் எரியுதே தெளிந்த நிலவு பட்ட பகல் போல் எரியுதே உந்திக்கை நோக்கி என்னிரு உருவம் நெறியுதே தெளிந்த நிலவு பட்ட பகல் போல் எரியுதே உந்திக்கை நோக்கி என்னிரு உருவம் நெறியுதே கணிந்த உன் வேணுகானம் காற்றில் வருகிறே கணிந்த உன் வேணுகானம் காற்றில் வருகிறே கணிந்த உன் வேணுகானம் காற்றில் வருகிறே கண்கள் சொருகி ஒரு விதமாய் வருகிறே கண்கள் சொருகி ஒரு விதமாய் வருகிறே கதித்த மனத்தில் ஒருத்தி பதத்தை எனக்கு அளித்து மகிழ்த்தவா கதித்த மனத்தில் ஒருத்தி பதத்தை எனக்கு அளித்து மகிழ்த்தவா ஒரு தனித்த வனத்தில் அணைத்து எனக்கு உணர்ச்சி கொடுத்து முகிழ்த்தவா தனித்த வனத்தில் அணைத்து எனக்கு உணர்ச்சி கொடுத்து முகிழ்த்தவா கணை கடல் அலையினில் கதிரவன் ஒளியென இணையிரு கடலென கழித்தவா கணை கடல் அலையினில் கதிரவன் ஒளியென இணையிரு கடலென கழித்தவா கதறி மனமுருகி நான் அழைக்கவோ இடர மாதருடன் நீ கழிக்கவோ கதறி மனமுருகி நான் அழைக்கவோ இதர மாதருடன் நீ கழிக்கவோ இது
सामजवर गमना सामजवर गमना सामजवर गमना सामजवर गमना साधुकृत सारसाप्रपाल कालातीत विख्यात सामजवर गमना साधुकृत सारसाप्रपाल कालातीत विख्यात सामजवर गमना साधुकृत सारसाप्रपाल कालातीत विख्यात सामजवर गमना सामनि गमज सुधामय सामनि गमज सुधामय सामनि गमज सुधामय गान विचक्षण गुणशील दयाल बलवा बलय सामनि गमज सुधामय गान विचक्षण गुणशील दयाल बलवा बलय सामजवर गमना साधुकृत सारसाप्रपाल कालातीत वेदशिरो 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 मात्र च सप्तस्वर नाद चलदीप स्वीकृत वेदशिरो मात्र च सप्तस्वर नाद चलदीप स्वीकृत यादव कुलमुरळी यादव कुलमुरळी यादव कुलमुरळी वादन विनोद मोहन कर त्यागराज वंदनीय यादव कुलमुरळी वादन विनोद मोहन कर त्यागराज वंदनीय सावरवर गमना साधुक सारसा प्रबल कालातीत विख्यात सावरवर गम गम ग गम स मग ग स नि सा मनी गम च सुधामय म गम ग स ग म नि स ग म द म गम ग स नि ग मग ग स नि ध नि सा मनी गम च सुधामय स म ग स नि स स स स नि नि स स स स ध ध स स स म स नि स स ग स नि स ग स ग म द ग म द म स स ग म द नि द म ग स स नि द म ग स ग नि स ग म द नि स ग म ग स नि द म द नि म ग स नि द ग स नि द म नि द म ग म स म नि ग म ज सु ध म य सा स स स स स नि नि द नि नि स स स द द द सा स स म स स शील दयाल बालमा पालय
राघव मरुगेलर మారుగేల చరాచర రూప మారుగేల చరాచర రూప మారుగేల చరాచర రూప మరుగేల చరాచర రూప మరుగేల చర చర రూప మరుగేల చర చర రూప పర పర సూర్య సుధాకర లోచన మరుగేల మురగవ మరుగేల అన్ని నీవనుచు అంతరంగమున అన్ని నీవనుచు అంతరంగమున అన్ని నీవనుచు అంతరంగమున అన్ని నీవనుచు అంతరంగమున తిన్నగా వెదగి తెలుసుకొంటినయ్య అన్ని నీవనుచు అంతరంగమున తిన్నగా వెదగి తెలుసుకొంటినయ్య నినెగాని మది నెనజాల నొరుల నినెగాని మది నెనజాల నొరుల నినెగాని మది
Hello. Request all participants to kindly settle down fast, please. So good. Request all participants to settle down fast, please. So any of the participant has Mac to HDMI adapter? Oh, okay. No, I think there's none. Hi, Peter. Are we audible? Peter, you need to unmute yourself.
Hello?
Hello. Are we audible, Peter? Okay. So, so for the presentation in research section 6, the Shabda Brahman exercise platform.
If you can't hear us, check your audio. It's
Peter,
Hello?
can you hear us
Yeah,
now?
try, say something.
Peter, can you hear us now?
No, I can't hear you.
Okay.
Hello? Can you hear me?
Yes, we can hear you. Okay. Anyways, the Shabda Brahman exercise platform, Peter Sharp and Harsha Pamitipalli would be presenting a paper. The duration would be 20 minutes and 10 minutes for the question answer. So over to you, Peter.
Okay, so I guess I should begin. And I'll share my screen. So we're presenting, oops, just a minute. This is out of control here. We're presenting the Shabda Brahman exercise platform. So I developed this with the help of Harsha Pamidipalli, who was with us a few minutes ago, but with the changed schedule, I think he departed. We'll get a little drink of water here. So we have the experience today that instruction in Sanskrit is declining. All over the United States, positions are becoming rarer. The people are retiring. The positions are not being replaced. And the quality of instruction in Sanskrit is being watered down in India. The groups that are involved in propagating Sanskrit are focused more on conversational Sanskrit. But these instructional materials fail to introduce students to the depth and complexity of the Sanskrit language and literature. So the students are remaining ignorant of the abundance and scope of the literature, the variety and complexity of the language, the enormous work that needs to be done to preserve Sanskrit knowledge, and the urgency to bring Sanskrit knowledge into the digital medium before primary resources perish. There are some 30 million manuscripts, as estimated by Professor David Pingree. More than 12,000 have been surveyed by the National Mission for Manuscripts in India. And most of these manuscripts have never been used to make any critical editions of texts. But the students who are learning conversational Sanskrit are not prepared to do this sort of work. So, and the younger students are unaware of the enormous scope and urgency of the need to do this sort of work. So students are remaining unmotivated to learn Sanskrit knowledge or to work to preserve and enhance it. Based on my first-year Sanskrit textbook, Shabda Brahman, A Linguistic Introduction to Sanskrit, we created this interactive learning platform. It's accessible at shabdabrahman.org. I'll demonstrate it actively in a minute. It's an interactive platform, and it leads students through every step of understanding and translating, provides detailed feedback and focused help at every step. It's currently available to students enrolled in first-year Sanskrit courses at the Sanskrit Library. And we've also developed a platform, a similar platform for the Sankshipta Mahabharata. It's a one-chapter telling of the whole story of the Mahabharata that occurs in the Adi Parvan of the Mahabharata. And this is in a framework that will allow other texts to be added. We plan to add Raghuvamsha as well. So what is the motivation for developing this platform? I've taught Sanskrit for 20 years at Brown University, and my experience there was that students would be given a homework set of 30 or more sentences, in which they had to transcribe from Devanagari to Roman script with proper diacritics. They had to analyze the interword prosodic changes, that is the sandhi. They had to identify the inflection of each word, that is the declension of nominal forms and the conjugation of finite verbs, and analyze the syntactic structure of each sentence, and then translate. What happened is that the students would repeat errors that they make in every sentence over and over again, and then they would come to class, turn in that homework set, and we would go over some of them, but perhaps not all of them. I would take those home and go over them in detail and hand them back in the next class. In the meantime, I've already assigned another set of exercises where they repeat the same mistakes again. And so there's a week or more correction lag time. And by that time, the students get their homework back. They've forgotten the context, and they may not attend carefully to the correction. So there's a lingering doubt and repeated errors that they're making in their homework, and this leads to frustration on the part of the students. The learning is inefficient and deficient. In addition, I have to go over, the instructor has to go over the same errors again and again, spending time correcting them in detail. And it's tedious to correct transcription, transliteration, sandhi, inflectional identification, and syntactic errors. So this is exasperating to have to correct the same answers repeatedly, week after week. The tedium and exasperation lead to neglect of details. Many times I found, as I was working as a teaching assistant for other professors, when I was a new Sanskrit scholar, and once when a distinguished professor at Brown offered a Sanskrit class, I could see that they didn't attend to the professors didn't attend to the errors. And so the teaching is inefficient and ineffective. What's required for ideal learning is immediate focused feedback at each step of working through each sentence in an exercise set. Immediate confirmation of correct work, immediate focused pinpointing of mistakes, immediate direction to relevant information to help, and that the help should not provide the answers, but should provide education to the student as to how to correct their own mistakes. Current language learning software is now geared towards business and travel themes. It's oriented towards communicative use of modern languages. Development of this software involves assembling numerous experts and is an expensive undertaking. The development of comprehensive language learning software for classical culture-bearing languages like Sanskrit is extremely thin. So the Shabda Brahman platform is unprecedented. What we do in this platform is at each stage of working through a sentence, we deal with in a separate pane and a separate tab, and it provides immediately focused help at every stage of working through the sentence, evaluates the student's submitted work, enables the student to correct his own mistakes, does not give away the correct answers, pinpoints the errors, provides links to assistance, and submits the completed work to the instructor. Now, I have slides which go through this, but I think rather than do this in this fashion, let me just go to the site itself. Now I have to stop and reshare my screen in order for you to see that. I hope you're all seeing now the Sanskrit Library Shabda Brahman exercise platform. So the first thing one does is, after logging into the site, is go to the chapters. And let me demonstrate something towards the end here in the perfect chapter. We have many drills, but I'll show an exercise and walk through a sentence I've completed so we don't have to go over it again. So here's the transliteration step. Tavad ratri kramate yavat suryo na kramate. And that's the situation that's here now. It's still nighttime here in the US. Let me, now, if we make an error in this transcription, so now I've left out this visarga here, okay? And as I check it, it will highlight these errors. It takes the student's input, it compares it to the correct transcription, and highlights the differences. Where something is missing, it highlights it in yellow, tells the student to add something. Where something needs to be replaced by a different character, it informs them of that in a message. And where we want them to delete something, it tells them that as well. And each of these steps then links to some help. Okay, so we click here. I don't know if you can see the new screen that opens up. I hope so. Can someone tell me, Martin, can you tell me whether you can actually see the Devanagari script
yes, we can.
which opens in a new tab? Yes, okay, good. Good. So, and here they can click on any of these in order to get a large image and video of how to draw the character. That may come in a separate window. I'm not sure that will be visible or not to you. Now, that's a transcription error. And now if we correct that error we type in SLP here, we correct the errors like this, and then check it again. It will tell the student your transliteration is correct, and immediately go to the Sandhi analysis where I've analyzed it. But let me put an incorrect error in there. So now I've got several errors, and if I check this, it highlights the errors and gives a message telling the student that there's wrong analysis here. And if we click on the link, then it opens up a window, which I hope you can see, with Sandhi tables. Okay, so can I zoom a bit? Yeah, you don't need to see the details here, but here's the Sandhi table, and there are different panes where they get the different type of Sandhi. Okay, and now if the student corrects those errors, so they can correct these errors. And supposing they make so they've failed to separate these words here, okay, and they've got a mistake here as well. Okay, so now we check again, and it highlights these mistakes. Now in this case, performing Sandhi to the student's analysis will lead to the correct result. Okay, if they do sandhi to na akramate, it will lead to na kramate, which is the original input. And here, yavat surya without separating still leads to the correct original sentence. So in this case, we do a different kind of test. The first test was we actually did their sandhi and then compared it to the original sentence. And that showed one class of errors in the sandhi. In this case, doing sandhi to their input will yield the original question, but it's still not a correct analysis. So we won't find it by comparing the result of doing sandhi to their analysis to the original sentence. So at this point, after they produce the original sentence, we compare their sandhi input, their sandhi analysis, to the correct sandhi analysis to show the second class of errors. And we highlight these in blue rather than in red. Okay? And again, these will lead to some help about what to do in this case. Okay, now if we correct these errors, then check it again, they'll get a confirmation of their correct sandhi. In this case, we let them observe what the correct sandhi is before we go to the next step. And then we take their words, the correct words they've analyzed here, and we put each one in an individual box for them to analyze. I'm going to zoom out again here. So now each one is put in a box. I've identified most of them. But if they make a mistake here, okay, or if they fail to put in an inflection, it will tell them what's missing and highlight the box in red. And if they put in the wrong lemma, they can search for it here, okay? And as soon as they type, it's a flex search. They can choose the correct lemma from the list. And once they do so, they're just about given the correct lexical category. In some cases, for example, if they put in tud here, then it'll put a question mark where there's more than one, and they can see the list of possible identifiers come up. But we'll put the correct answer in here, and then check it. And we have to do this now. Here, if they don't know how to identify with the codes when they're first learning, they can press the question mark and or /, which is lowercase question mark, to get a panel in which they can enter the correct identifier. So then they submit that and then check it again. And also with a verbal identifier, they can do the same thing. So present, middle, third person singular here. And we check it, and everything's correct. And now we can go to the syntax pane. Now in the syntax pane, again, I've filled everything in. What happens here is that they'll get a list of possible choices that are available for the identification they've given it. So they've given it the identification of a nominative. So there are only so many possible syntactic roles that are available for a nominative. It can be an agent, a causal agent. In a passive sentence, it can be a direct object. It could be the goal of motion, or it could be the qualifier of the nominative that is playing one of those roles. So if they choose the wrong one and check it, they'll get an indication that it's incorrect. And if they choose the wrong parent, they would likewise get an indication that it's incorrect. And the parent lists, the menu here lists all the words in the sentence in the order that they occur. So they just have to choose from the list the correct target of the parent. So now let's put in the correct answer, check it. And once they've given the correct syntax, they can see a syntax tree, which shows the relationships. And I've classed the syntactic relations in two types. One are the principal relationships, of the karaka relationships, identifying the main verb of the sentence. And those relations are shown in gold with blue arrows leading from the child to the parent. And other relations, like the relation of a relative clause to a main clause, are not actually syntactic relations. The syntax is all within the clause. So here the relationship between the yavat and the tavat is one of identity. It's an abheda. And this relationship is not a syntactic relationship, actually. It's not a karaka relation. It's not the relation of a participant in the action to the action, or a qualifier, or that type of thing. And I know Professor Kulkarni has analyzed these things differently using some other Nyaya categories like Pratiyogi, Anuyogi, which are not actually considered by the grammarians. But the relationship here I've chosen is one of identity.
Teacher, we may need
so
to
now they're prepared to do the translation, and if they need help in deciding the syntactic relation, they can go here to a table I've created of all of the possible roles with examples as described in Paninian grammar, with examples drawn from the Kashika Vritti. And this is also in an appendix to the Shabda Brahman textbook. And they can also look up words if they've forgotten the meaning. They can look it up again in the glossary. Okay. Okay, now, okay, that's the syntax. And now they can go to the translation, where all of the information they have previously entered is summarized for them for each word. So I filled in the correct translation here, but supposing they put in just what words have been put in here as word-for-word translations. Okay, I've given them the translations which are in the glossary under the words that they've identified, and these are all the identifications which they have given in previous panes, and the syntactic relations which they've indicated there in the previous pane. So all their information is presented to them here. Now, if they take just the word-for-word translations and put them in here, okay, night continues as long as the sun does not rise. No, that's not. Night continues as long as the sun not rise. Yeah, here. As long as sun not rise. Okay, let's check that. And then they get a message. No, what's going on here? I wanted to put this one. This is the one I wanted to put in here. Just the minimal, okay, in the order that they're given. Okay, so long, night, continue, as long, sun not rise. If they check that, then then they will get a message saying incomplete, okay? And if they adapt their translation to be more correct by putting in, okay, some of the more correct answers, night continues as long as the sun not rise, still they've left out something here. It's not quite correct syntax. And then we check it and we say, get a different message saying your translation does not entirely match mine. And it asks them a number of questions, gives them help. They can choose from auxiliary words to put in, to add to their translation, to complete it. And once they put in the correct translation, then it tells them, okay, you translated correctly, sadhu, and they're allowed to go to the next sentence. Okay? And they go to the next sentence there. Okay, now let me stop sharing that. And just close with a few words about the okay, so we've gone through the exercise. Now,
Peter, can you hear us?
So we also show them percentages of their work completed, and at the chapter level, also within the chapter, the source files are all prepared in XML according to the Text Encoding Initiative guidelines, and just mention that the user interface is built using JavaScript and React.js. Yeah. The back end is built using a Python programming language. It's Flask framework. A REST API is created to enable interaction between the client and the server. Data pertaining to the questions is all in an SQLite database, and the host is cited by Amazon. The project is maintained on GitHub. All the data is kept secure in transition, and there's a authentication login. Okay, so I'll stop there, and if you have questions, please ask them.
So in the interest of time, I think we won't be able to take many questions.
I see somebody's talking, but I can't hear what they're saying.
Thank you. Any questions? So, thank you, Peter.
Yes, Martin. Yes. At this point, you need to join one of the courses. The system is not meant to be used without a teacher, and you know, one has to be taught Sanskrit before one just goes to the exercise. It's learning Sanskrit involves more than simply. I think you're getting an echo now.
So, thank you.
Okay, thank you.
The next demos in the line are Sanskrit manuscripts made available by Gandhar Kulkarni, Vijay Chandari, Rahul Jain, Anil Kumar, Sanjay Singhal, followed by making descriptive catalog of Sanskrit manuscript by Sanjay Singhal, Rahul Jain, Vijay Chandari, Rajshri Godavat, and we'll keep the question answer of both the sessions together. They're related to each other. Thank you.
on. Okay. I think now I am audible. Okay. Namaste. I am presenting Dharohar team, and this is a website which I am going to present you. Afterwards, how is this website created will be explained. Sangraha.org is our website, which is created by Dharohar. And these are three search engines, Sangraha, Sandarbha, and Samagra. Sangraha is a descriptive catalog of the manuscripts produced from the website, and we are a platform to connect Sanskrit scholars with the libraries, who have manuscripts. We are providing them a platform to get connected with the Sanskrit scholars. Let's see how is this Sangraha working. I have logged in. I have already logged in to save time. The login information is very important, just because, just to know that the scripts and your shopping bag, that is the manuscripts which all are the user is accessing, is saved with the login information, and each and every time you log in, you will get the same script output and script input, which we have 5 different script output and inputs. Let us see if I am able to search. Okay. So it is taking time. This is normal title search, wherein Mahabharata is searched. We have 84 manuscripts which is having Mahabharata name in it. So it is also main Mahabharata along with some commentaries which we can see here. Again, I'm going to specific manuscript. There were 20 manuscripts of Mahabharatam, Bharata Bhavadipascha. So out of which, again, I am, this is means now what we are seeing is the manuscript information, which is of each and every manuscript of those 20 manuscripts, descriptive catalog, but in short. So this is a list of short information about the manuscripts, 20 manuscripts of Mahabharatam, Bharata Bhavadipascha, wherein we can see short descriptive information. And again, let's see if this is opening. So Mahabharatam, Bharata Bhavadipascha, this was the catalog which we saw. Herein we will see the title name of the manuscript. This is the information which is popping up of the title, the subject, and again the pop-up of regarding the subject information, the author information which is again in the pop-up, and commentator information again in the pop-up. And this is the complete descriptive catalog of a manuscript, wherein we have begin text, end text, and colophons. Now let us see what is this subject about. Okay, so we have prepared a hierarchy of subject tree, wherein this is the hierarchy of the subject tree. So to standardize all the types of manuscripts and types of subjects, this subject hierarchy is prepared. And if we select it accordingly, the search goes ahead. As we are particularly seeing right now Mahabharata and Bharata Bhavadipa, I'm not changing my search. I'm going through this search itself. Okay, this manuscript, the first page is starting here, but this is not a complete manuscript. This is an incomplete manuscript. So the first page, as a cataloger, when manuscript comes to us, the problem is to identify that which manuscript is this, what is written here, and what is the subject, what is the topic, what is the title of the manuscript. Because many a times it is possible that the title which is given by the library might be different than what the manuscript actually is. So to come over such problems, Sandarbha was created by us. Sandarbha is again second search engine which was created for text search, random text search. Now, as we have transcribed the begin text and the end text in our catalog, this is done manually by reading the manuscript. We can take one pada from this manuscript, from the begin text, and search it like this. I have just taken the Sandadhana word here, from here, Sandadhana word from here, and I have searched it from Sandarbha. Sandarbha is a search engine wherein text is searched. It is taken from open digital corpus. As I didn't know regarding what this manuscript was while cataloging, I just searched Sandadhana and it gave me the result of, initially this was not there. Let's see if I can search it directly. It is taking time, therefore. Okay, this is a good thing. So in left side, we can see that there are 4 to 5 texts in which Sandadhana word is there. From which, if I go for Mahabharata, there are 22 results, 17 results in Mahabharata where Sandadhana word occurs. And when, as we can see this manuscript, Tasya Vikshipataschapam Sandadhanasya Chasakrut. In our critical edition of Mahabharata, Nasya is given. As I searched Sandadhana, I could get, this is from third part of third Arakand of Mahabharata, Aranyaka Kanda. And it is going us to Sandadhana se Chasakrut. Here we can get the previous and next part of the text which we have searched. And again, if I go to manuscript and see, it is the same. Therefore, it is confirmed that this is from, this manuscript is from Mahabharata. By using the Sandarbha, we were able to get any text which we have got from manuscript, and the reference points from where the text was. The third search engine is Samagra search engine. That is, again, we have 2 different types of searches of Samagra. Samagra is the search engine of NCC. The 19 volumes of NCC are searchable in Samagra. fuzzy search and exact search. I am taking an example of Nyaya Ratnamala. It is giving us the result of Nyaya Ratnamala from NCC, the 19 volumes of NCC. These are the head words which we can search. The head words of title and author are here, which are present in NCC, we can search here. So it is giving me 8 results, but if I go for exact search, it is optimizing the options of search to 4. And now I know that I wanted to search Nyaya Ratnamala, which is regarding Vedanta. Therefore, if I go ahead in the search, this is Nyaya Ratnavali, which is the commentary on Siddhanta Bindu. On double clicking Siddhanta Bindu, I get the result of Siddhanta Bindu. Siddhanta Bindu is the commentary on Dashashloki. Also, we will get this information in my NCC itself. As Dashashloki is a head word of in NCC, on double clicking on Dashashloki, we got the information about the Dashashloki also. So in this way, in 3 different parts on Samagra, we are able to see 3 different informations. Again, to check down, this is generated from created from OCR of NCC. This thing. So if something is missed out or not, we can just open the PDF file, the page file of NCC and check it out. Here also we can scroll the previous page and the next page. So we searched for 260th page, and when we clicked on previous page, we were able to scroll on 259th page also. And as I clicked on next page, I was able to go on 261st page also. So Samagra is giving us, Samagra is a search engine on which we are able to search down NCC. In Sandarbha, we found that text search about, I will like to show the subjects which we are covering right now, and we want to expand the books for these searches also. We will be expanding it shortly. But these books are completely text searchable throughout this thing. And then we have our Sangraha website. Sir will explain how this is created.
So we welcome Mr. Sanjay Singhal for his presentation.
Namaskar. As soon as I come on stage, my slides disappear. That's normal. So Gandhar explained the website. What I'm going to talk you through is how the descriptive catalog entries on the website are made. www.sangraha.org is the URL. The basic process that we follow in our overall work plan is we work with libraries. When libraries subscribe and participate with us, we acquire images, either by in-library imaging, or if they've already got digital images, we can work with those. One thing we found is never are these images in the right page order. So before we go to cataloging them, they need to be arranged in the right page order. Once they're in the right page order, they then go into the cataloging process, which is making of the descriptive catalog entries. And once a catalog entry is made, it goes through a peer review process. 2 of Gandhar's peers would review his work. If there are errors found, they just go round and round till all the errors are gone. And once the errors are gone, then automatically it gets published on sangrah.org. And this is where users interact with it. The key thing, our goal is to make 2.5 million manuscripts available on this over the next 20 years. So we had to design this for scale. Given that some manuscripts are not in Devanagari and they're in other scripts, we've also got a program by which we digitally transcribe and transliterate from other scripts into Devanagari so that it becomes available and accessible to scholars. Very early on, we established what would be our core principles of work. And the most important thing we found was we had to be completely faithful to the manuscript. If there are errors in the manuscript, even obvious errors, we just transcribe them as they are. And any information we provide must be accurate and never misleading to the user. Now, on a project of this scale, when you're thinking of 2.5 million manuscripts, one of the most important things is to be consistent over time. Because if you catalog in a particular way in 2021, you should not be cataloging in a different way in 2029. And if person A is doing a catalog and person B is doing a catalog and person C is doing a catalog, they need to be consistent as well. So consistency was important. And therefore, a lot of focus has gone into building quality and consistency in what we do. But ultimately, it's about how users will search this catalog. It's going to be a large catalog. It already is it's got some 8,500 right now. It will continue to build. And we said, however we search this catalog, we must be accurate. What that means is if somebody's given a search term, a title, an author, a subject, or whatever, we should be faithful to the query of the user, and we must be comprehensive. So we should not leave out information or manuscripts which are relevant to the searcher, nor should we bombard the searcher with useless information. So we need to be both accurate and comprehensive. So given these goals of quality, consistency, accuracy, and comprehensiveness, we designed the system in such a way that we are able to deliver these things today. So what I'll do is I'll quickly switch to showing you some of the things that we do in terms of making the catalog. I will need to, just give me a moment, I will need to log into the system. So I'm now logged in, and hopefully all the pages that I had loaded earlier will work, and I don't need to depend very much on the internet. But internally, what you saw in Gandhar's presentation was what the metadata that we capture, how we deal with that externally. Internally, we get a similar view. And here is an example of something which has been done recently. So this is a list of something like 70 or 80 data points that are captured by the process. The process is designed to be easy and yet accurate. So fingers crossed, if I click on that icon, I should be seeing an image of the last page, which, fingers are still crossed, it will show up. There you go. So the idea here is, as people are cataloging and they need to put in transcriptions or look at transcriptions from the last page, they don't need to thumb through many, many images to get to the page of relevance. So for instance, if there is information about a colophon somewhere in the middle of the manuscript, you should be able to get to the right relevant colophon pages. And all of this is working straight from this data entry website. The transcriptions are here. And I told you about peer reviews. So here, these are the remarks which were made by the reviewers, who made the remarks and on what date. And once a remark has been made, for instance here, there is a transcription error noticed by somebody, the cataloger has to correct it and say, right, I have corrected this error. And then it goes back for review, and it gets approved, and then it's publishable. So the need for accuracy is managed in this way. There are a number of other features. Typing errors get eliminated, drop-down menus, and so on and so forth, but that's for later. This is a typical review screen. So things which people have to review are all here. Things which people don't have to review because either they're generated by the computer system itself or have been reviewed by other people before, come out in pink. And similarly, you get the remarks, and I have made the corrections, and so on. The foundation of this is because for one text, you can get many, many manuscripts. As you saw, we had 17 manuscripts of a particular text. So the core of this is the lexica which we have produced. In producing the lexica, what we are able to do is not have to type things over and over again. We know that if this text has been spotted as belonging to the Mahabharata, all we need to do is select the Mahabharata from the lexicon. So in terms of lexicons, we have lexicons for persons, which means authors, commentators, supporters, gurus, and things like that. Places, sorry, I'll come to places later. Titles, keywords, and subjects. So with each with each catalog entry, we associate keywords as well, which is something which is not generally available. You can do a subject search, but not a keyword search. So after reading the manuscripts, one gets to understand what are the right things to include here. So we use some keywords. So persons, titles, keywords, and subjects are linked to a text. So Mahabharata is a text, but a place is typically linked to where the manuscript was written, so it is a manuscript-related lexicon. So instead of writing Varanasi, Banaras, Kashi, and so on, there is a standard way that you represent Kashi. That's what lexicons are useful for. So we have a person lexicon, and I take this example of Jayadev because there are two Jayadevs, or whose manuscripts we have, texts we have got today. But I'm interested in Jayadev, who is the son of Bhojadev and the author of the Gita Govind. So here is a lexicon entry for Jayadev, and each person has a unique identification. And this is an important feature because when we get to 1 million manuscripts, searching through 1 million long names is not going to be very efficient, we feel. So all we need to do is, if it's a person search, look for 163, and we'll get to the right thing. So it may become for speed, this may become an important thing. A Kriti lexicon, typically, and here is Gita Govind, shows who the author is and links the author to the subjects, to the keywords, and gives some information about whether this thing has been published or not. We have a protocol by which we judge whether a manuscript is published or not. If it matches that protocol, we call it published. If it doesn't match that protocol, we call it unpublished. And then the begin and end text of the text itself. So this is the information available in the lexicon. And the gray text that Gandhar was hovering over, that information, the pop-ups, came from the lexicons. The subject lexicon is a tree, and if you go to the tree and click on one, if there's other subjects, they come in. So Kavya is, here is Kavya. So Kavya is Gadya and Padya and Sahitya, etc., and then Padya again has things. So the subject search, you can select a particular subject and say, give me everything above, or give me everything below. And that's how the subject search works. So again, comes from the subject lexicon. Now, keeping database integrity and making sure that everything is properly controlled in a big project like this requires role rights and requires users not to be able to tamper with and accidentally change data which is already in the database. So we have what we call rights for various roles. So viewing, editing, deleting, reviewing, reporting, importing, exporting. These are the things which you can do to the database, and these are the various databases. So person, place, kriti, keyword, catalog, and so on and so forth, the various databases which interact to give you this system, who has what rights to change these things. And this is dependent on the role. So a trainee cataloger can only view these things, but can change his password. But if you went to a full cataloger, who, interestingly, we call that role that of a reviewer, they can change things in different places. So Gandhar would have a role as a reviewer, and he can change the person lexicons, add, edit, delete, review them, and so on and so forth. So this is how quality is maintained through the system. Users themselves, there's Gandhar, and Gandhar is the reviewer. So he has the role of a reviewer, and he can do all those things which were mentioned here. This program requires, and this is some projections which we've just recently put in, if we've got to get to 2.5 million manuscripts in 20 years, 20 years for us is March of 2042, we need to build up to a team of 200 catalogers and a total team of 270 people by March of 28. And we therefore need to not only hire people, and that had been a challenge which we've recently sorted out, we need to hire people and train them quickly. And training is very, very important and critical. We've now recently implemented training systems. So here is the example of a trainee we have. These are all the trainees. We can look at his data. And that says he started work on the 23rd of January in cataloging training. He has so far cataloged 46 manuscripts, representing 1,800 pages. He spent 38 hours on the catalog screen. And his average accuracy is 85%. And this is all the stuff that he's been doing. This is the accuracy column, this one. And as you can see, he is pretty good when it comes to short manuscripts, which are 1 or 2 or 3 pages long. So the training, I could direct him to say, look, now you focus on longer manuscripts and get your accuracy up. And the goal is to get these people up and running inside 2 to 3 weeks, become good enough to do this job. And last but not least, how do we assign work to various catalogers? We have the experience of each cataloger and the subject matters that they've dealt with. So when I'm assigning work to people, I can say, all right, this person has done a lot of Upanishads. Here is an Upanishad manuscript. I should assign it to him. This is a Shraut series of Shraut manuscripts. I should assign to the Shraut expert. So this system that way is integrated both in terms of how the catalog is produced and how it is managed. One thing I did forget to mention, and that is that every field of metadata that we record, there is a clear-cut guideline which everybody must follow. And the guidelines are available at the click of a button, written in Sanskrit. And you click on the field and you get the guideline of what you need to do. Because manuscripts have a lot of variability. And how do you deal with the variability? By having simple rules. We wrote the rules in Sanskrit because we hire people from South India. We hire people from North India. Some can understand Hindi, some cannot understand Hindi. But everybody understands Sanskrit. So the rules are in Sanskrit and easily accessible simply from the cataloging screen. So that's what I wanted to say. I hope I was quick enough, Dr. Patel.
So I think we have scope for one question, if any.
Yeah, so just one question. So you have place for a manuscript, but what happens when there is place mentioned in the manuscript?
It is for the place in the manuscript. So this manuscript was written by so-and-so at such and such a time or on such and such a date in such and such a place.
No. I'm saying there are places mentioned within a manuscript.
No. Our job is that of a librarian.
Okay.
Our job is that of a librarian. That's what we're doing. So we're not going, yes, there are a number of places mentioned and one can
So, okay. Thank you, Sanjay ji. Thank you for your presentation. So,
Yeah, so it was Singalji, it was really a very nice presentation, and the efforts you have put in are enormous, and I can see the consistency which you were mentioning about, and also the classification that you have mentioned regarding the manuscripts, so that we can search them very easily and all. So it will take another 20 years. Users, to the search engine, etc., is available for users? Yeah. Oh, okay.
That's it. That's only really because what Gandhar did not demonstrate was the organizations. And when you register, you can identify what your organizations are. And then, although everything is being done in Devanagari, we can obviously produce the results. If you search in the organization or something, you want to look at the results in And it's an Amazon-like buying exercise. Put a manuscript in the shopping cart, pay for it.
Will somebody help him? So while the Okay, so let us start this session. Because of few reasons, we could not had the invited speech in the morning, so instead now we are going to have it. It's really my honor and privilege to introduce Professor Kutumba Shastriji, who is an erudite scholar of Advaita Vedanta, Darshanas, poetics, and Sanskrit literature. So you see the two extreme branches. On the one hand, Advaita Vedanta and Darshana, and on the other hand, poetics and Sanskrit literature. He was the director of Rashtriya Sanskrit Sansthan, and he took initiatives to make it a deemed university. And now we know it is a central university.
I don't know anything. Auroville आता है? No, this is good. थोड़ा बड़ा करके रखो. This is all right? Okay.
So after the Rashtriya Sanskrit Sansthan became a deemed university, he was the first vice chancellor of that university. And after that, he was a vice chancellor of Sampurnananda University and also Somanath Sanskrit University at Veeraval in Gujarat.
Good, that will be better. Let me see what it is. Notes will also come.
Remove the what is that, mobile? Hard disk, okay. You want both the views?
How to go next? Enter. Arrow. Okay. No. Good. Only arrow. Okay.
So, just give me one more minute. I know it's getting late, but some of the things about our invited speaker, Professor Kutumba Shastriji, I should tell. One important thing is he had several awards. One of the awards is the President Award, which he got from Pranab Mukherjee, our Rashtrapati ji. And another award was, he got Infosys, he was awarded Infosys chair at Bhandarkar Oriental Research Institute for 2 years, and during which he worked on very important topic, which is important from the point of view of discourse analysis, and that is the Tatparya, what is Tatparya? And he looked at various interpretations, various manuscripts, and based on that, he has his book will now come out in soon from Bhandarkar Oriental Research Institute on the Tatparya. And today he is going to speak on that. But he didn't stop after that. After retirement, he is very busy, especially with this work on the Tatparya at Bori. And after completing this work, he has now ventured into another one. He got another fellowship from ICPR, and he's again working on a very important work on the Adhikaranas, and again, a very difficult text to understand, and there are very few scholars who can work on such texts. And we are very fortunate to have Professor Kutumba Shastriji here to tell us about what is there in our Indian Shastras. And now I think is the time to know, for all of us to know about the discourse analysis and how we decide how one adhikarana or one text is related to another text, or one paragraph is related to another paragraph, what are the parameters, and we would like to hear these things from you. Thank you for accepting our invitation.
Thank you. श्रीवेङ्कटाचलाधीशं श्रियाध्यासितवक्षसं श्रितचेतनमन्दारं श्रीनिवासमहं भजे। गुरुर्ब्रह्मा गुरुर्विष्णुः गुरुर्देवो महेश्वरः गुरुस्साक्षात् परं ब्रह्म तस्मै श्रीगुरवे नमः। सदाशिवसमारम्भां शङ्कराचार्यमध्यमाम् अस्मदाचार्यपर्यन्तां वन्दे गुरुपरम्पराम्। I think I am audible. Okay.
At the outset, I express my deep sense of gratitude to the organizers of 7th Conference, International Conference of Sanskrit Computational Linguistics, which is very pioneering and a very new area of developing area of research, especially to Professor Amba Kulkarni Madam, who was always kind enough with me, and also earlier also I spoke once, twice from the platform provided by her in Hyderabad and other places. Today, Tatparya means, in nutshell, there is one crisp Sanskrit sentence, Gatosta Markaha. There are a good number of Sanskrit students here and scholars here who can enjoy this. Now, what is the meaning of it? Sun has set, that's all, nothing else. But it gives okay. So it gives different meanings for different people. For a brahmacharin, it means that it is now time for performing Sandhya Vandana. For a cowherd, it means that now I must make my herd in returning its home. For similarly, there are 10, 15 meanings are provided in Kavya Prakasha itself, and now I don't have time to dwell on that. This because Vaktru Bodhavya Kakunam Vakya Vachyanya Sannidhe Prastava Desha Kaladehe Vaividhyat Pratibhajusham. This is what is said. So many components are there. When we come to the question of Tatparya and Vyanjana, ever since I missed first time Ambaji, I was repeatedly telling this. At that time, sometimes machine capabilities must be immensely more. I don't say impossible, but human computer is par excellence. So in any way, I did some work on Tatparya. 4 questions I addressed. What is Tatparya according to various authors? Text-based study only, because we are incapable of going outside the text. We are only just like parrots. Whatever is there in the text, we will only tell that, not going much beyond it, except here and there some touches be given. Secondly, what is Tatparya? Where is Tatparya is needed? Why Tatparya should be accepted? And how to know the Tatparya? This how to know Tatparya is very vast field, with which I think we are more concerned. And in that, I am doing today a small presentation. Let us see, let me read as an introduction. Vedas are the most ancient and largest groups of books. Vedas, groups of books, is not right, because we consider Veda is only one. It is Veda Vyasa who divided it into 4. So, according to Indian tradition, Veda is only one. So, its size is, you can imagine. But anyway, taking the nowadays popular view, largest groups of books held to be impersonal by the faithful in India. Impersonal apaurushaya, with no human origination. They contain hundreds and hundreds of chapters, thousands and thousands of passages and sentences. No exaggeration. Even 1,000 may be a small word, the sentences number may be in lakhs also. They carry ideas mutually complementary sometimes, and sometimes mutually contradictory too. Hundreds and hundreds of rituals are mentioned and described in these texts. The language is evidently very old and archaic, because date of Veda is anywhere between 6000 BCE to 10,000 BCE. Therefore, a great question arose as to how to explain them keeping consistency in mind. Several attempts have been made to address this problem from time immemorial. Content-wise, the Vedas are mainly concerned with two things, rituals and philosophy. Therefore, Indian Shastrakaras addressed themselves with the greater need of evolving a consistent theory and system through which the form of the rituals can be constructed with all the details required by a performer. Thus, a huge system came into existence through sage Jaimini in the name of Purva Mimamsa and continues still giving possible solutions to textual and hermeneutical problems. This has resulted in evolving around 1000 principles of laws or nyayas. Dvividohi vedokto dharmaha pravritti lakshano nivritti lakshanascha. This is Gita Bhashyam of Shankara Bhagavad-pada. Vedartha is of two types. One is pravritti dharma and the other one is nivritti dharma. The first one is rituals, the second one is philosophy. Similarly, another system came into existence through sage Badarayana Vyasa to evolve a spiritual and philosophical theory through reconciling various seemingly conflicting statements to fall in line with each other or with the central teaching of the texts in the name of Shariraka Mimamsa. This system added around 191 principles, laws or nyayas or principles of discourse as figured out through Amba Madam. Thus, a huge system came into the existence to interpret the Vedic lore. Okay. Thus, the Indian hermeneutical tradition, hermeneutics is the right word or not, I doubt it. Our term is Vakyartha Vicharana. Vakyartha Vicharana is coined by Shankara Bhagavad-pada in one of the Adhikaranas. He says Vakyartha Vicharana or Shastrartha Vicharana, something. Thus, the Indian hermeneutical tradition is as old as and as vast as the Vedas. We will share a few thoughts on a basic set of 6 principles which have been widely used by both the Mimamsakas and the Vedantins. They are invented by the Mimamsakas, as the case is mostly so with regard to the Indian hermeneutics, and elaborately discussed in the 3rd Adhyaya of the Shabara Bhashya, which is also called Angadhyaya. According to Kumarila Bhatta, these are foundational in Purva Mimamsa. These 6 principles are very foundational in Purva Mimamsa. He made an observation that the rest of the Shastra, consisting 9 chapters, depends directly or indirectly upon the conclusions of present 3rd Adhyaya. That is the significance of Angadhyaya. It is called Angadhyaya. And I am drawing your attention now today to another great author in Advaita Vedanta, who is considered to be number 2 in the parampara of Acharya Parampara of Advaita Vedanta. He is popularly called by Vivaranacharya. Never, his name is not at all known to the junior students, but his name is Prakashatma Yati. Prakashatma Yati, but he is always referred to as Vivaranacharya. So he wrote one Panchapadika Vivaranam. Therefrom, a school in Advaita Vedanta has begun. Before that, there was in existence Bhamati school. So there are 2 main schools after Shankara Bhagavad-pada, 2 main schools. One is Bhamati line of interpretation and the other one is Vivarana line of interpretation. Both of them are Advaitins, only some subtle differences here and there. Prakashatmayati also says, and this Prakashatmayati also speaks about Shrutyadi. We will be discussing them in detail. Sakala Shastrartha Nyaya Avagatyartha Muchyate. He says, to understand the entire Vedanta Shastra, these 6 principles are analyzed by me here. They are Shruti, Linga, Vakya, Prakarana, Sthana and Samakhya. Mimamsakas have not only evolved these 6 principles, but also 6 Tatparya Lingas, Upakrama Upasamharo, Abhyasaha, Apurvata, Phalam, Arthavadaha, Upapattischa. These are also 6. They have some fascination about the number 6. They invented 6 pramanas for karma bheda. They invented 6 pramanas for krama. They invented 6 pramanas for namadheya. More or less, all their sets of principles carry the number 6. I do not know what kind of fascination Jaimini was having for number 6. We must do some good research and find out peripherally. That's of course, you can forget about the comment. Now, Shankaracharya and Madhvacharya quoted the Jaimini Sutra 3.3.14 and acknowledged the importation of the above principles into their system. That is, Mimamsaka's principles are imported into Vedantin's system. However, my observation, this is my personal observation, Shastra has no sanction and Pandits do not agree. However, the nature, the conception, the application and the result of application in the 2 systems via Mimamsa and Vedanta appear to differ from each other. Similarly, the Jaimini Sutra quoted above clearly speaks about the weakness of the later principles in respect of earlier ones. It is called Paradaurbalya, theory of Paradaurbalya. Uttarottaram Durbalam, that is Shruti, Linga, Vakya, Prakarana, Sthana, Samakhya. So, Linga is weaker than Shruti. Vakya is further weaker than both Linga and Shruti, like that. Though Samakhya is the weakest principle. Weak in the sense, when there is a clash between Shruti and Samakhya, you should go by Shruti, not with Samakhya. That is to decide it. They have Paradaurbalya theory, which is mostly maintained in the Mimamsa system, whereas in the Vedanta, violations of the said theory are significantly more in number. This is how I say these 6 are not the same 6 as Mimamsakas held. Anyway, it is my personal view. To make this point clear, first of all, we may examine the definitions of these principles provided in the respective 2 systems, and secondly, discuss the reasons for violation of Paradaurbalya theory. The sutra is this. This is Jaimini Sutra 3314. No, I do not know Jaimini Sutra number. It is quoted in Jaimini Sutra 3314. Yes. Shrutilinga 3rd Adhyaya. No, it is Shankara Bhashya reference. Okay, I don't have Mimamsa reference number. Shrutilinga Vakya Prakarana Sthana Samakhyanam Samavaye Paradaurbalyam Artha Viprakarshat. Now, coming to quickly, I browsed because it's a little bit technical one. So let us not deal with it very in detail. Superficially, let us understand. Nirapeksha, there are two, see, all that I want to say is, there are 2 sets of definitions of the same principle in the Mimamsa tradition. That is, one is apparently appears to be general and applicable in wider perspective. The second one is very technical and applicable only to the Mimamsa particular Shastra and its prayojana and its need. It addresses only the need of Mimamsa. These 2 sets are evolved by Mimamsakas. Now, what Prakashatmayati has done is, he adopted the general one and ignored the technical one, because his job is not rituals, explanation of rituals. His job is to decide about the Brahman, meaning of the passage, meaning of the some terms. We will come to that. So, Nirapeksho, everywhere I quoted it, Nirapeksho Ravaha Shrutihi is one definition. It means not very much. It is very, very weak in its construction, but applies in a very wider area. The sound, the shabda, the word which has no apeksha or which has no any apeksha of any other pramana, that is the Shruti. Nirapeksho ravashrutihi. Shruti, see for example, if I say vrikshaha, the word doesn't have any other apeksha. For a person who of course know the samjna samjna sambandha, it has no apeksha of anything more than knowing samjna samjna sambandha, that it is tree. So it is a shruti. Now you see how they have expanded in technically. Shrutirnama angatva ghatakibhuta paroddesyata kritikarakatvayoho anyatarasya pradhanyena vachaka shabda. There are two principles. Angatva nirnayaka principle. Angatvam is defined in two ways. One is paroddesyata. Second one is kritikarakatva. These two terms, once I explain, but later on I don't do that. Paroddesyata means its uddesya is something else than itself. For example, a servant is there in an office. His uddesya is the manager of the office, but he is a subordinate to him, anga. So manager is the principal and he is anga. So para uddesyata, uddesyam is something other than itself. Then paroddesyata, that criteria makes the person or the thing or whatever it is an anga, a limb to something else. This is angatva swarupa. Second is kriti karakatva. It should be karaka to a kriti prayatna. For any, it should subordinate as a karaka to a particular action. Once anything that is ghatena jalamanayati. So this pot is anga for bringing the water, because bringing the water is a kriti and pot is a karaka. Without pot we can't bring, of course, we can't bring the water. So kritikarakatvam is also angatvam. Wherever you find paroddesyata or kritikarakatva, it should naturally be an anga. It cannot be principle. It cannot be principle, but is only anga, either in loka or veda, in the laukika Sanskrit or everywhere. This holds good. Even in human relations also, it holds good. Paroddesyata kritikarakatva. Now, an example, I simply go, there is a lot of discussion in every adhikarana, so much of discussion are there. So, aindriya garhapatyam upatisthate. In aindriya is one word, there is a tadhyata pratyaya, as all of you know. So, indra sambandhinya richa. The rik is related to indra. Related to indra by what way? Praising the indra. So, the rik is in the form of praise to Indra. Upatisthate, prarthayate, for example. Now, because of Aindriya, Tritiya is Karana, Karana Vibhakti, Upatisthate is Kriya. So, what it comes to our mind first is this rik, this particular mantra of Indra Devata should be used in the upasthana. Then whose upasthana it should be? On the samarthya, on the capability of the word and tadhyata pratyaya, the mantra should be used only when you are invoking the god Indra. It results from that. Aindriya upatisthate. But Shruti says, Aindriya garhapatyam upatisthate. This is the Shruti statement. It is a Vedic sentence. You can't alter it. So, Indra sambandhinya richa garhapatyagnim prarthayate. Though the mantra is devoted to Indra and Indra's invocation, prayer should be addressed to only the Garhapatyagni. There are three Agnis, Garhapatyagni, Ahavniyagni and Dakshinagni. There are three fires. Through the help of three fires, various yajnas are performed. And Garhapatyagni, when you pray to the Garhapatyagni, you should use this Indra Devataka mantra. How we decided it? Now, this mantra, Indradevata mantra, is the anga for Garhapatyagni Prarthana. Now we got it. How we did get it? By its capability, own capability, by its other way, if we say, if it is left to us, we may be using this mantra to invoke the Indra god only, not Garhapatyagni. Aindriya upatisthate. Because Trutiya is there. But Shruti says, Aindriya Garhapatyam upatisthate. So this mantra becomes anga for angi of upasthana, that is prayer addressed to Garhapatyagni. So angangi bhava nirnaya. This is what is called angatva nirnaya and all that. Now Shrutihi, now Prakashatman, P means Prakashatmayati in Vedanta. P means Prakashatmayati in Vedanta. First two are Mimamsakas. Shrutihi padantara nirapekshaha shabdaha. Padantara nirapekshaha shabdaha Shruti. Yaha shabdaha padantara apekshito nabhavati. Saha Shruti. Now we have to analyze these definitions also in detail. That is the job presently I am engaged in. P's definition is on the lines of that of old Mimamsakas. Nirapeksho shabdaha and padantara nirapeksha shabdaha. Just it appears to be a little bit of explanation, but the general one is adopted by Prakashatman and the technical one is dropped because Vedantins do not have any issue of Angangi Bhava Nirnaya. Because there is in Brahma Vidya, there is no Anga and Angi. It is only to decide the meaning of the right meaning of a few terms, the Vedanta Shastra goes on. Murari Mishra, who wrote Angatva Nirukti, one small book, Angatva Nirukti, says, Nirapeksho Ravaha is the age-old definition of older Mimamsakas. He himself accepts that Nirapeksho Ravaha is Prachina. Prachina Pravadaha. This is his word. Prachina Pravadaha. Now I defined it as per the need of the Mimamsa, that Shrutirnama, Angatva Gatiki Bhuta, etc., etc., etc. Murari Mishra says, this is according to later Mimamsakas, Navyastu. Oh, this second Lakshana is because of Navyas. Navyas means later. So, what you can draw is the general definitions, whatever they are, they were the real Prachina definitions, and later on they have they have condensed the area of its application and defined it technically so to suit to Mimamsa. This exercise has been done because of their need only, nothing. Later Mimamsakas brought in concept of case ending which expresses auxiliarity. Later Mimamsakas also, later in the sense beyond Murari, some people have added Vachakaha Vibhaktihi Shrutihi. So Trutiya, Chaturthi, Panchami, it should be a case ending according to Navya Mimamsakas. For P, it can be a word, it can be a sentence also, or even a passage, not necessarily to have case ending. So this is the striking dissimilarity between Mimamsa and Prakashatman's definitions. No need to express auxiliarity because he is not concerned with auxiliarity. Precisely for the reason that Prakashatman's definition is non-technical and general, principle Shruti is referred to in the Brahma Sutras by its various synonyms generated from the root Shru, such as Shruti, Shruta, Shravana, etc. Usually, technical terms cannot have an equivalent other term. Usually, guna, adeng gunaha means only guna. You can't replace the paribhasha guna with any other word. As long entire Panini system, guna means au, a or something. So, but here in Brahma Sutras we have got several synonyms that itself is a proof that it is not technical. It is not paribhashika. Shabda is also used in the same sense directly. In addition to these, the Shruti is referred to by a long list of its equivalent terms numbering 37 as long as I have observed they are Vyapadesha, Vyapadishta, vagera, vagera. Let us skip it. Now, linga is defined by the Mimamsakas as the competence of words to indicate the auxiliarity. Again, this is a Prachina definition. They only told competence is the Samarthyam Lingam. However, Samarthyam Lingamiti Pranchaha. Samarthyam Lingamiti Pranchaha. Taduktam Samarthyam Sarvabhavanam Lingamityabhidhiyate. This is Murari Mishra. However, as in the case of Shruti, the later Mimamsakas defined it more technically as linga is the indicative competence possessed by the existent word to conjecture the expressive word, which in turn convey either one of the two types of auxiliarity, namely intendedness towards something, that is paroddesyata, or being an instrument in accomplishing an action, or kritikarakatva. So, Samarthyam Lingam Mimamsa Nyaya Prakashaha. Tatra Lingam Nama Angatva Ghataki Bhuta Paroddesyata, etc. Blah blah blah. Then Barihir Deva Sadanam Dami. Barihi Deva Sadanam Dami. Barihi means a kind of grass. Dami, the verb is used. So, though avakhandane is the root, so it is cutting. Dami means khandanam karomi. Therefore, where should this mantra, it is a mantra, Barihir Deva Sadanam Dami, this mantra, where should it be used? In the action of cutting the barihi, cutting the kind of grass called barihi. How do we know this anga? Cutting of the grass is the angi, kriya, and anga is this mantra, Barihir Deva Sadanam Dami. How did we know that? Because Dami, the word do avakhandani itself has got some competency and capability to express its angatva towards cutting the grass. Therefore, this is a linga. Now let me quickly go through. Prakashatman defines linga as linga is the indicative capacity of words which is of the nature of an invariable relation with a distinct meaning. This is added by Prakashatman. An invariable relation with a distinct meaning is added by Brahman is the distinct meaning they want to prove. So, any Visheshana or any property that has been spelt out in a sentence which happens to be connected with the Brahman in an invariable relation, that is linga. On that strength of it, they prove that it is the term is Brahmavachaka, linga, capacity. In short, it is the indicative meaning obtained on the basis of a distinctive characteristic expressed therein. Sruta Samarthyam Arthantarena Avinabhava Lakshanam Lingam. Linga is used about 16 times in the Brahma Sutras, either in support of Siddhanta Paksha or Purva Paksha. Vakya is defined by the Mimamsakas as Samabhivyaharo Vakyam. Again, this is old one, old definition. Samabhivyahara means uttering in a sequence. In its wider perspective, the term Vakya should signify all the sentences of the Veda. Therefore, both Shruti and Linga may also fall under Vakya in some sense or other. Hence, to distinguish the special characteristic of this technical term Vakya, it is explained by them as Vakya is utterance of words in a sequence denoting the principle of auxiliarity without such words being possessed of case endings which signify the auxiliarity directly. Because auxiliarity directly by case endings is a Shruti. So, there should not be a vibhakti to prove the angatva, but the entire sentence should have a capability to show that it is an anga to something. Let us go to example, then only these things will be somewhat clear. Angatva Ghataki Bhuta, etc., etc. is the same. Ghataki Bhuta Kritikarakatva Anyatara Padartha Kalpananukula Srutapada Sannidhi is Bhatta Deepika. Now, one more thing the scholars should note, that in the system of Mimamsa, every later principle, though it may help you to decide the angatva and sentential meaning and all that, it should create, one minute, English words are sometimes cause problem. That is, it should Krudigartha Anyatar Padartha Kalpananukula. They want, what they say is, Vakya should artificially create linga, a sentence with linga, and linga Vakya should again generate a Paurusheya sentence of Shruti, then only the sentential meaning will come. This one has to examine, we have to keep these things in our mind, how the computer will also ask for it. Whether directly Vakya cannot give the meaning of the Angatva, it should create in between Linga and Shruti. Because what I felt is, as a general scholar without any computational background, what I felt is, for Mimamsaka, Shruti is only one pramana. Because it is an alaukika, a relationship between doing a ritual and getting a result. It's not lokasiddha. It's not from any other pramana we know, if we do Jyotishtoma, we will get Swarga. There is no way to know the relation between Jyotishtoma and Swarga except Veda. So therefore, Veda is only in the form of Shabdas, Shruti. So Vakya cannot decide the Angangi Bhava. It should, Shruti only should decide. Therefore, and Shruti is not there, only Vakya is there. So what you should do is, Shruti should, what you call Kalpana, English word. Shruti should imagine, Shruti should imagine the, not imagine, you have to generate the Linga Vakya, and then you have to generate Shruti Vakya, and then only it will become its Anga. This is some technical system they have, which technical issue has been dispensed with in the Vedanta. That's what I wanted to emphasize. Vedantins are closer to our computational linguistics. Let us see. I hope I am clear. Now example is, Yasya parnamayi juhur bhavati nasa papam slokam shrunoti. For the yajamana, for the person who performs the ritual, juhu means a kind of spoon. Chamasa is also spoon, juhu is also spoon, through which drava padartha is put into the fire. You know, some wooden, they put every day in Tirumala Kalyanam, they put ghee with some wooden spoon. That SVBC channel you can see. That is what is called juhu. And this juhu should be done by what kind of wood? You see, every particular is to be given by Veda. Ritual means you have no swatantriya at all. Whatever is told in the Veda, you have to follow the same thing. So there are so many woods. Doing juhu is only 2-minute job. No, there are prescriptions for to do with particular wood and all that. There a sentence is there, Yasya yajamanasya, for which yajamana, the juhu happens to be parnamayi. Parna is a kind of tree. Parna is a kind of tree. Juhu, which is made of parna wood. If he holds it and if he performs the sacrifice, papam slokam nasrunoti. For him, there is throughout his entire life, there will not be any detriments of doing anything or any loss of property or progeny or anything. Papam nasrunoti. That's all. That means always he will be happy. That's what this sentence says. Now, parna wood is anga, juhu is angi. This angangi bhava, to decide this angangi bhava, there is no vibhakti, because tritiya is not there. Yasya parnamayi juhur bhavati. It is only prathama. So there is no vibhakti, case ending. So this is not the case of Shruti. And it is not linga, because linga is mostly by one word. Here it is a sentence. The full sentence has got the capability. Therefore, it is Vakya. Yasya parnamayi juhur bhavati nasa papam shrunoti. In the Brahma Sutras, we do not come across any reference to the principle Vakya directly, but we find 3 sutras where a possibility of a reference is felt to some extent. They are Pranadayo Vakya Sheshad, Vakyanvayat and Asadya Padeshat. In all the 3 places cited above, the text which follows the present Vishaya Vakya is referred to by the term Vakya as per the Shankara's commentary. Though explanation of Samhavyahara may not be very difficult in these cases, yet it is difficult from Mimamsaka's conception of the term Vakya. Let us move. Prakash Atman defines Vakya as the capability of several words. This expects both the denotative meaning Shruti and indicative meaning of the words in deciding the relation of the denotative and indicative meanings of the words given to our knowledge by the primary and secondary powers of words. Aneka pada samarthyam Vakyam. Prakarana. Mimamsakas define the prakarana as mutual expectancy. Ubhayakanksha prakaranam. There are 5 sentences in a sequence, namely Samidho Yajati, which enjoin rituals called prayajas. Samidho Yajati, Tanonupatam Yajati, Ida Yajati, Barihir Yajati. There are 5 Yajati are there. For none of these 5, no result is told by the Veda. So they have got an akanksha of what is my result. If I do Samidhyaga, what is my phala that is I am going to get? Phala akanksha is there. And see the farce, after some time or before that, there is one sentence, Jyotishto menas, no, Darsapurnamasabhyam yajeta. Darsapurnamasabhyam swargakamo yajeta. Darsapurnamasa is prescribed for swarga phala. For Darsapurnamasa, how to do it has not been spelt out there. Darsapurnamasa is a big activity, but it has got some subordinate activities. Cooking food is only, we say simply cooking food, but it has got several hundreds of actions before actually the food is ready. You know, hundreds of actions, not even, I am not exaggerating, hundreds of them. So, similarly, in ritual also there are avantara rituals, they have not been told there. So, it has got some, how should the Darsapurnamasa be done? So, Darsapurnamasabhyam Swargakamo Ejeta sentence has got an akanksha of, which is called Katham Bhavakanksha. How should it be performed? And Samidho Yajati Tanunapatam Yajati 5 have got Phalakanksha, what is my result? So, Nashta Asya Dagdharadhanyaya. Now, combine both of them. So, all 5 prayajas are to be treated as limbs of Darsapurnamasa. Otherwise, how do we know there are 5 limbs of Darsapurnamasa? This is how Mimamsakas explain the huge, mind-boggling size of Vedic sentences into a proper system and evolve the form of the ritual. Even form of the rituals are not straight away told line by line, everything in one place. This Vedic literature is a very big problem, I tell you. It is easy to recite, but you enter into that, sooner you enter into it, you are lost. Such a problematic, huge corpus of literature is given to us by whom God knows. Samidho Yajati, etc., which enjoins rituals called prayajas, without mentioning the result of such rituals. Therefore, all these 5 sentences carry expectancy with regard to their result. So, Ubhayakanksha Prakaranam. So, this is Mimamsa. There is another text, namely, Darsapurnamasabhyam Swargakama Yujeta, which enjoins the ritual, Darsapurnamasa, and its result is Swarga. But the sentence, it did not say the modus operandi. Therefore, this sentence has got Katham Bhavakanksha. This arises, therefore, arises mutual expectancy. Prakash Atman defines Prakarana as the capability of 2 sentences, objects of which are contextual on the basis of either mutual expectancy or expectancy on the part of any one of the 2 sentences. Anyatarakanksaya, itaretarakanksaya va, వాక్యద్వయ సామర్థ్యం ఆరభ్యాధీత విషయం ప్రకరణం. Prakashatman defines prakarana as the capability of two sentences. The principle prakarana is cited in the Brahma Sutras for about 8 times. In one of these sutras, we find the term prakrutatva used in another sutra 2.3.12, the term adhikara in place of prakarana. In all these instances, it is found that the word prakarana is used in a non-technical and general sense of context, but not in the technical sense of mutual expectancy. In the Sutra 1-10, Prakaranacha, the text of the Kathopanishad is cited in support of the argument that context belongs to the Brahman and not to the fire or Jiva, which in turn helps to decide the meaning of the word Atta. Atta, Charachara Grahana. There is a devourer is described in the Kathopanishad. Yasya brahmacha kshatrancha ubhe bhavati vodanaha mrutyur yasyopasechanam kaitha veda yatra saha is the sentence of Kathopanishad, in which devourer is. Who is this devourer? Is it a human person, or is it Vaishwanara Agni, or even outside the Agni, or Brahman? This is the dilemma that is to be resolved in the Brahma Sutras, and it is decided in favor of the Brahman. Why? Because yasya brahmacha kshatrancha ubhe bhavata bodhana, the entire human race, brahmacha kshatrancha only are the pickups. They stand representative of the entire Jiva Sanghata. Entire Jiva Sanghata is bhojana for only the Brahman, because a person can eat only a little bit of meat or something, he cannot devour the entire Jiva Loka. Devourer, stated in the text of Kathopanishad. Again in the Sutra Prakaranat, the Mundaka text is cited to prove that the context belongs to Brahman, which in turn helped to decide the meaning of the text of the Mundaka in favor of Brahman. In the instances cited above, the two texts or the meaning of the two texts are not in mutual expectancy. That is what I am underlining, as in the case of Prayajas and Darshapurnamas. Hence, the term Prakarana is used in the Brahma Sutras in a general and non-technical sense. It is precisely because of this difference in its use, synonyms of Prakarana such as Prakrutatva, Adhikara could also have been used. In fact, the term Prakrutatva expresses the desired meaning of the context in a better way, and that is why Shankaracharya repeatedly used the word Prakruta in his Bhashya. The Prakarana of Vedanta and Vedantins may be equated to the technical term of Arabhyadhita in the Mimamsa tradition. Sthana is defined by the Mimamsaka as the placement of the two texts in proximity. They divide the sthana into Patasadesya and Anusthana Sadesya. Patasadesya is again divided into Yathasankhya Patha and Sannidhi Patha. Mimamsakas give several examples to illustrate the application of the principle in their texts. Desa Samanyam Sthanam. I am not giving the examples because it will consume time. Prakashatman defines a sthana as a respective relation of two sets of sentences placed in particular order. In principle, this principle expects the cognition of the capability of two sentences which express two sets of different objects in a particular order. Krama sannivishtanam krama sannivishtaih yathakramam sambandha sthanam. Let us browse through. As far as the Brahma Sutras are concerned, this principle sthana has not been used in them. Even though 3 sutras do have sthana word in them, there the meaning of sthana is somewhat different from the sthana which we are discussing. I made a note on that. Let us move. Samakhya is defined as a word rooted in etymological meaning. A spoon is called Hotru Chamasa. This is interesting. A spoon is called Hotru Chamasa. Its name is Hotru Chamasa. Because of the capability of the name itself, the Chamasa means again spoon, wooden spoon by which something can be eaten. So, who should eat by this spoon? It is only Hota should eat by that spoon. The other priests should eat the same Purodasha with other spoons than the Hotru Chamasa. Because Hotru Chamasa name itself carries that this particular spoon is Anga for the eating of the priest called hota. By mere name, it gives angangi bhava. This is how they enter into the system, the sentences, and come out with some good results. Following the etymology of the word hotru, he is obliged to eat by it and not by any other means. In this way, the hotru chamasa, which is etymological in its nature, functions as a principle of deciding the auxiliarity of chamasa to hotru. We find this principle cited in the Brahma Sutras once, 338, samjataschet taduktam astitu tadapi. Here a Purvapaksha is made on the basis of samjna, that the Udgita Vidya of Brihadaranyaka and Chandogya Upanishads should be treated as one and the same. Actually, it is not quoted in Brahma Sutras, we can say, because it is cited only with regard to Purvapaksha. Whether it is Purvapaksha or Siddhanta, it has been used in the Brahma Sutras. That's what we want to express. Prakashatman defines Samakhya as the capability of a name in establishing a relation between two meanings which have been known from two different sentences. This principle expects all the earlier principles in deciding a meaning. Sambandha pratipadane vakyantara pratipannasya vakyantara pratipannenarthena sambandha nimittam samjna samarthyam samakhya. Okay. Scheme of Prakashatmayati. Except in the case of Shruti, it is capability that acts as the characteristic of being the principle of interpretation. These are some points noteworthy to note. Principle of interpretation is the only, except Shruti, the other five do have only capability as one of the characteristics. Capability is defined as, Prakashatman has defined as the state of being related through an invariable relation with a distinct meaning. Avinabhavena sambaddham, we have seen it in defining the linga. If a single word, now you see his scheme, which is very interesting. If a single word possesses such capability, it is linga. If many words put together possess that capability, it is vakya. If it lies in two separate sentences consisting several words each, it is prakarana. If it rests with two sentences and the two sentences establish a relation on the basis of order of the place of objects in both the sentences, yathakrama sambandha, it is a sthana. And if it lies with samjna, capability lies with mere samjna or name, in different chapters or texts, it is Samakhya. So therefore, there is a scheme behind Prakashatman's understanding of these principles. We can see a kind of progression in the said capability, Samarthya, from Pada level to Vakya, Vakya level to Vakyadvaya, Vakyadvaya level to Vakyadvaya along with respective relation to Adhyayadvaya and Granthadvaya. This is the distinctive and significant contribution of Prakashatmayati in understanding these principles. Another important contribution of Prakashatman in this regard is his statement that every later principle expects the previous principles in giving rise to the meaning. There is no kalpana, there is no need of generating the non-existence sentence as such in Vedanta, but expectation is there. That's why everything will expect only Shruti, ultimately. Meaning, according to him, this is the reason for the weakness of later principle than previous principles. Naturally, later principle expects the previous one, so it becomes weak and the previous principle happens to be strong. However, Prakashatman has not expressively stated anywhere that every later principle should assume what a kalpana assume. I translated here, I was searching there. Should assume the previous principle as is accepted by the Mimamsakas. This expectation of previous principles is well understandable because Prakashatman's scheme is from Pada level to Mahavakya level, and the expectancy of a Vakya towards Padas and a Mahavakya towards Vakyas is an established fact. In this way, the theory of Paradorbalya is retained by Prakashatmayati following Mimamsakas. Prakashatmayati as well as Shankara Bhagavatpada quote the Jaimini Sutra, as I already told. Striking dissimilarity is the dropping of the component of auxiliarity by Prakashatman. Prakashatman's definitions and definitions of old Mimamsakas are mutually closer. From this important observation of Prakasha with regard to theory of Paradurbalya, no sublation of weaker principle by the stronger principle in peace scheme. Aindriya Garhapatyam Upadishthate. In peace, Prakashatman's scheme, it is harmonizing or explaining away of the weaker principle to fall in line with the meaning of the stronger principle. There is no sublation as such, but somewhat it should be made diluted. The meaning of the second sentence is to be diluted, which has to fall in line with the sentence that is held to be stronger. The meaning of the weaker principle is also retained, but modified on the basis of well accepted norms. For that also again norms are there. From the discussion on definitions made so far, two distinctive features of these principles emerge. Firstly, a general and broad-based nature. Secondly, a particular technical and with limited applicability. Mimamsakas adopt the second and the Vedantins the first. Mimamsakas use them for explaining the auxiliarity, whereas Vedantins has criteria to decide the meaning of terms, sentences and passages. Mimamsakas prefer assumption of earlier principle by later principles to essentially to be valid means of knowledge. Such assumption is not contemplated by Vedantins, though Paradurbalya theory is accepted. Violation of Paradurbalya theory is occasional in Mimamsa, whereas it is very common in the Vedanta Shastra. There is a strong case to treat these principles as two sets of principles with identical names based on the conception, definitions and application. But Shankara Bhagavatpada is explicit in saying that there is only one set of principles evolved by the Mimamsakas, that is Linga Bhuyaswadhikarana. Badrayana Sutra 3.3.49. Not only Shankara Bhagavatpada, in Badrayana Sutra itself, Shrutyadi Baliyastvacha Nabadhaha. There is one more sutra, because even Badrayana accepts that these are the Mimamsaka principles, but defined in a different way. As a measure of reconciliation, we may say that these six principles are originally principles of hermeneutics, Shrutyartha Nirnayaka Pramanani. Mimamsakas have used them contracting their nature and applicability. Vedantins used them as they are. The reason for such a difference in approach is Mimamsakas are concerned with the explanation of karma, whereas Vedantins are concerned with the explanation of Brahman. Karma is a sadhya and in need of auxiliaries. Karma is in need of auxiliaries and it is a sadhya, it is not siddha. And Brahman is siddha and the nature of revelation and of the nature of revelation on the basis of samajnana of Vedantic passage. This siddha sadhya bheda is there between Purva and Uttara Mimamsa, which has been phalajijnasya bhedacha Shankara Bhagavatpada in detail explains under Sutra 111. Mimamsakas have never been explicit in stating that these are determinants of meaning. They never said they are the meaning determinants of meaning. Neither the Vedantins expressly told it. Mimamsakas called them Angatva Nirnayaka Pramanani. Vedantins just called them Shrutyadi Pramanani. Bhatta Someshwara, one Mimamsaka, in the Nyaya Sudha says that Prakarana is a well-known means of understanding both in Veda and Loka. But my opinion is he may be referring to the Prakarana of the set of 14 principles explained by Bhartruhari, Sanyogo Viprayogasya Sahacharyam Virodhita, Arthaf Prakaranam Lingam, Sabdasyanyasya Sannidhi, Samarthyamauchiti Desha Kalo Yaktiswaradaya. And maybe he is referring to that, we have to examine it. I am not conclusively saying anything. It is only Prakashatmayati in the Advaita tradition and Vyasatirtha in the Dvaita tradition have stated this difference in clear terms. Violations of Paradurbalya Niyama in Vedanta are more in number than observance. Ground for such violations is the support of Tatparya in almost all instances. 6 principles of Tatparya are called Tatparya Lingas. They are Upakramopasamharu, Abhyasopurvataphalam, Arthavadopavatti cha Lingam Tatparya Nirnaye. Near unanimity in defining them and application of them. No problem with Mimamsakas and Vedantins with regard to Tatparya Lingas. Again, they are also 6. The 6th number goes on. Upakrama, I showed in which Adhikarana, which Tatparya Nirnayaka Pramana is used, which is not now necessary. Both the sets of principles, now the question is, both Shrutyadi 6 and Upakramadi 6 are used in the Brahma Sutras. Even in the Sutra also they are mentioned. Why? If both of them are Tatparya Nirnayakas, why? So there is a very interesting one. I think I should not take much time. So I will not elaborate on that, but I made some points. They are not mutually exclusive. They depend on each other. Because deciding the meaning of a word or sentence depends upon the strength of Tatparya. And Tatparya in turn depends upon the appearance of Shrutyadi principles in the beginning and the end of the passage. What is Upakramopasamhara? One and the same word is in the beginning of a text and in the end of the text. Suppose Brahman, the word, the second valli of Taittiriya Upanishad, Brahma Vidapnoti Param, it starts with Brahma word in the beginning, and in the last sentence also again Brahman word is there. So Upakrama and Upasamhara, the Brahman word is there. So the entire context in between belongs to the Brahman. This is what is called Tatparya, Upakrama Upasamhara, Tatparya Nirnayaka. But how this Upakrama, but in Upakrama there must be a Shabda, there must be a word denoting a particular object in the beginning and the end. That is Shruti. So Tatparya Lingas do depend upon Shrutyadi Lingas. Similarly, to decide the strength and weakness of Shrutyadi Lingas, Tatparya is the driving force. So there is a kind of interrelation between these two 6 and 6 principles, altogether 12 principles. Because deciding the meaning of a word or sentence depends upon the strength of Tatparya. And Tatparya in turn depends upon the appearance of Shrutyadi principles in the beginning and end of a passage. Abhyasa means a repeated appearance. There are 6. Therefore, Badarayana relied on both the sets of principles. Anyonyasraya dosha comes. Technically it is asked. See, no question has been left out in our text. What I feel is, sincerely, we need not do any Purvapaksha, even for the sake of, even God is there existent or not, even Nastika, Astika, everything, they have been thoroughly discussed in our Shastric books only. It is our mistake that we did not read them and again going on doing our own mental exercise to prove or disprove. They are written there. Only we don't have patience to go through the complete Shastric lore. One Akashadhikarana I picked up. Shall I take 5 minutes? Little more. Here itself? Okay. Now, I will put up in my words. This Akash, or otherwise I read it, 3 slides are there. Akashadhikarana is one. Asya lokasya kagatiriti is the question asked by the student. The teacher replied, Akasha iti hovacha. Asya lokasya kagatihi akasha. Now what is the meaning of Akasha? What comes to your mind immediately? Akasha means the space that comes to our foremind and in which from boyhood, I mean every commoner also is using Akasha word in the same sense. So it is a Prasiddhi Rudhi is there and also it is in the beginning of the text, first sentence. Akasha is in the beginning of the word. Beginning has got some more strength. That is, it is called Asanjata Virodhi Nyaya. See, the first word carries greater strength than the second word. Because when the first word is uttered or born, his rival is not born. So when first child is born, he is very strong in all families. The reason is when he is born, he or she is born, The second child is not born. The second child is always weaker in all families, because by the time the second child is born, the one is already in existence. It is called Asanjata Virodhi Nyaya. These are several thousands of these Nyayas, apart from Adhikaran Nyayas, are there in our texts. Sometimes they are even Laukika Nyayas also. So in both the ways, Akasha, what should be the meaning of Akasha? Space. But now it has been decided, Akasha Stallingat. In this particular Adhikarana, Brahma Sutra, Badarayana Maharshi has decided that Akasha, by the word Akasha, it is only the supreme ultimate reality which is called Brahman is the meaning of Akasha word. How he derived it? Tallingat. Lingas are there for it. What are the lingas? Just for a moment you see. Sarvani hava imani bhutani akashadeva samutpadyante akasham prati astamyanti akasho hyevaibhyo jyayan akashaf parayanam. 4 sentences are there. All the things in the world, whatever it is, wherever it is, in Chaturdasha Bhuvanas, they are all born from out of Akasha. They all get what you call devolved in the Pralaya. They Leela, they go back into the Brahman, and Akasha is the biggest of all because he is giving birth to all the things including Akasha. And then he is the Parayanam, he is the ultimate goal of reach. Now these 4 lingas cannot be applicable to Akasha. Though to some extent Akasha is also a bigger one, because firstborn is Akasha. If you go to Taittiriya Upanishad, Tasmadva etasmad atmana akashas sambhutaha akashad vayuhu vayoragnihi agneraapaha adhyah prithvi prithvibhyonnam annam. First God has provided food, then only he created the jivas. See the compassion of the God. According to our belief, first Anna is produced and then person is produced. Because after giving birth, how he will sustain himself. Okay, now this Akasha is also a bigger one, but tasmad atmana akasha sambhuta. Now in this Adhikarana, let us conclude. Linga has become more powerful and greatly carried greater strength than actual Shruti. Akasha is Shruti, but Shrutyartha is diluted. This is the magic of Vedanta Shastra, which is not the case in Mimamsa. Usually they don't allow this to happen. Only Vedantins have, because we are concerned with the meaning. Therefore, because all the objects of the entire universe getting originated and getting involuted into the one entity, that entity cannot be the Bhutakasha, that entity cannot be the space what we see, but it can be something more than ultimate reality. So it is the Brahman, it is decided. Linga has got, Upapatti is the Tatparya Nirnayaka Pramana. On the support of Upapatti, Linga has become strengthier and Shruti has become weaker, and this Akasha word denotes only the Brahman. This is subject. Thank you all.
So much thoughts you have given, so much material you have given us for thought. I don't know what to say now, but what I have observed is this Prakashatmayati. He has given a very good step-by-step procedure to
Recording in
do the
progress.
discourse analysis. And so we start with the sentences, then we combine the 2 sentences, and then we go to the paragraphs and all that. So that is something which is really very useful from the discourse analysis point of view, I see. And we need to discuss these further in detail to understand how we can use these pramanas, these two sets of 6 pramanas for discourse analysis. And we will be troubling you again and again in order to understand this. But what the thing which I will take back is, rather than Mimamsakas, I would like to go with the Vedantis, because Vedantis are more into the meaning part of it, and this is what we also need. So maybe we will go for those 119 pramanas given by the Vedantis. And thank you very much for...
Actually, I am working on that 191 Adhikaranas. As briefed by Prakashatma Yati has brought out the logical framework behind each Adhikarana into Sharirika Nyaya Sangraha, a book written by him. I am translating and annotating and with exposition for ICPR National Fellowship.
So that will be really very
And I
useful.
need help of all the scholars available here at various points, more so help of Ambaji at that time.
So we will definitely like to read those things and see how those are useful for computational purpose as well, because I see the potential there. So thank you very much, and sorry you had to wait for a long time for this. Okay, now I think is a time for panel. Yeah, and where is Pawan? Yeah.
Hello. Yeah. So we will start the panel right away. The online panelists are waiting. So please, Professor Pawan Goel. Yeah, please. You sit down. Yeah, please. So we will have our moderator, Professor Amba Kulkarni, and the panelists, Professor Pawan Goel, and Professor Kurt Koitzer, and Professor Partho Talukdar. They are online. They are attending online. So yes. Parthaji and Kurtji, can you hear us?
Yeah, I can hear you.
Okay. Thank you very much. Professor Koitzer, can you hear us? You're on mute. You're on mute, Professor Koitzer. You may please sit down, I think. Can we get a front view so that they can see? But you cannot see them. Professor Koitzer, can you hear us? You're on mute.
I can hear you on the live stream, yes.
Okay, thank you. So we sincerely apologize for the extreme delay, but let's at least get started. So I'll request Ambaji to take over. Yeah.
Welcome, Professor Kurt Koitzer, Partho, and Pawan Goyal. I think we should sit.
I can hear you on the live stream, yes.
Okay, thank you. So we sincerely apologize for the extreme delay, but let's at least get started. So I'll request Ambaji to take over.
Welcome, Professor Kurt Koitzer, Partho, and Pawan Goyal. Hello.
Thank you. So we sincerely apologize for the extreme delay, but let's at least get started. So I'll request Ambaji to take over.
Welcome, Professor Kurt Koitzer, Partho, and Pawan Goyal. Hello.
So we sincerely apologize for the extreme delay, but let's at least get started. So I'll request.
Hello. Will you please mute your live stream, Professor Kurt and Partho, because we are getting echo. Hello, please mute your live stream, but at the same time, we should, yeah, thank you. So we have here, no, we want to be in the frame. Yeah, so we will sit here. So, Pawan, please sit here. Please. So the panel is on AI and Sanskrit, or Sanskrit and AI. With the ChatGPT, and today we also saw the presentation by the group of Kurt Quasar, Sebastian and others on the translation from Sanskrit to English, where the translation, at the same time the morphological analysis and various other grammatical features were provided. So we were very much amazed by the technology, the use of technology, and we would like to know from each of you, because all three of you are working in the field of AI, and Partha, I do not know about you, but Kurt and Pawan, both of them are definitely working on Sanskrit and AI. And I think Partha is passionate about Sanskrit, as I know, and you are in the AI. So from all the three of you, we would like to know what are your views regarding AI and Sanskrit. I would first request Kurt to start the discussion, and you will get 5 to 7 minutes for this. Hello, hello. Can you hear me?
I can hear you fine.
Yeah. So Kurt, I request you to start your presentation. You will have 5 to 7 minutes.
Okay. And can you hear me fine? If you could just nod. Okay, great. I'll just present in this way. So yes, as Amba mentioned, you heard a bit about this before. And just to get us all on the same page, I'm using a very liberal notion of Gen AI, basically anything which has a language model of some sort, a neural net in the middle. GPT-4, of course, is at the extreme. It receives a prompt, and it generates some output, as you see here. And we can see on the left here that, let's see, I'm actually seeing a bit of a delay in my slides here. That I cannot account for. You're not seeing the slides advance here? Yes. There we go.
Yeah, we can see.
Yeah, okay. We can see there's a bit of a chicken and the egg problem. There's lots of things to which we believe we could apply Gen AI technologies, desandi, sentence segmentation, lemmatization, morphosyntactic tagging. These have been issues addressed by this community for some time, as well as going further into machine translation and semantic search. But the challenge is to apply Gen AI methods, we need training data. And I just have estimates on the right here of the amount of training data, individual examples we would need for these in the hundreds of thousands to perhaps millions. And it's hard to imagine how we'll achieve these without some sort of automation. However, we in our group have a great debt to Oliver Hellwig's work available at GitHub today, open source, where he has basically training data that allows us to work on descending, lemmatization, and morphosyntactic tagging, and he has in total 600,000 examples. Now, I do want to also acknowledge, given this community, that there are many other contributors to this, from Professor Goyal, Gerard Hui, Amba, yourself, and so forth. But this is just the data that we're using. But even with Oliver's data, we still need additional sentence pairs data in the form of sentence pairs for machine translation. And I know we're short on time, but I just wanted to shout out, we've assembled a team of student volunteers here, basically from high school students from around the country at Berkeley. And we have a team led by Jivnesh Sandan in IIT Kharagpur that has also been helping us. And altogether, very briefly, using basically the Sanskrit texts that have been available to us in Unicode and PDF format, as well as the English translations in similar formats. We have some automated alignment here in the using our own technology of vector alignment, and altogether we have been able to produce about 718,000 Sanskrit English sentence pairs, which are the core of our system. Now, we use these 718,000 sentence pairs to then train or fine-tune, is probably more accurate, models. We use one, hat tip to Google here, the MATLAB 400 model, which has been pre-trained on a number of languages, and also the Meta No Language Left Behind model. And those together, with about 160 GPU hours of training, and on these sentence pairs, of which this is an example here, we produce the Mitra system. Now, in my more extended version, I went in much more detail in terms of the limitations of the system, but today let me just abbreviate that. In terms of the limitations of our current system, we have a relatively small number of sentence pairs compared to other higher resource languages. Perhaps more importantly, the training data is uncurated. The translation quality and time period varies widely. And our language models we're using are relatively on the small size of those, from 1 to 3 billion. And therefore we rely on external or generic GenAI tools for fluency and topical concept. So what this does in a result is kind of serve up what you might call a stew of various translations. Basically, just all this training data is tossed in together. It's not a concise and coherent recipe, and we hope that perhaps this can be addressed with later more sophisticated processing. In my longer version of this talk, I went on about many much more fundamental limitations that we might see from machine translation of Sanskrit. But let me just summarize that by saying these are precisely the same limitations that are faced by human translators who are translating Sanskrit as well. So just to quickly summarize, and to try to give some sense from at least my perspective, what we can reasonably hope from machine translation and GenAI. So I would say in terms of translation, we're going to get far from a finished translation. A machine translation gives us something of a good hypothesis. The basic morphology and sentential structure are worked out. And I believe from our experience with other low resource languages, this should make translators more productive. This will help produce rough translations, which allow experienced scholars to quickly navigate through unfamiliar literature. And these also allow scholars with limited Sanskrit to identify most relevant passages in Sanskrit. Personally, I'm excited. I think I'm probably unique in this audience as having probably the least Sanskrit skills of everyone here. So for me, I'm excited about the potential for this as a good support for language learners in their first few years of learning Sanskrit, and to enable us to choose literature to explore rather than rely on particular readers, such as London's readers and so forth. Looking more to the future, perhaps for another conference where we believe that GenAI technology can be used to help with semantic search, discourse analysis, and stylochronometry, and other types of stylistic analysis. Just to flash again, it wasn't very easy to see in Sebastian Nerdick's earlier talk. This is a cut up of a screenshot of the actual execution of our tool. So we have on the left here a simple passage from Shiva Sutras in Sanskrit, and then we have on this the morphological analysis and translation on the right. And this is what I wish I had 50 years ago, when I first tried to learn Sanskrit, I could have put Nal and Damayanti aside and really studied something I was interested in. So just to quickly conclude, to kind of give us our own report card in terms of how we're doing in applying Gen AI, what I have here is basically a hierarchy of different techniques for applying large language model technology and Gen AI technology in levels of sophistication. And as simple as our systems are, and I'm happy to go to maybe more detail on this perhaps in the panel, I think we're already with this fine-tuning using relatively sophisticated methods, but there's still more that we can use, in particular the potential for using retrieval augmented systems or RAG systems. I do just want to end by saying what I'm showing here is actually a much more production system that we have done for the Tibetan language, where we have 2 million Tibetan English sentence pairs. And I have to say, from a distance, I'm fascinated. The Tibetan worldwide population is only 6.7 million people, and yet they've been able to preserve pretty much, and preservation of the Dharmic literature has practically no support in their homeland of China. And yet Tibetans have managed to digitize and make online the majority of their literature of 60,000 volumes. And moreover, there are over 300 Tibetans today engaged in gathering training data. So my answer, or my question to the audience is, broadly in the broader community, is, can we do something similar for Sanskrit literature? I was able to catch some of the earlier talks where I'm very happy to see a vision of where we'll see 2 million scans online. That sounds very exciting. I'd also love to see training data of millions of sentences. And I'm posing the same question, or this same challenge, to Vivek Raghavan, the CEO of Sarvam AI, which is something of the evolution of Bhashani. Thank you very much.
Now, I will not ask questions at this point in time. I would now request Parth to present his views.
Amba, I'm having a bit of trouble.
Hello?
Could you hold the microphone a bit closer? Yeah.
Hello, can you hear me now?
I can hear you better now, yes.
Oh, okay. So thank you very much. And now I would invite Partha to present his views. And after all the three panelists present their views, we will have questions from the audience. And then we will have the discussions among ourselves. So Partha, over to you.
Yeah. Thanks, Amba, and thanks for the organizers. Thanks to the organizers for having me. So I don't have any slides, so I can just kind of verbally present maybe my thoughts. Yeah, so I mean, first disclaimer, I mean, I think I beat Kurt on at least one aspect, which is knowledge of Sanskrit, which is zero for me, and it will be hard to, I think, go below that. So please ignore my ignorance here. So, I mean, AI and Sanskrit, I mean, I kind of, maybe we can think of it in two terms. So one is what AI can do for Sanskrit. And I think with the availability of multimodal language models involving say images, text and all, which are kind of, and more progress happening in that direction. So I'm more and more optimistic about those kind of models helping with digitization type of efforts, especially for Sanskrit, which has been a problem. And then also not only on the digitization, but also on the search kind of aspects that that Kurt mentioned. And then also for various types of Sanskrit NLP tasks, where maybe with these kind of language models, we can cut down on the amount of supervision and the annotated data that's needed to achieve certain tasks. So that's kind of what the advancements in LLMs, and in particular multimodal LLMs, can do for Sanskrit and Sanskrit NLP. On the other direction, kind of what can Sanskrit do for AI? So I have been looking at problems of more inclusion, linguistic inclusion in particular in large language models, and how we can make language models work for many languages around the world. So at Google, we have a mission called 1,000 Languages Moonshot, and a lot of the work that we do in the Bangalore, in the India lab is focused on, say, like in the Indian context, how we can maybe scale these language models to 100 plus languages in the Indian context. So one of the things that I'm particularly keen on is, like say, Sanskrit as kind of like a central language for many of the Indic languages. So if you are able to increase, say, more representation of Sanskrit data in these kind of like language models, could it have, like say, some positive transfer effect, not only to do better for Sanskrit, but then also for many of the other low resource languages for which we may not have like as much of data. So that's kind of like positive transfer starting from like pre-training or fine-tuning with Sanskrit data. So it was good to see the work that that Kurt mentioned, and I'd love to know more about that. So I think that's kind of like one other aspect that I'm curious about, of like say how Sanskrit could help with linguistic inclusion in the AI context. Yeah. So I think I'll stop here and look forward to discussing more in the rest of the panel. Thanks.
Thank you, Parth, for very insightful suggestions regarding Sanskrit, use of Sanskrit for AI. And
but we can, at least I can barely hear you.
Can you hear me now? Is it okay?
Just barely. If there's got to be a way to improve your microphone situation.
Hello, can you hear me now? Is it okay?
Just barely, but I guess that's the situation.
Okay. So, Parth, thank you very much for your comments, both the use of LLMs for Sanskrit as well as use of Sanskrit for AI in general for Indian languages. And we will come back to you. And now I would invite Dr. Pawan to present his views.
Right, am I audible? Yeah. So hi Kurt, hi Partha, good to see you online. Yeah. I hope you can hear me. So thanks for giving the intro about Gen AI to the audience. So I prepared more generically about AI and Sanskrit, and actually Partha already mentioned another view. I had two views about it. What we can do using AI for Sanskrit, and what can AI do for Sanskrit? I mean, what can Sanskrit do for AI? So I also had thoughts on both the directions. And going about from the research papers, I think one of the first papers that we saw was from Rick Briggs on how Sanskrit can be used for AI. That was more like the meta language of Nyaya can be used for knowledge implementation for the text, and this can be a very good technique for AI. But now going about what can AI do for Sanskrit. So over the last few years, right? I remember my time as a student, I was always looking for some data on which we can build some models. And with the help of Oliver Helbig, for example, we got this data. We started working on problems related to analysis of Sanskrit. So we had worked on problems on segmentation, dependency parsing, compound analysis. There were simple works like metrical analysis, anaphora. So a lot of institutes, had developed data on dependency parsing and all, especially Professor Ambakul Kulkarni's institute, and many other institutes had done work on that. So a lot of work had gone on synthesis, on the analysis part of Sanskrit. But not so much effort was put on the generation part. So that's where Kurt mentioned about the translation work, where Gen AI, ChatGPT is coming to. So I won't touch on that point because Kurt has very nicely mentioned about the work in the promise. But in general, when we talk about Gen AI, what are the sort of benchmarks that we can put? Like where, as a community, we can see going forward in next 10 years, where would we like the tools to be? Like, can I say that I can have a tool that can generate poetry given the context? I can give the context and can generate poetry. And I was hearing a lot of interesting talks today on identifying alankaras in poetry. But can I say I want to generate poetry with certain rasa, certain alankara, given the context? as the input. Now that would be something like a very nice challenge for the system. Similarly, can we have generative AI on also producing the speech sound, the text-to-speech Sanskrit, especially when you have Vedic chanting and other sort of different levels of generating Sanskrit sound. And it can go to all different levels. So as a community, what kind of benchmarks we would like to put like going forward? That would be nice to see where the current tools are and what is needed so that we can say, right? So they are at a level where they can address some problems of Sanskrit. Like being in the conference here, I'm able to hear talks from a lot of Sanskrit scholars, and it's always humbling, like as an AI person, like we are nowhere near to what the knowledge is there in the Shastra, in the Sanskrit literature. At what point AI would actually be, at a point can compete, I don't know whether it can compete, but at least can assist in certain way, maybe in pedagogy and other fields. So going forward, let me just conclude. So I would like to see, for example, we identify certain domains, right? So one part is identifying domains, maybe education and healthcare, Ayurveda is what I have seen where tools can be used, and also seeing some sort of nice challenges for us going forward. And from what we started for using Sanskrit for AI, I think it would be nice if we can find problems in AI where Sanskrit can contribute. Right? That would actually be a nice service. Like, what are the problems in the current AI where Sanskrit can contribute? And Partha already mentioned about one such problem. Also problem about interpretability, because all the literature is full of interpretations. So how do we bring out interpretability in the NLP research and beyond? So that's my few points on the matter. Thanks.
Thank you, Pawan. And now, anybody from the audience would like to add to this? Yes.
Just what Dr. Pawan was saying, just to add one point here, I think the ethical problem which is coming up from the AI is also a field where Sanskrit can be a great field to give insights in handling that particular field. So I don't know, can it be a AI-related problem where Sanskrit can contribute something?
You are asking a question to the panelists. So there is a question for the panelists, whether AI can help in problems related to the Sanskrit can help in AI for problems related to ethics. So maybe Pawan.
Yeah, I just attended a session on ethical and responsible AI at Google that Partha had given. So yeah, I mean, this is a very interesting challenge. How do you handle ethics? Because the language models are not aware of the cultural context, and they actually can, so when we use language models, there are a lot of issues. While how Sanskrit can actually help in that. So right now, the very popular terms that is being used in the community is model alignment. That how do we align the model to certain specific cultural context, certain specific user base. So how do we make sure that the outputs align to certain specific principles that we have elaborated? And good thing about Sanskrit is that all these principles are written, right? So we have principles in Nyaya, Mimamsa, and Vyakarana, and so many different traditions are there. So all these principles, how do we encode them so that we can make language models align to them? Would be very, very interesting and challenging research problems. And I think Sanskrit can really contribute, is my feeling. Thank you.
Any other questions from? Yes.
This is a question to Dr. Partha. I know that you've been working on knowledge graphs, and one possibility that can be explored is in the Sanskrit corpus. there is a significant amount of, mostly we depend on the experts, the Shastris' knowledge of the text and the commentaries that exist today to understand a corpus. But can AI help generate knowledge graphs from these corpus texts that can reveal new knowledge, new interrelationships? For instance, Shrikant Talageri, studied Rigveda from a very material dimension and established a pattern of, geographic references that then kind of suggested something else. Of course, international scholars have not accepted his theory, but at least there is a strong hypothesis. He showed that, geography references and animal references, etc., there is a consistent movement from in a different direction. So that actually, it was a manual effort. If it had been a corpus AI studying, that kind of a pattern could have been identified much faster. Like that, there could be several other patterns that then we can experts can further investigate manually. Is that possible? Is that worth exploring?
Yeah. So again, like the audio was not super clear, so it was kind of like becoming faded. But let me kind of like repeat the question, and then please let me know if that's not correct. I think like the question was about whether AI could help with creation of knowledge graphs, especially like Sanskrit knowledge graphs, which could then help with like some kind of like pattern discovery. That like the scholars could take up.
Right.
Yeah, so I think that's a very interesting question, and I have also spent like quite a bit of time in the past on like building knowledge graphs and working with them. I continue to be quite interested in them. So I mean, I think it depends on to a large extent. I mean, first of all, I think like whether you can build it. Yes, I mean, I think like with all of these like say language models and all the quality of like say doing like an extraction of knowledge and all of those things have improved compared to in the past, right? But then there will always be kind of like errors that are going to be there. So it's going to be for the end use cases that you have, how much of like error tolerance you are going to have. I mean, even though things have improved, but it's not going to be like perfect. So if like the users who are consuming that type of like say knowledge structure, if they are aware of that and they are like experts themselves, they can kind of like handle with that noise, I think that's okay. But then like but if they like trust it completely, then I think there are going to be issues. And that's true for both like from these like automatically constructed knowledge graphs, and if you do some sort of like question answering on top of that, and then also like large language models which are going to have like say hallucination properties. So I think like if you're trying to kind of like have some sort of like question answering or like satisfy information needs, then I think like the possibility of encoding this knowledge which is there in your corpus, both in the parameters of your language model or kind of like building some structured knowledge repository and then working on top of that, I think both of those are like possible. But then like if you need like maybe like interpretability, some verifiability, then I think having those kind of structures once they have been vetted and verified will be kind of can give you some additional advantage. So but if you want to just like satisfy some informational queries from that corpus, modulo like hallucination and verification, maybe the language models can also do that job, right? So I think it's going to depend on kind of like what your end use case is, and that way maybe one way or the other or some combination of the two might like make sense.
Yeah, I might just add. I mean, knowledge graphs are just kind of one particular angle by which we might extract information or wisdom even from these large corpora of Sanskrit literature. I mean, there's lots of opportunities for intertextuality, semantic search, and so forth. And I think the the great power of these is, we heard just moments ago, a real pandit, with a tremendous command of a broad range of Sanskrit literature. And yet, those of us who've been working with computer tools for some time know how quickly the computer can astonish us with its basically command of all the literature, command in some sort, command to some degree. So I think there's plenty of reason to be optimistic that there's some pleasant surprises awaiting for us as we get more and more tools for mining this knowledge and wisdom from these texts.
Yeah, thank you both, Kurt and Partha. And here is one more.
Yeah, so thank you again. So I have one question. See, so can you hear me? Can you hear me well?
Yeah.
Okay. So one concern is that the divide between rule-based systems and the current AI-based system. So Sanskrit is traditionally known to be extremely rule-based. Almost all the tools, etc., that we see right now there are rules in the Sanskrit text that have been codified, that have been programmed, right? And the current AI trends, at least, is that you take a corpus without any rules and you make some models out of it. So the question that I'm asking all the three panelists is that how can we get a happy marriage of both of this? So we have these large language models that can utilize the vastness of a corpus, but we also have these very rich rule-based systems in Sanskrit. So can we use both of them in a system? Yeah.
So maybe Partha, you may start with.
Yeah, sure. Yeah, so I think like, I mean, like right now, I think like a lot of the main recipe is like, data driven, and especially like when you don't have the data, I think like the rule and the linguistic knowledge is, I think, going to be quite useful. Now, one way to do that could be that like, I mean, if you have like some sort of like a generative grammar, if you kind of like just want to use the same recipe, then maybe utilizing those grammars, you can like generate corpus, which is the data, and then train your model on that like generated synthetic data, which hopefully like improves capability in like processing that language. But then like very recently, yesterday, like this Gemini 1.5 Pro, and then like there's a particular example there. That's why I'm mentioning that, which has like this extended like context window of like 1 million. So where some of my colleagues like took this like grammar book from the Kalamang language, which I think like is spoken by less than like 200 people, and so that there is no corpus available for that, right? So now when because of that long context window, they were now able to provide that whole book on grammar on the Kalamang language as kind of like a context, and then kind of like did like machine translation from EN to that language and then other direction, and then they saw improvement in performance, right? So I think that's kind of like a very nice way of like still utilizing the strong capabilities of these models, but then also finding a way to like incorporate kind of like the linguistic knowledge which is present for these languages, right? And that has been enabled because of like the long context window that could happen. So I think that's I think there is a lot more to be done in that direction. I'm kind of like excited about that direction. But beyond that, I think like all of the work on like neurosymbolic learning is there, where you like have this additional external knowledge, how you could incorporate that. I mean, but I think that's like an open research question.
Okay, thank you.
Yeah, I think that almost anyone who comes from a rigorous background in any kind of grammatical understanding is disappointed at the extent to which modern systems somehow get by without using them. But over time, I began to wonder if this bug isn't something of a feature. I think for Sanskrit purists, there might not seem to be an advantage. And yet I think that we will see that as we get a larger and larger corpora, we'll be able to get transfer learning into Sanskrit variants of Prakrit, Apabhramsha, Asha, Buddhist Sanskrit, and so forth, and be pleasantly surprised by the ability for a single system to move across these languages in a way that humans, I think, would be challenged by.
Yeah, I mean, thanks. Already Partha and Kurt had mentioned the main points. So I had the same thing in mind that, for example, what can be done. So now that the systems can take a large context.
I think we're having a lot of trouble with the audio. I think people who put the microphone right directly up to their mouth, we can hear it easily. If you turn your head or so forth.
Yeah, I hope that is better. I hope that is better.
A bit.
No.
Yeah.
Okay. Sure. Yeah, I was just mentioning that now that the tools can have a large context, of course we can try and put all the possible rules inside the context itself while we are trying to actually do the task. That's actually a very expensive process though. I mean, putting all the rules and trying to generate things, but that's one way of doing things. But I mean, in long terms, of course, we may need some change in the way these models are being trained. For example, the way they are being trained is very, very specific process of gradient descent. I mean, a lot of parameters learning, but can a different learning paradigm be thought that is similar to how we are learning, right? I mean, in terms of getting feedback from the rules directly in the learning process rather than doing it at the end. So this is something a long shot. I mean, so I really don't have much idea on this, but I think something has to change even in the learning paradigm of these models, is what I feel. Thanks.
And here is a last question by Shankar Raman.
Namaste. I hope you're able to hear me. I just have some thoughts that I have been thinking about with AI for some time and Samskrita. Samskrita, as yesterday Google Translate, she was showing with various senses of a same word, and such things are very unique to Sanskrit as a language and its derivative languages. And even with Marx's and the dictionary that we have. The point here is the way AI is training models is very computationally intensive, that it uses so much resources, and a normal person would not be able to train it. It would only be companies like OpenAI or Microsoft would be able to train large language models. Can we use the inherent beauty of Sanskritam to change the, for example, in English we use word to vec or some kind of, those kind of models to actually encode the words or language. Can we use Sanskritam to encode words better or give the senses better, such that the computational intensivity of training, of processing, of storage, and all this can be changed, and therefore AI models can also become edge models? Can the inherent beauty of Sanskritam be used to help AI become less computationally intensive? So this is a very moonshot kind of idea, but can it be thought of in this manner is what I wanted to ask.
Yeah, well, first I'd like to respond that, it's certainly true that these very large models used in Gemini and ChatGPT and so forth are far beyond what any even computer science department in the country can approach, much less the Sanskrit department, for example. But fine tuning these models, which I went through quickly in my presentation, really is within our reach, and it'll become more and more within the reach. So I don't mean this is somewhat orthogonal to your question, but I wouldn't immediately put the fine tuning of Sanskrit in particular and think that that's something that's only reserved for some sort of specialist or something. But more directly addressing your question, I have to say I have a lot of sympathy and kind of it reminds me of the desire for determinism when we face quantum mechanics. Everyone kept wanting to see some deterministic. I mean, I share the sense that with all this beauty that has been packed into years of study of Sanskrit and the canonization, Panini, and so forth, there's got to be some way to use it. But we just haven't seen it yet. But I would just add one more thing, is that I do think that with some additional kind of context and prompting, Partha just mentioned larger context windows and so forth. I think we can begin to incorporate more specialized context to allow for more nuanced interpretation of Sanskrit. So I do. I know you were trying to wrap up, but before we wrap up, I had just a couple quick questions from my fellow panelists that I can wait or ask now if.
Maybe Partha and Pavan may respond. No, it's okay. Partha, would you like to respond to Shankar Ramanan's? Would you like to respond to Shankar Ramanan's question? Or comment?
No, yeah, I think it has been covered already.
Okay,
So
fine,
yeah, I share
fine.
kind of like similar
Okay.
views.
So Kurt, you can go ahead. Hello. Yeah,
Amma,
you
did
can
you
go
say
ahead.
go
Kurt.
ahead?
Yeah.
So,
please.
well, maybe so Partha, it was such a pleasure to see you here. I think we, as you know, we corresponded quite a while ago. I'm going to put you on the spot here a little bit. I hope you'll excuse me, but I'm still curious as to just what kind of priority Sanskrit is for Google. I know you're trying to do very broad. It's a laudable effort to cover very broadly languages. I think you're over 400 languages now. But then the depth in any particular language, of course, varies a lot. So in the grand stack of say 400 languages, where would you put Sanskrit for Google?
Yeah, so I don't know whether I mean, I know or like in a position to share kind of like Google's view, but I can maybe put forward what my viewpoint is. I mean, one is that I mean, Sanskrit, as I was kind of mentioning in my earlier comments, kind of like exploring more on Sanskrit as like a maybe some kind of like a language which increases the bridge properties of cross-lingual transfer across languages in language models. That's one thing I'm kind of interested in. So kind of like that type of pre-training and fine-tuning that you are doing with the Sanskrit corpus. What is the effect of doing that on other languages? So just to improve say still the language model capabilities, but as a positive transfer agent for other languages. I think that's that may have a special status. But beyond Sanskrit as yet another language, I think given the cultural importance of Sanskrit as a language, being able to do well for that language, I mean, given kind of the vast literature that's there. And there is kind of Google Arts and Culture initiatives through which we want to do well for the languages and culture. So I think that way there is more increased importance for it just compared to any other language.
That's great to hear. Thank you.
Yeah, and there are many passionate people we have also been part of discussions who are interested in kind of making the manuscripts and literature available online and make it easier for people to get access to.
Right.
Thank you. So we are now almost at the end of this panel discussion session, which was delayed by almost an hour, and you had to wait. I would like to mention 2-3 things. As an answer to Professor Arnav Bhattacharya regarding the rule-based and the use of AI, what I would like to mention here is, see, in AI we have, well, I'm using very old terminology, strong AI versus the weak AI. What we are here aiming is at the weak AI, not the strong AI. So when we learn a language as a human being also, we are not taught the grammar in the beginning. We have the observations, we learn language through observations, and then later on we are taught the grammar. And here, in that sense, what Professor Kurt Koezer's team is doing is something very important. They are using the translations where they are looking at, they are using it, the observations are there, the large language model is providing the translation, and at the same time, time, you are also providing the grammatical information, which is very crucial to ensure that the translation that is being produced is authentic. And this is what we are also taught when we learn the language. We have the observations, we have the grammar, and grammar is used to see that what we have understood is correct. So in that sense, a marriage of the two systems is already happening in the demonstration that we have seen in the morning by Sebastian. Then, as a response to Partha related to Sanskrit, use of Sanskrit to AI, you have rightly pointed out that Sanskrit, if we take as a pivot language, then for all Indian languages, the translation among Indian languages will be very efficient one, which will have a better quality. The reason being, the languages, as we know, they divide the conceptual space in different ways. So English will divide from the lexical point of view, I'm saying. Lexically, you divide the conceptual space in different ways. The different languages divide the space in different ways, and all Indian languages which have strong affinity towards Sanskrit will have a similar kind of division, whereas English, though it belongs to English and Sanskrit belong to Indo-Aryan languages, there are differences at the lexical level. The way the conceptual space is divided has a lot of divergences are there, and therefore definitely if you take Sanskrit or Hindi as a pivot language and develop the systems for translations rather than taking English as a pivot language, definitely you will have a better system. And finally, Pawan has raised very important point related to the generative AI. Can this generative AI provide us, can they generate poetries which can give a specific rasa, which can generate specific rasas, or they have different alankaras, etc. We provide inputs such as, yes, I want a poetry in this particular alankara, and machine produces it. Is it possible? And these are certain things which are still not, I mean, people are not exploring these things at this time in larger scale. Most of us are more interested in the translation systems, information retrieval, and knowledge representation. So, but this is something definitely is going to be challenging, because it's Sanskrit which has such beautiful properties. The other languages, I have not seen any other language, at least English or even the modern Indian languages, they do not have this kind of beauty which Sanskrit has. And there definitely you will have to have something else. I do not know, I don't have any answer for this. So, so thank you very much for being with us. And if you have any last comments, last words to say.
Yeah. So, Ambai, thanks. I mean, I just have like one last maybe comment. So yeah, so we are working on like preparing like a benchmark for generation tasks for many Indian languages, so that like, you know, we can evaluate like LLMs on those tasks, and Sanskrit is one of them. And we hope to like share more details on that. So it'll be great to share that with the community, and then people can, I think, like build and evaluate their models on top of that.
Okay, thank you.
Thanks again for having me here.
Yeah, thank you, Kurt.
Yeah, just a quick response to that. Yeah, clearly, because of the freedom of word order in Sanskrit, I think that the evaluation of translations is going to be, harder than other languages, and definitely will push us to some new methods. So I'm looking forward to that. I did want to just end with a call for data. And those of you who want to join us in building a corpora of sentence pairs and gathering together all translated Sanskrit and pairing it up with its original, please, I'm not hard to find. I hope you'll reach out to me.
Yeah, we will discuss this later. Thank you very much. And thanks a lot.
Thank you.
Okay, thank you very much, Partha and Kurt, and Pavan and Amba for chairing. So we've got I'm sure you're all very, very hungry. So we're doing the gala dinner. We've had a change of plan. We've decided to feed you and then music you. We have two very esteemed musicians that will be joining us. Professor Kim Kunio, who is the Dean of Music. Welcome, Secretary of Auroville Foundation, Jayanti Ravi. Thank you for joining us, and her husband. So we have Professor Kim Kunio and Heather Lee, who will be, I know you're very hungry, and it's been a long day with many delays. So we're going to be having a concert, and the brief for the music was basically to do the marriage of Sanskrit and technology. And I could not think of any musicians more suited for this task. Kim Kunio has been around the world recording sounds, and he has been streamed hundreds of millions of times. He's also the dean, ironically, of the university where I did my postgraduate studies in Sanskrit with McComas Taylor, professor of Sanskrit at ANU, and this, by coincidence, happens to be his university. And Heather Lee is his wife. She's a renowned singer. She has sung for the Prime Minister of India on demand. And both of them are people that when I was thinking one day of doing something for music in Auroville, because music is one of my very deep passions, and I know for Dr. Ravi it's a very deep passion. And I kept thinking of them, and interestingly, they love Auroville. So even though we're talking about Sanskrit, music is another language, and it's a language that transforms lives, and it can create a new direction. So we're going to break into dinner. We'll have 45 minutes. It's a gala dinner tonight. It's prepared by the Visitor Center in Auroville. It's all organic. It's mostly grown around on the Auroville farms, the rice and many of the dishes. And so we're going to invert the program. We're going to do the dinner, and there's dessert. And we'll have 45 minutes while the musicians do a sound check and set up. And then we will be starting the concert. So what is the time right now? Can I get 8? So 8:45, we'll be back here for Kim Kunio and Heather Lee for the concert. Thank you very much. Thank you for being here with us. Hello. Namaste.